Welcome to this course of AI, machine learning, data science, and big data analytics. I'm really excited to guide you through this journey, where we'll explore with preparing AI and machine learning models and working with large datasets for analysis and scientific or advanced cases. Whether you're a beginner or looking to sharpen your skills, this course is designed to help you step by step. In this course, you will learn Introduction to AI, Machine Learning, Data Science, Big Data, and Data-Driven Decisions, Introduction to Python and Variables, Data Types and Operators, Conditional Statements and Loops, Functions and List, Tuple, and Dictionaries, File Handling, OOP Basics, Virtual Environments, and Package Management, Introduction to NumPy with NumPy arrays and operations, Introduction to Pandas and data frames, Load, Clean, and Transform, Handling missing values, Data merging, grouping, and aggregation, Exploratory data analysis, which is EDA, and data visualization with Matplotlib, Advanced visualization with Seaborn and feature engineering and pre-processing, Descriptive statistics and probability basics, distribution, normal, Poisson, or binomial and hypothesis testing, correlation and covariance, and linear algebra for machine learning. By the end of this course, you'll be able to gain an understanding of the fundamental ideas behind AI, machine learning, big data science, and big data analysis and process of making decisions based on data. You'll be able to use variables, data types, and operators to write simple Python codes. You can use loops and conditionals, expressions, to manage the program's flow. You can create reusable functions and use dictionaries, lists, and tuples to manage the data. You can also manage environments and packages, handle files, and use basic OOP. You can utilize NumPy arrays to do quick numerical calculation. You can use data frames to load, clean, and transform your dataset. You can combine groups and aggregate datasets and deal with the missing data. You will also be able to use Matplotlib to explore datasets and illustrate the insights. You can prepare data for machine learning models and produce sophisticated statistical visualization. You will also learn how to use basic probability concept with descriptive statistics, comprehend the probability distributions, and carry out fundamental hypothesis testing. And the end is you can calculate correlation between variables and use fundamental linear algebra for machine learning. This course is structured video lectures with projects, so I encourage you to take notes, complete the project exercises, and practice consistently. I'm excited for you to start this journey. So let's dive in and let's get started with this course. Welcome to a new course of AI, machine learning, data science, and big data analytics. So as the first class of this course, we're going to introduce you to AI, machine learning, data science, big data, and data-driven decisions. Before getting into the hands-on progress or the process of this class, we have to know the overview of this class. So, starting off, what is artificial intelligence or AI? The branch of computer science known as artificial intelligence teaches robots to think, learn, and carry out tasks that typically require human intelligence. Now, what are the examples of AI? There are various examples and a vast in this modern era. So some of the suggested are Google Maps route recommendations, suggestions for YouTube and Netflix, on phones, face unlock, chatbots, autonomous vehicles, and voice assistant such as Alexa, Siri, and there are so much more right now. Now, even though there are examples of AI also has a specific subfield. Now, they are basically composed of four parts. Those are machine learning, deep learning, natural language processing, and computer vision. So all of them together combines up and creates the AI subfield. Now, let's move on to the real world AI application. Now, there are various and almost all the industries which are growing every day uses AI, such as in healthcare, MRI images analysis, disease prediction, and so more is done just by using AI. For money, stock forecasting, and fraud detection. For retailing, prediction, consumer behavior. In learning, there is learning analytics and automated grading. For transport, there is autonomous vehicles and route optimization. And for promoting, there is recommendation engines and targeted advertisement, which basically help you to promote even, let's say, people and also products at the same time. Now, what is data science? The study of gathering, cleaning, analyzing, and displaying data in order to obtain insightful information is known as data science. Now, data science is not much different than AI because the data that is used to create AI or program the AI comes from the data science. Now, data science also has a specific workflow, such as getting information, pure data, examine, image, create models, which is ML, which works in machine learning, and even make choices. So all of these combine up and create the workflow of data science. Now, let's check out the differences of DS, which is data science, ML, machine learning, and AI, artificial intelligence. Now, I have differentiated the terms and the meaning of these, so it will be easier for you to understand. Such as AI basically works with big idea, which involves machine behave, and also the intelligence. Now there is ML, which is machine learning, which utilizes the data to teach the machines the exact behavior and the response it should give it to the user. Then there is deep learning, which is basically the neural network for machine learning. And then we have the data science, which utilizes data to gain the understanding from the users and respond correctly. Now, machine learning versus deep learning versus data science. Now, I'm going to go more into the vast description and the extended explanation about them, so make sure not to skip any part about this. First off, we're going to start off with the machine learning. Now, machine learning uses algorithms such as these forms of data to learn, which are regression in linear form, which is going to be a bit complicated if you have no prior experience with programming languages. There is trees of decision, which basically works with conditions and even loops to make sure that it gives out the exact criteria and the exact result what the user expects. Then there is KNN, which I'll be getting more further into this course. And then there is the random forest, which is also a module mostly used by Python, but I'm also going to get in through those after we start our practical classes. Then there is deep learning. So for deep learning, there is a neural network, or deep learning is mainly the neural network which machine learning uses. So it is basically modeled after the human brain and also used in DL, or deep learning. Now, these are basically utilized in identification of faces, translation of languages, and autonomous vehicles, which are very much, visible in our modern era, such as we have Face IDs on our phone, we have Touch IDs, and there are a lot of softwares which basically help you to translate language. And obviously, we also see nowadays there is autonomous vehicles which are already running in a lot of regions. Now, the last one is basically the data science. Now, what is data science? So basically, everything pertaining to data and decision is basically known as data science. So there are some basic comparative analysis of all of these three terms. So the definition of data science is to study the data and understand what is actually happening. Now, this mainly helps you in a couple of cases, such as prediction and maybe even getting the outcome, or a lot of cases. And machine learning basically makes predictions based on data. So everything is intertwined and linked together to give you out the exact type of results. And on the other hand, we have the deep learning, which is basically the ability to use huge data plus neural networks to make advanced predictions. Okay, so among them we have gotten the explanation of all of these, but what is the big data? So there are large and complicated data sets that are beyond the capabilities of conventional technologies, are referred to as big data. So you will also find out a couple of data like them in Excel or CSV, which I'm going to be working with in this class, which is going to basically give you a clear and a vivid idea about how it is possible and how you're going to make sure to work along with it. Now, what are the characteristics of a big data? Now, in volume, it has enormous amount of data. In velocity, there could be data speed, which you should be working with. There should be specific coordination, which you will be working with, and all of them are going to be float data or integer data, but on the basis of the text. Then there is a variety, such as text, audio, and photos. So it's not like any specific type of data that you will have to work with, but there could be a vast amount of data. There could be even different types of formats. There could be different type of extensions, and everything is termed in cases of this big data. Now, there is also accuracy and veracity, which is basically going to help you to find out the exact point and exact coordinates of specific type of data which the user is expecting. And there is the value, which is practical knowledge. Now, nothing can be done without, knowing and without any experience. So I'm going to guide you through the whole process. And if you're facing any problem, feel free to ask me anytime. I will guide you through the whole thing. Just one thing I would suggest you is make sure not to skip anything, because if you do, you might miss on something very important and later on face, a couple of errors. Now, where is the big data used? Now, most big data are used for analytics, for social media, or even different web pages. Then there is financial transactions. There is e-commerce practices. There are smartwatches for health monitoring, and also logs of telecom calls. So all of these combined basically is used by big data. Okay. Now, what is data-driven decision making? So making any decisions based on facts rather than conjectures are known as data-driven decision making. Now, what are the examples of those? Such as, whenever you are using Netflix, it uses a type of audience data to choose which shows to develop, such as there are ratings, there are comments, and so much more. And it also tracks down in specific regions that what is basically trending. It basically helps you and the user to get what is basically, good and what is bad. So data-driven decision making is very useful in these cases. Then we have is the product suggestions, which are made by Amazon. Now, we already know that Amazon is the biggest and the largest product consuming online website. So you can use that and you will get an idea about how the suggestions and recommendations come to your page. Then there are banks that use risk prediction to determine whether to approve loans or not. So obviously each and every one of these people which are trying to get loans in banks have a specific analytic, which basically helps you to overcome and also determine that if the person can take the loan or not. And it also determines how much can the person take the loan, and also based on the EMIs and so on. So all of these together basically gives you an overview about this course and what is basically AI. There is artificial intelligence, there is data science, machine learning, deep learning, and even big data. So hope you understood about everything in this presentation that I have given you. Now I'm going to show you also the process of how you're going to set up your device so that you can keep on working with it, and how you're going to progress with work in this course. And make sure to follow through, because there are going to be some, complex parts which you need to follow through and use the exact same methods that I use. Okay. So without any further ado, first off, open up any of, your web browser which you have on your device. It doesn't matter whichever it is, but I would suggest you that to use any Chromium based browser, which is basically going to help you to get indulged into more of the functionalities that we're going to use and show in this class. So let's just open up our browser. So as you can see that I have opened up Google, and I'm also using the Arc browser. You can use like Mozilla, or maybe even use Microsoft Edge or Chrome, whichever you prefer. Now, the first thing that you want to install on your device is going to be Python, which is going to be helping us throughout the whole course. So type in download or search for download Python. And I would suggest you not to install, Python from any third-party web pages. Instead, just go off to python.org, click on the first link, and click on the latest version of, whichever meets up your, OS. Now, as I'm using Windows, you can use like, Linux, Mac OS, Android, or whichever you are using. Make sure to click on them so it works perfect on your device. Now, if you are on Windows just like me, just click on this download Python manager, or you can also install just Python, which is going to run perfectly on your device. So just click on that and it will start installing. You can see this is like downloading, and it's going to take just a bit of time. Now, after this is done, you also want to download any IDE, such as you can use VS Code, which already comes, by default with Windows nowadays. But I'm going to be using PyCharm, which is like completely based and made specifically for Python project. So here I'm going to download PyCharm. Now, if you don't have any prior experience with PyCharm, it is completely fine. You have to find out whichever IDE is comfortable for you. Now, I'm using PyCharm because I've been using PyCharm for a long time. Now, if you have like prior experience with PyCharm, is that you will see, or you have seen, that there were two of these type of PyCharm. One was the community edition and one was professional. Now, if you're still or if you get back, or if you're back to Python or PyCharm after a really long time, then you will see, or you will search for the community edition, which is totally free. But now what PyCharm did is that they created this unified product, which is going to be free, and it is also going to give you a pro trial for a month. So download this unified product and install the one which basically is suitable for your device. Now, if you have the newest hardware which is available right now, which is basically ARM64, then download the ARM64. But if you are on the older hardware, then click on EXE Windows. If you're using any different type of OS, all of them are available over here for Linux and also for Mac OS. And just click on install or EXE download. Now you will see that it will also start installing in just a bit of time. There you go. And after this will be done, what you want to do is make sure to install Python first and then install PyCharm. Now you can see that I have opened up PyCharm. Now another thing that I'm going to show you is that whenever you are installing PyCharm and also Python, make sure you add it to the path so that Python is detected on every project that you create. Now, even if you did not do that process, then I'm going to show you. Just open up your Windows and search for variable. Okay. So click on edit system variable. So in this way, this type of platform will open up on your screen, and click on environment variable. And you will see over here on path, there's going to be this script. Okay. Now, how are you going to make sure that this is the exact script? So search for Python again on your device. Okay. Now open up file location and right click over here, click on properties, and over here you will find out the exact location. Okay. And you will see that even if you click or select this whole thing, Control C, cut this off, this is the exact same location. Now, if you do not have this path, just click on edit, click on this over here, click on edit again, and paste the exact location and press on OK. In this way, Python will be detected on your device and you don't even have to do anything. Okay, press on OK and then you're good to go. But make sure to install Python first and then install PyCharm. Okay, now if you don't have any, prior experience with PyCharm, you can see this is the project panel. We have the customization panel. We have the plugins over here. And at the end, we have learn. So you can learn from their, like community. And it is a totally active community. You will be able to get any Gits or whatever you need to learn. Okay. Now, if you have like previous Python project, everything will appear over here. You can search for them, or you can open them up anytime you want to from any type of directory. Okay. Now, the next part is creating a project. Now here, I'm going to name a project, let's say AI course intro. Now you will see that it is detected in my device. Also 3.14 is also detected, but I most of the time prefer using 3.12 because that is the most stable version. Now the next thing that you want to do is inherit the package and make available to all the project. Another thing that you have to keep in mind is click on custom environment and make sure to click on virtual environment, and in environment click on generate new. In this way, the virtual environment is going to be created every time you create a new project. Then press on create and wait for a bit. So after you create your project, this is exactly how it will appear up, totally clean. Now, there was another option of creating a welcome page. I would suggest you not to use that because that just creates an extra page and that is completely unnecessary. Now, the first thing that you want to know about is that this is the terminal. Now, if you want to install any new module, you install it through here. But you can also install it through the interpreter settings. Go down and click on interpreter settings, and from here you'll be able to install new packages or whatever package that you need. Okay, you can also update the versions of those packages, which is going to basically help you with a lot of bug fixes. Now, as we're going to be working with a vast amount of data and data analytics, there is a specific module completely popular and the most used, which is pandas. So here, type in import pandas as PD. Hit on enter and wait for a bit. Now you will see that the import is not like working over here. So here, type in pip install pandas. Now wait for a bit. If you already have pip installed, then it is going to install the latest version of pandas and also pip available for you, which you can use. Okay, just wait for a couple of seconds and make sure you have a stable internet connection, which is going to basically help you to install and download whatever file that is needed from the web. Okay, so after a couple of time, you will see that it will be done. So wait for a bit and let me just skip to the part where it is completely done. So you will see over here that now Python is updated, or pip is updated, and also pandas is updated on your device. Now, just like I said at the beginning that we're going to be working with Excel files and also CSV files. So the first thing that you want to do over here on the venv, create a Python file just like this. Here I'm going to put in intro. Now click on enter and you will see an extension will be created, which is .py, which basically indicates a Python file. Now another thing that I'm going to create over here is click on file. Here I'm going to have the dataset.csv. So we have the CSV file. You can see that CSV files are supported by PyCharm Professional. I'm just going to click on dismiss. I'm going to click on install the plugin, and it is going to search for the plugin which is basically needed for working with CSV files. So wait for a bit as it is searching for the repository, and after a while you will see how it basically works. Now another thing that I'm going to mention is that I have created this class to show it for total beginners so that you can load the data, analyze it, and even get the insights. Okay, so let's get started with this class. There we go. We need all of these. So click on all of these and click on OK. Now you will see over here, every plugin will be installed, but it is going to require internet connection. Okay, so make sure you are connected throughout the whole time. Now let's just skip to the part where all of them is done. So just as you can see that my data set is now looking like this because I have a new module. Okay, So the first thing that you want to do over here is start off with the data. Let's say I'm going to put in username. Then I'm going to put in age. And then I'm going to have in units. Here, I'm going to put in Alan. Then let's say the age of this person is 18 and the units is 88. In the same way, let's just create more data. Let's say Sarah. Here I'm going to put in 32 and unit should be 76. Here I'm going to put in John, 32 or 31. Unit is 89. And let's say I'm going to put in another data over here. Let's say Milo. This person is only 17. And let's say this person got a score of 95. So we have this data over here, which is going to work as the data set. Now you can select all of these and you can turn this into a heading if you prefer. Now, but the first thing that I want to do is I just want to show you how you can use simple data analytics code. Now, I'm not going to be explaining all of these data or all of the things that I'm going to use in this class because this is the introduction. So first off, I'm going to import pandas as PD. Okay, then we're going to load in the data set. So I'm going to put in data equal pd.read_CSV. Now you're going to define which data you want to use, which is basically the dataset. Dataset.csv. Now, as we already have this data, now we want to check that if the data is visible or not. So here I'm going to put in print, which is the most common function of Python. I'm going to put in full data, and then you want to print out the exact same data set by the variable. Now run it and check if the data shows up on your screen or not. As you can see, we have the username, the age, and the units, and all of these data basically match up to this data. Okay, now as we are done like printing out the data, the next thing that I want to do is I want to do some basic statistics, which is going to be inside of data science. So let's say I want to print out a specific value, \n. Let's say I'm going to put in the average unit score. Now, as we want to print out the average unit score, we have to define the data variable. Now, another thing, we have to make sure we use the units. So here, I'm going to put in units. After that, put in .mean, which is going to be the function, which is basically going to average and sum up all of the data that is inside of the units category. Now let's run this again, and you will see the average unit score is 87.0. So that is basically how you're going to do some basic statistics using data science. Now, the next thing that I want to show you is going to be comprised of the machine learning, which is going to be the prediction logic. Now, whenever you are using prediction logic, you have to use functions of Python and also the conditional loop, which is the if, elif, and the else. So first off, let's just define it. Let's say predict unit. So here in this variable, we're going to print out units. Okay? After that, you want to put in the if. Then I'm going to put in if units is greater than 85. Then I want to print out return, let's say distinction. Then if it meets up my criteria of another value, let's say units, if it is greater or equal to 72, or let's say 75, okay? Then this will return as, let's say, passed. And if none of these criterias match up, then it should return as fail. So the last thing that I want to do is I want to print out the data set, which is going to be the variable of units, which is going to be equal to data, let's say units Now over here, we can also put in unit underscore score. After units, put in dot apply. And then I'm going to put in predict unit, which is going to be the variable. Close it off. On the last lines, we want to print out the whole thing, /n. Let's say predicted units. And also, we want to make sure to print out the whole data set. So if you run this, you will see that we have the predicted units. Alan is distinction, Sarah has passed, John and Milo has distinction at the same time. So what it basically does over here is that we're using pandas first, which basically helps us to load and analyze the data, which basically works for data science. Then we have the mean value, which is used over here. This basically gives out the average numerical value or the integer value, and it is used to make specific decisions. Now the decisions are basically made over here in the definition, which is predicting the units. So the predict units and variable units is the basic machine learning logic. So we are not using deep learning, neither we are using, prediction. Okay, even though we are using prediction, we're using the most common and the simple data analytics method. Okay, so yet even though it requires large data sets, so we're just going to ignore deep learning for now. Okay, so by the end of this whole class, what you have learned is what is AI, what are the real world AI examples, what is data science, the difference between ML or machine learning, data learning, and also data science. Then what is basically a big data set? Then we have data-driven decision making, and how are you going to write your first data set just like this. Okay, so what I want you to do is just understand all of these terms, why are they used, how you can put in modules, and how you'll be able to work with these type of data and also these type of works in Python. Okay, you can also create a visual diagram just by using the data sets, but we're going to show them to you later on in this course. So hope you understood about everything in this class, and thank you for watching it up till the very end. So without any further ado, let's hop on to our first practical class of this course of Python, AI, machine learning, deep learning, and data science. Welcome back to our first class of Python, or AI, machine learning, data science, and also deep learning. So this is the first section of our practical classes and also can be termed as our first module, which is Python Foundation required for AI, ML, and DS. This is the introduction to Python and variables, data types, and operators. I have made this class to be very beginner friendly, and I have segmented this class in a couple of parts, and I've given you, or I will show you, with codes and explanations, which is going to give you a clear and a vivid idea about what these are, and also how you'll be able to work with them and how those function in Python. So make sure not to skip any part, as it is going to be very important if you have no prior experience to Python, and this is going to help you throughout the whole project. So without any further ado, first off, let's just open up PyCharm, or if you are using VS Code, then just open it up. As you can see on my screen, I have opened up PyCharm. Now here, I'm going to start off with Python fundamentals. There we go. I'm going to create a custom environment and inherit all of the packages, and I'm going to press on create and wait for it to create the interface. So first off, we need to know what is Python. Now in my first class, or the introduction of this course, we did not explain what is Python. But as this is the fundamental part or the fundamental module about Python, then I'm going to suggest you that you get the idea about it too. So Python is basically a high-level programming language, which is extremely beginner-friendly and is almost close to human language. And the most important part about Python is that it is very versatile. Now, Python is basically used in AI and machine learning, data science, data analytics or big data analytics, automation, web development, and etc. So that is basically Python. Now, why are we going to use Python for AI and data science? So first off, Python has a very simple syntax, which is very easy to cope up with and adapt with. Python also has a large library, such as NumPy, Pandas, which I've shown you in my first class. Then we have TensorFlow, PyTorch, and etc. Then we have like Python basically works well with large data set and its performance is top notch. And in Python, you can debug, and there is fast prototyping facility that is only given in Python. If you have any prior experience with any programming language, you will see that the other programming language takes a bit of time to process and takes a bit of time to prototype or even debug. But in Python, it is super fast and gives you fast response. If there's any problem, it gives you up an error as fast as you run any program. Okay? So according to the topic of our class, which are first off is the variables. Now, which is the first thing that we're going to complete. So what are the variables? A variables is basically a name or a category or let's say a box which is going to store data according to what you want or what you have in mind. So this is kind of like those headers, and then under that is basically the data. So even when you want to sort out data or find in data, you put or search for the heading. In that way, it gives you a fast response to search for the exact type of data that you are looking for. So that is a kind of a variable, okay? But a variable can store different types of data. Now, if you've worked with Excel, you know that in a cell you can put in different types of data. It could be alphabetical, it could be data, it could be integer value, it could be float value, it could be Boolean value, and all of those. Everything that is validated inside of Python, more or let's say extended versions of them work in Python. Now, when you are working with variables, there are specific syntaxes or rules which you need to follow. Now, when you are defining any variable, let's say I'm going to click on new over here, and I'm going to name it variables underscore ex. So when you want to define any variable, you cannot start with a number. You can see when you put in a number, it is already detected as an integer value. Another thing, you cannot put in extra spaces. Let's say my apple. This is not going to work. As you can see, there is a red line. But if you want to put in space, just put in underscore and then type in equal. In that way, you can see that Python did not detect any problem with it. Another thing, when you are naming or creating any type of variable, it is very case sensitive. So if you are naming this like age and you want to print out something like, let's say I'm going to put in print, and if you put in age, this is not going to work because Python is case sensitive. Now, in couple of cases, you can use different type of function to make the program or make the variables less case sensitive or even not case sensitive. But we're going to get through them step by step. Now, another thing that you have to keep in mind is that any variable that you define needs to be meaningful, which means it needs to store specific type of data. Okay? So let's start off with the first example. Let's say age, which is going to be 54. Then we're going to put in username, which is going to be double quotation as this is a string value. My name is Gary. Now, the third thing is my height, which is going to be somewhere around 5, and I'm just going to put in 5.6, okay? So as we have specific variables, let's say the first one is age, second one is the username, and third one is the height. So each and every one of them, as the first one is an integer value, which is the complete number, second one, username, is an alphabetical value, also known as a string value. And the third one, which is height, contains a decimal. So any number that contains a decimal when you are defining your data is known as a float value because that is completely accurate. Okay? Now let's say if I type in print, I'm going to name username. I'm going to print out, let's say age, and I'm also going to print out the height. Now, if I just run the program, you will see the exact type of data will be printed out inside the console. Run it, and you can see inside the console we have Gary, 54, and also .6. If you want to understand any type of data, put in .type. Do the exact same thing and run it, you will see that it is a class string value. If you copy or do the exact same thing, I'm going to put in type. Do the same thing over here. Now you're just going to run the program, and you will see that the integer value opens up and the float value opens up. So this is exactly how you're going to print out any type of data or any type of variables in Python. Okay? Now there are also variable reassignments, such as I have my age to be 54, but what if I want to overlap that value? If I put in the exact same keyword, and let's say my age is now 61. If I run this, let's say I'm going to print it out, age. So you will see instead of 54, which was the first value, it will print out 61, which is the latest value. There we go. Now, in the same way, if you want to do the same thing, let's say I'm going to copy this, paste it, and instead of age, if I put in height and run this, it will print out the height, which was the old one, 5.6. But if I name it to be height, and let's put in, let's say 6.0, and run this program, and you will see it will overlap the value, and the data that you have is basically updated, because Python always uses the latest or most recent value given by the user. Now, you also have to understand about the basic Python data types. Well, in the basic type of data type in Python, mostly or the major ones are only of 4, which is the string value, integer value, float value, and Boolean value. Now here I didn't show you Boolean. Let's say is raining, the variable, and if I put in true, and here if I print out, let's say is raining, run the program, there we go, it shows up true. Now if I put in type and run the program, you will see it will have a class Boolean value. Now this is like this because when you put in true or false inside any data, it turns out to be a Boolean value. Now Boolean values have 2 types of data, which is false, and the next one is basically true. There we go. Now this true and false basically determines the computer language, which is 0 and 1 in binary. So if the value is true, that means it is turned on. And if the value is false, it means the value or the switch is turned off. It also replicates the same way in case of 0 and 1. If it is 0, it is turned off, and if it is 1, it is turned on. Okay? So that is going to be this type of data. Then we have the listed data. Now, how are you going to define the listed data? If I put in list 1 equal, now you don't want to use in quotation or parentheses like this. But when you are defining in a list, we use basically the secondary bracket, or known as the square bracket. Let's say 1, 2, 3. If we want to print this exact thing out, print list 1. Also, print type list 1. Now run the program. You will see that we have this 1, 2, 3, and also class is now a list. Now let's move on to the next one, which is a tuple. Now tuples are mainly immutable type of list, which is basically like it cannot be changed, or it cannot be overlapped, or it cannot be rewritten, even though Python uses the latest version or the latest data of any variable. But in case of tuple, the list or data cannot be changed. So if I put in tuple underscore 1 equal, here for a tuple, we basically use a parentheses. Here we put in 1, comma 2, comma 3. We don't even need any spaces. If I want to print out the data, let's say tuple 1, print out the data with the type tuple 1, print them out, and you can see we have 1, 2, 3, and the class is a tuple. Now the last one, or the last type of data type in Python, is a dictionary, which is basically a key value data. Okay, so here I'm going to define something as dict underscore 1, which is going to be equal to the third bracket. Here, double quotation, let's say name. So the name of me, which I'm going to put over here, is going to be Harry. I'm just going to cut out the space. And what you want to do is you want to print out the value, which is dist1. If you print it out, sometimes it might show you off as an error, but you can see this is working. So let's also try printing out the data type. So put in type dist1. There we go. Run the program, and you will see that it is going to be termed as a dictionary. Okay, so this is basically how you are going to know that what type of data is being used on any specific project. Okay, so as we're done with this, let me show you another example of just a dictionary, because dictionary can hold a large amount of data, such as, let's say I'm going to put in pupils. Pupil equal third bracket. Now here, I'm going to put in the code name. Code name of any specific person is going to be 009. Put in a comma after each category of data. The age of this person is going to be, let's say, 23, comma. Go off to the next category of data. Let's say the department of this pupil. Here, let's say this person is in Python. Python AI. So you are done with this, and on the last line, you don't even need to put in any comma. So here, first off, let's type in print, and the first one is going to be the pupil that I want to print out. And I want to basically get the data of their code. Also, if I want to get their age, I'm going to put in the exact same variable, and I'm going to define the age. If I run this, you will see the pupil is going to be 009, and also 23 to be that person's specific age. So now we get into the part that why are data types important in AI and machine learning. It is because there are different types of models in Python, or even machine learning and AI. Now, these type of models only work in data types which are completely correct. And sometimes they even need conversion of data, such as string to numbers, or numbers to floats, or even floats to strings, or number to strings. And these type of data sets contain mixed type of data. Now, sometimes when you are defining them in Python, it cannot be detected like properly and exactly at the same time. But in Excel, when you define it, there are specific functions to overlap any specific type of data set that is not needed, and in those cases, it is ignored in the function. Okay, so in Python, there are also specific type of data which cannot be run in all times or in all functions. Even though Python has those type of functions, in Python you have to define each value. And if those data types are not validated, you need to convert them so that all of them are validated, or so Python can understand, as this is the default, like, Python language, or let's say a programming language. But in Excel, it is also a program that is meant in such a way or made in such a way so that you can work on spreadsheets. So it has all of those advanced type of functions that is needed. Now, let's move on to the next part of this class. So first off, let's create a new Python file. Here, I'm going to work with operators 1_example. Okay? Now, what are operators? Operators are those type of symbols that basically helps you to function up or to make sure that your functionalities are met with the criteria or requirement to run any specific program. Now, there are different types of operators. In Python, there are 4 types of operators, such as arithmetic, comparison, assignment, and logical. So let's just show you what type of operators that we're going to use. Starting off, I'm going to show you the arithmetic operators. So here I'm going to create a segment, or like a message, which is going to distinguish every type of operator. I'm going to put in arithmetic. So first off, let's create a variable. Let's say x is going to be 12 and y is going to be 3. Here, I'm going to print out a lot of these variables. Let's say x plus y. I'm going to print out x minus y. Print out the exact same thing, x. Then we're going to show you multiplication. Now, in multiplication, you cannot use double x like this. So we use the asterisk, which is going to help you a lot. Then I'm going to put in x divided by y, which is division. Print out x. Then we have floor division, which basically gives you a rounded value. Let's say if your data is like, 5.5, the base value, or let's say 6.5, the base value of that value is going to be 6. So it's just going to give you out 6. Okay? So this is basically the floor value. Then I'm going to show you about the remainder. Obviously, in a lot of these type of, operators or arithmetic operation, there is obviously a lot of remainders left. So if you want to find out the remainder, we put in the percentage. Then we have the last operator, which is power. So for that case, we use double asterisk. Let's say 12 to the power 3, or y like this, or you can even put in any specific like number. Okay, but here I'm just going to use in y. Now if I print out the whole thing, you will see 1 is 15, 12 plus 3 is 15. We have minus value, multiplication, division. We have the remainder. We have this percentage over here, which is the remainder basically. And then we have the power of the value. Okay. Even if I want to use something like print 2 to the power 3. So 2 into 2 is 4. 4 into 2 is 8. So it will print out 8. Okay. So that is basically how your arithmetic operators work. Now let's move on to the next type of operator, which is comparison, or helps in comparison operations. Let's cut out this line. Here, I'm going to work with A equal to 6 and B is equal to 12 again. First off, let's print out to be A completely equal to B. This basically shows you if the value is completely equal. Then I'm going to show you A not equal to B. It is going to give you out in a true and a false value. Then print out if A is greater than B. And the last one is A is lesser or smaller than B. So there are only 4 types of, operators in comparison operator. If I play it, you will see in true and false value. So A is not completely equal to B. A is not equal to B, which is true. A is greater than B as false. And A is lesser than B, which is true. So it gives you out in these type of results. Then we have the logical operator, which basically uses and, or, and not. Now, I'm not going to go into vast explanation, but let me just show it to you because this is important for later or for conditions and also machine learning decision making. So here, I'm going to put in logical. First off, I'm going to print out a value, which is going to be true and false. Now, one thing you have to keep in mind is when you are using the function and, in this type of criteria or condition, we need both of the values to be true so that it gives you out the answer to be true. But in the or value, we need only one of the condition to be true. So even if I put in true or false, it will still give me out the result as a true. And the last one is basically the not. Now, this not is basically the opposite of what the user is putting in data. If I put in true, it will result in a false. If I put in false, it will result in a true. So as I put in true, it will result in a false. So let's run the program, and there we go. The first one is a false because just like I said, when you are using the and, it is going to give you out, or it is going to work in such a way so that both of the criterias is true. If one is false, it's not going to work. But in the second one, which is true or false, one is true, so the answer is true. And on the not, we have true, so it's going to give us the false value. Now, there's going to be a last one, which is the assignment operator, which is equal or adding equal to. Let's say it is going to look like something like plus and equal or minus and equal. So I'm going to give you out an example on all of these. Let's say I have a specific number and the number value is 13. So here, as Python uses the latest recent added value, so I'm going to put in plus or equal to 5. Same as the number, but it is going to add up 5 to it. So if I print out number and run it, you will see it is going to show me 18. There we go. If I put in minus or equal, it is going to just deduct the value. So this is basically how Python works and how these operations work. Now, in the same way, let me show you with a value like, let's say, digit. Digit is going to be equal to 5. And over here, the digit or digit underscore 2 is going to be equal to 5 too. If I print out the value to be digit is completely equal to digit 2, it will show me that it is true. Okay? In the same way, if I print out digit is not equal to digit 2, it will show me, obviously, that it is correct. But it will show you off as a false, because both of them are completely equal. If I put in the exact same thing, if digit 1 is greater than digit 2, it will show me a false, because it is not greater. In the same way, digit 2 is not greater than digit 1 either. Run this and it will show you off as a false at the same time. So this is basically how you'll be able to work with these type of operators in Python. So the summary of this class is that you understood about what Python is. You also learned about how to create variables. We have learned how to use different types of data in Python. We also have learned about using arithmetic, comparison, logical, and assignment operators. And at the end, we also learned about how we can manage the files properly in Python. Now, I'm going to give you out all of these files, but you need to practice them along. What you want to do is you want to create a variable as, let's say, a homework, where you're going to create the variable named with color. Then you're going to put in, let's say, product, and also in which region it is. First off, you want to print them out. Then I want you to do 5 arithmetic operations, and then you're going to create one list, one dictionary, and use the comparison operator to compare those two values. Now over here you can see I have all these type of values that I've used and shown you. So that is going to be it. Now even after this, if you're facing any problem or if you face any errors, feel free to ask me anytime. I'm always there to help you out. So thank you for watching this video up till the very end, and hope you understood about everything else. If you have any further problems, feel free to ask me. And without any further ado, let's move on to our next class of AI, ML, and data science. Welcome back to a new class of AI, ML, DS, and big data. So, the topic of this class is going to be conditional statements and loop. So, today's goal is to understand the core building blocks which is used in every AI, machine learning, data science, and big data program. And the most important topic of this class is going to be conditional statement and loop. Before getting into our practical part of the class, we have to understand what is conditional statement and what are loops. So first off, let's just open up PyCharm on our screen. And the next thing that I'm going to suggest you is make sure you have a stable internet connection. And also make sure that you have the stable version of Python and not to skip any part of this class. So let's just open up PyCharm, or if you're using VS Code, then just follow through. So as you can see on my screen, I have opened up PyCharm. Now first off, let's just create a new project. Now instead of project like VENV, click on custom environment. Now over here, inherit the packages, and I'm going to rename my file. Now here, I'm going to put in conditional statement loop. Now press on create and wait for a bit, and make sure to click on generate new and also virtual environment. If you want the most stable version of Python, make sure to click on 3.12, which is the most stable, but it does have a couple of bugs. So it will just guide you in the same process. Press on create and wait for a bit until the virtual environment and the interface opens up on your screen. Just like this, if you're connected to the internet, you will see that the virtual environment will be created on the left side of the project panel. Now, first off, we have to know about the topics. At the bottom, you will see that it is going to start indexing, and it is going to update these skeletons because it is going to be more suitable for you to be able to work in the best functional environment. Now, what is conditional statement? Well, conditional statements are basically compromised or composed of if, elif, and the else, which is basically used for decision making for in every aspect of using Python. Now, even if you want to work with Python in the most basic cases, you're still going to need conditional statement. Even if you want to get into machine learning or even big data or data science, it is still going to help you in the long run. So, if we want to make it more simple, it is the type of function or it is the process where data meets the criteria or the requirement or the condition to do specific stuffs. And on the other hand, we have the loop, which is basically used for automation and repetition of specific function or process or running a program. It also includes using variables like multiple times, repeatedly, and even in other projects. So, it can repeat the task for all types of data or all types of function, but you just have to make sure that you are using the loops in the right way. In loops, you will find out the while loop and also the for loop. So these are the basic things that you are going to be using, which is ML model, training loop, data cleaning, big data processing, AI rule-based engines, and automation scripts. So, as we have this class or the file made up over here, the first thing that I want to start off with is going to be the conditional loop. So here, I'm going to create a Python file. I'm going to make sure conditional condi example. Okay, so there we go. We have our first Python file, and in this file, I'm going to be showing you how the conditional statements work. So here, I'm going to put in example. So just like I said at the beginning, it helps you to make conditional statements and lets your program make decisions based on your data. So there is if, elif, and the else. So first off, you put in the if, and then you define in the condition. Now after the condition, you put in a colon, and then you put in the code. This is the code, how it is going to work. Then we put in the elif, which is the second code. Okay. Now, even though this is just, an example, so I'm going to put in the code again, and to finish off this function or this process, we put in else at the end, so that if none of the condition is met up, it just shows you off the third code. So here I'm just going to put in another code. So this is going to be the example of how your code is going to work, and this is the structure of using the conditional statements in Python. Now, as we know the examples and how the syntax works, now let's show you an example of the conditional statement. Let's say here I have years, which is going to be my variable. Years is 20. So if age or years is greater or equal to 18, then I want to print out that you are an adult. If I print this out, you will see that there's going to be an error on the first line because we don't need this. Now let's just run the program and you will see that you are an adult. Now I'm going to put in another statement. Let's say elif, which is going to be our second statement. If years is, let's say, less than 18, then I want to print out that you are a minor. And if none of the criteria meets up the condition, then I want to print out you are a child. There we go. Now print this out. You can see you are an adult. If I change out the data to 17 and run the program, you will see it will print out you are a minor. Okay? So here we can also put in lesser or equal to. It will also work the exact same way. But if I put in, let's say, 13 and run the program, you can see you are still a minor. In this case, what I can also do is add in another. So years, which is going to be lesser equal to, let's say, 17. Then it should print out you are a child. And here I'm going to put in invalid request. There we go. You are a minor. So you can see this is lesser or equal. But here, if you put in greater, it is going to work a bit different. Run the program. There we go. 12. Run the program. And there we go. This is how it works. You can see if it is lesser than 18, this is how it should work. If it is lesser than 17, or equal to 17, then you will be a child. Okay, so this is basically how you'll be able to run these type of programs and make sure that your decision is made by Python. Now you can still see it is still printing out you are a minor. In that case, you have to make sure to put in proper, conditions and proper strings to make sure that your condition is met properly and is understood by Python. Now, based on this code, it will never print out that you are a child. But in that case, if you want to do that, first off, what we're going to do is that if the years, over here I'm going to put in 13, and I'm going to make sure that 13 is greater. Here I can print it out that you are a child. There we go. Now here, as you can see, it is greater, or 18 is greater, then here you are a minor. And if this is greater or equal to 18, here I'm going to put in you are an adult. Now if I try running this program, you will see that it will print out you are a child. Then if I change this to 17, run the program, you are a minor. If I put in 24, run the program, you will see you are an adult. So why does it work like this but not how I put it the first? It's because the current code or the previous code that we were running is that if yours was greater or lesser than 17, it is also true. And if the yours was lesser than 18, that was also true. So Python will just basically stop at the second condition, and it will never reach out to the third one. So you have to make sure that Python validates your request and also your conditions whenever you are working along with it. Okay? So now you know how you'll be able to work with the if, elif, and the else. Now let's do another thing. Now here, I've shown you how you'll be able to work with the, if, elif, and the else statement. But what if you want to do just only two, which is the if and the else? So let's say I'm going to have a temperature of 30 degrees Celsius. Here, if the temp is greater than 25, then it should print out, let's say, it is hot today. And if it doesn't meet up the criteria, then it should print out it, or let's say the temperature is, let's say, chill. There we go. If I just run the program, you will see that it is hot today. But if I print out over here to be 20 and run the program, you will see that the temperature is chill. So what happens over here is that Python checks the condition. Only one block will be executed if you are using the if and only the else. And it is basically very useful in machine learning, like if probability is greater than a specific percentage, then classify, specific criteria. But in the same way, as you can see, we use the if, elif, and the else. So first off, here the program checks what is the mentioned years. Okay, now it is going to turn true if it is run by the code inside in the if block. Okay, another thing is that Python checks each condition from top to the bottom, so everything is validated inside. And when one condition is true, it stops checking any further and doesn't rerun the program anymore. So it is basically very useful in real world classification logic. So obviously you're not going to be working with only one or two logic or one or two condition. But in this way, you'll be able to work with several and multiple conditions just the way you want it to be. So this is basically how you're going to be working with the conditional statements in Python, and these are the if, elif, and the else statement. Okay, so hope you understood about this part. Now let's create another Python file to show you how does loop work in Python. Here I'm going to name it loop1_example. Okay, so as we have the loop1 example, the first thing you have to understand when you are working with loop is that why is loop important in Python or even data science or machine learning or AI. So first things first is that whenever you are using loop in Python, it iterates through specific data set. Now it could be a large data set, it could be a small data set. but iterating through them cannot be done by all modules or all type of functions. But when you are using loops, it is basically going to loop, iterate, and also repeat the exact same code block over and over again without facing or without any errors. Okay? Another thing about loops is that it helps you to clean up specific data, such as it helps you to search for the data, search for the specific code block, and clean up the data. Then it helps you to process millions of rows. Now, certain type of function does not help you to iterate through certain or specific or limited amount of rows or range of data. But whenever you are working with loops, it is basically going to work with millions of data, and it is still going to give you out the result in milliseconds. So it is almost like the fastest function or the fastest functionality of using loops in Python or even in machine learning, data science, or even big data sets. Now, the last advantage of using loops is training modules. Now, in machine learning, training modules or models are very important to find out, predict, and even visualize specific type of data, which are also known as epochs or batches. Now, just like I said, it can iterate through millions of rows or columns in one go and give you out results in milliseconds. It has zero error whenever you are working with it. Now, the first thing you have to know about loops, I'm going to give you an example of the syntax. So, whenever you are using loop, first off, you put in for. Let's say I'm going to show you for the for loop. For, here you're going to put in the variable, then you put in, and then you put in the sequence. Well, if you still don't get the idea, I'm going to give you an example, and then you want to repeat the code. Okay, so this is the syntax of using loops in Python. Now, first off, let me show you how you can loop through a list. Let's say I'm going to have veg equal. Now, obviously, you know, when you want to create a list, we use these secondary brackets. Let's say in veg, we have potato. Then we have onion. And then we have, let's say, cabbage. Here, I'm going to put in for item in veg. So each of these data is an item. So after veg, I'm going to print out the exact same thing, which is item. If I print out the whole thing, you will see potato, onion, and also cabbage printed in each index. So basically the loop runs one time for each element. Now, obviously, you know, if you want to print them out step by step, what you have to do is type in print and then put in double quotation, type in potato. Then you have to put in print, put in onion, and also print. Then you put in cabbage. If you run this, everything will be printed in the same way. But when you are working like this, it is going to take you a lot of time and it is going to take you a lot of effort. But if you are using the for loop, it is going to run the program all at once, saving a lot of time and iterates through specific or even big data sets. Okay, now as we know about how to iterate or loop through a list, now I'm going to show you how you can loop using range. Okay, so first off, let's create a range. So here for I in range. Now I'm going to put in a specific number, so up till 5. Here I want to print out iteration colon comma and then put in I, which is the item. If I run the program, you will see iteration 1, 2, 3, and 4. Now, even though we have put in 5, already you know whenever you are working with programming languages, the last number is an exclusive, and the index of the number starts from 0. So 0, 1, 2, 3, 4. So it already like adds up or sums up to 5. Okay? So if you actually want to print it up till 5, you have to put in 6, which is going to be the exclusive number, and you will see it will be printed up to 5. Okay? You can also like change the text here. Let's say range iteration, run the program, and everything will be run at the same way. But if you want to use print, that is going to obviously take a lot of time. Another thing, that when you want to print out 6, which is the exclusive, it actually like prints out exactly 6 times when you are running the program only once. Now it is used everywhere in machine learning and also training loops when you are using for. Okay? Now, the last thing that you need to learn about this class is going to be the while loop. So let me show you the index or the syntax of the while loop. You put in while just like this, and then you put in the condition. Then you like put the same thing of keep the loop or the code repeating. Okay, this is the syntax. So if you want to run it with the example, let me just show it to you. Let's say I have a digit. The digit is 1. Here I'm going to put in the while the digit is lesser or equal to 6, which is the condition. If I want to print out, let's say digit count colon, and then put in the digit as the variable. Now the last thing that I'm going to do is I want to increment the value 2 at once. So here I'm going to put in digit plus or equal to 2. In this way, it will just keep on adding 2 values from 1. There we go. We have 1, 3, and 5. But it is not going to go up till 6 because that is the exclusive number. Another thing is that it's going to keep on repeating until the condition becomes false. Now this is often used for tasks that depend on external conditions. Now even if you want to put in something like 999 and run the program, it is still going to run up till 999. Okay? Now one thing over here is, why does it print out 999? It is because it adds up to 2. In that way, it adds up to 999. If I put in 100 or 1000, then you will see that it is going to print up till 999 again. There we go. Because if you're adding in 2 more, it just sums up to 1001, which is not a part of the condition, and it also violates the condition. In that way, it is still not going to print out, but if you put in 1001, it will still print out up till 1001. Okay? If you put in lesser than 1001, then it will print up again up till 999. Okay? Now, as you know, and you've learned about the while loop too, now let me show you an example of how you'll be able to use it in AI and also machine learning loop style. So first off, let's create another Python file. Here I'm going to put in AI ML example. So the first thing is that you have to know that in AI and ML, there are epochs and also bursts. Okay, so let me just use epochs. Epoch is going to be equal to, let's say, 2 in this case, and I'm going to put in a total epoch is going to be equal to, let's say, 5 in this case. You can also put in like, lesser or greater. It just depends on whichever condition you want to use. Here, what I want to do is going to be using the while loop. So here I'm going to put in while. Okay, this is how you want to put it in. There we go. So while the epoch is lesser or equal to the total epoch value, put in colon, and after that, we want to print out, let's say, training the values in ML/AI, put in comma, and put in epoch. On the last one, I'm going to put in epoch plus or equal to 1. Run the program. It will still run in the same way, but when you are working with AI and also machine learning, make sure to use epoch, not a different variable. Basically, this represents how machine learning is going to use your code or your structure for model training, and also it is going to multiple times over the data. Another thing, it is going to be automated. So I'm not just showing you the whole process, but giving you an idea about how the syntax works when you want to use epoch or conditional looping, or even, all of these steps into machine learning directly. Okay, so let me show you how you can combine the conditions with specific loops. Okay, so first off, let's say I'm going to have another digit, but I'm going to loop through a list. Let's say I'm going to start off with 20, 30, 40, then I'm going to put in 51, comma, and then 58. Okay, so I'm going to put in for digit in digits. There we go. Here, I'm going to put in if number percentage to get the modulus. Let's say 2 is completely equal to 0. Here, I'm going to print out, let's say, digit. It is even. Okay, so if there is 0 remainder left, then obviously it means that it is an even number. But if the modulus shows up as 1 or 3 or 4, not 4, it is going to be equal, but if it's like the odd numbers, everything is going to print out as odd. Okay, so put in digit first is odd. Now you can run the program. You will see an error, but here you're gonna put in, let's say, I'm gonna put in digs. Run the program, and there we go. You can see if number. So we have number over here. Instead of that, I'm gonna put in dig or digits. Okay, run the program, and there we go. We have another modulus, which is part of the problem. So let me just fix this out. Let's say percentage. So here, we're just going to cut this part out to make sure that every digit is validated. Now run the program, and there we go. We have 20, 30, 40, 51, 58 is even, and then this is odd, and the last one is also even. Okay? So basically what it does is that it loops and goes through each and every value. Then the condition is checked up if it is an even or an odd number. And the most important part about this process is that it is for dataset filtering and also pre-processing. Now there are also a lot of, let's say intermediate process or functions that I did not show you in this class, because I have made this class in such a way it is very beginner friendly. So I'm going to show all of those to you later on in this course. Now, first off, let's just get into the summary. So what we've learned in this class is the conditional statements of the if, elif, and the else, and how these conditions are validated. And also we've learned about the syntax. In loops, we learned about for loop, while loop. We also worked with range, and also we worked with real machine learning loop example. Okay? Now another thing, what you have to keep in mind is to practice along. So I'm going to give you out a homework where you're going to loop numbers from 1 to 30, and you also want to print out, let's say, specific keywords. You can choose any 3 keywords. First off, the keyword which you're going to use, you're going to make sure that it is divisible by 4. The next keyword that you're going to use should be divisible by 5. And the third keyword that you want to use, it should be divisible by both the numbers which I mentioned in the first place. Okay, so that is it for this class, and hope you understood about everything. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So just practice along, do not memorize anything, and you can reuse these codes if you want to, and just keep on practicing. So without any further ado, let's move on to our next class of AI, machine learning, dataset, and data science. Welcome back to another class of AI, machine learning, data science, and big data set. The topic of this class is going to be functions and list, tuples, and dictionary. So I have made this class to be totally beginner friendly, so it gives you out a clear idea about function, list, tuples, and dictionary. Another thing that you have to know about this class is that I have segmented this class in a couple of parts, so it would be easier for you to learn and also use it in the long term. So make sure you are connected to the internet, and make sure not to skip any part of this class, because if you do, you might miss out on something important and later on face a couple of errors. So without any further ado, let's open up PyCharm, or if you're using VS Code, then just follow along with me. First off, let's create a new project. And over here, what I'm going to do is that I'm going to make sure to put in function. Then I'm going to put in, let's say, ex1. Okay. Now inherit the packages and press on create until the interface opens up on your screen. So as you can see that we have our interface in front of our screen. So what you will learn in this class is what are functions and why do we use them in Python. Then we're going to go through our list. We're also going to learn about how they are used in data science and machine learning. And the last thing that you have to keep in mind, just like I said, I kept or made this class to be super beginner friendly. So I'm also going to be using simple beginner codes. So starting off, we're going to learn about functions. So let's create a Python file, function1. There we go. So what is a function? A function is a block of code that you can reuse anytime. It's not like a loop that you can use like over and over again, or run the program over and over again till it meets up the criteria. But what it does is that it reduces repetition and makes the program a lot more cleaner, organized, and a bit more functional. The basic syntax of working with a function is by using defining a function name, just like a variable. So what I'm going to do over here is I'm going to create a calling simple function. Let's say what we do most of the time is type in print and get out the result. But here you have to define it. Define welcome, colon. Here, let's say print out hello user. How are you doing? So this is exactly how you want to print it out. Now here, if I want to type in greet, or let's say if I want to type in the variable, which is welcome, and run the program, you will see it will be printed out. But one thing is that you can see we did not print the exact thing. Instead, we called out the welcome function. In that way, the function is run, which is defined by the def over here, which is basically defining a function. Then we have the welcome, which is the keyword just like a variable, which calls out the function whenever you want to print it out inside of the console, and everything inside the function runs only when you call it. Okay? Now, the next thing you have to understand about using a function is functioning with a specific parameter, such as you can call it out even inside the print, such as, let's say if I put in def username colon. Here, I want to print out first off with a string. After the string, I want to call it out, such as I'm going to put in a parameter, such as code. Here, I'm going to define the code over here to be called. Here, I'm going to put in, let's say, username, and then I'm going to put in the exact name of the user. Let's say Sarah. If I run the program, you will see it will print out hello and then Sarah. Now you might think that this is a bit more time taking. It takes a bit more time, a bit more effort. But one thing is, it is a function, not a call or not a return like the print. So the parameter that we're using in this part is the code variable. And also the argument that I'm putting to call out the name or any specific keyword is Sarah. So the function prints personalized greetings, or even, let's say, whatever variable you are using. Now, the next thing you have to understand about the function is that a function also can return with a return value. Now, how does it return with a return value when you are already printing it out even with a parameter or an argument? It is that you can also call it out even in between an operation, such as we put in def, let's say summation. Here, I'm going to put in two parameters, x and y. Then I'm going to return it with, let's say, x plus y. Now, I'm going to put in results. There we go. Equal to summation. And now we're going to put in the value of the parameters, such as x is going to be 60, comma, and y is going to be 30. In that way, you can see it on the screen. It is already validated. And if I want to print out the result, it will print out how the summation works. There we go. Now we have 90. So whenever you are using this return function of Python, it sends a value back to the parameter, and also it validates the summation or the condition that you are putting inside of the program. And you can store it in a variable which is known as the result, which is over here. Okay, so that is basically how you can work with a function, also a basic function in Python. Okay, so that is going to be it. Now let's move on to the next part. In the next part, I'm going to show you lists. Okay, so what are lists in Python? A list is basically a box or a category which can store multiple values in one variable. So obviously you have experience with list. If you've checked out my previous classes, you already know how does list work and how you'll be able to make it. So let's say I'm going to put in number, no, equal secondary brackets, let's say 11, 22, 33, and 44. Okay, so on the next one, what we can do is we can print out the numbers just like this, and the list will be printed. Now, we already know how to print out and create the list, but how are you going to access them? So we have to use indexing. Let's say if I put in print number, now to call out the index, we put in secondary bracket. Now, as you already know, in Python, indexing starts from 0. So 11 is 0, 22 is 1, 33 is 2, and 44 is 3. If I want the first element, which is 11, I will put in 0. If I want another value, let's say I want to print out 33. So here, I'm going to put in number, and I'm going to call in number 2. Print them out, and you will see 11 and 33 will be printed. So now you understand about how the indexing works in Python. Now, how are you going to modify a specific list? Let's say, first off, you have to call in the variable, which is the number. Now, starting off with the index, I want to change out 22 with 55. So here, I'm going to call out 1 as the index equal to, now you put in the value, which is going to be 55. And here, if I print out the value of the variable, run the program, you will see 11, 55, 33, and then 44, but there is no 22, as this is already modified the list. Then, how do you add and remove items from a list? First off, you put in number, dot put in append. Let's say I also want to add in 66, number dot append. I also want to add in 77. In this way, if I print out the value, you will see in this list, it is also going to add up 66 and 77 at the same time. There we go. If you also want to add in 22, here I'm going to put in number dot append 22, run the program, and there you go. At the end, there is 22 available or present there. Now, the last thing that you need to know about looping through a list is how to loop. So here, let's say for number in numbers, okay? Or in NO. Here you can put in number, just like this, colon. Here, I want to print out the value, let's say value, and over here, comma, and call in number. Instead, what you're going to do, you're going to type in number, call out the variable, and you will see everything will be looped through in one program, or running the program only once. So this is basically what you can do with lists in Python. So we're also done with lists. Now let's move on to tuples. So if you have no idea about tuples, tuples are also kind of like a list, but those are immutable. And it is represented using a parentheses. So first off, I'm going to put in tuple underscore 1. So the first thing about the tuple is that it is kind of like a list, but it cannot be changed, modified, added, or even replaced. Let's say week. I'm going to put in weekend. Weekend is going to compose of, let's say, Thursday, Friday, and also Saturday. Here, first off, I want to print out the weekend. Run the program. There we go. We have Thursday, Friday, and Saturday. Now, how are you going to access the items in tuple? In the same way, print weekend, secondary bracket. Let's say I want to print out Saturday, which is 2 in the index. Run the program. There we go. We have Saturday. In the last one, I'm also going to show you how tuples are immutable. If I want to put in weekend dot append, and I just want to put in, let's say, Sunday. Run the program, you will see that it has no attribute. It is because tuples cannot be changed, it cannot be accessed, it can be accessed, but it cannot be modified. So you can print out the program weekend. Run the program, and there we go. It is immutable. So in list and tuple, the difference between them is lists can be changed, but in tuples, it cannot be changed, neither modified, and neither deleted. So tuple basically protects the data from being changed accidentally and even replaced accidentally. Okay, so that is it about list and tuples. Now, the next thing that you want to know about the last part of this class is the dictionary. So I'm going to put in dictionary underscore 1. Okay, so first off, you have to know that what is a dictionary. So a dictionary is also a type of a category, but it stores data in key value pairs, which means that it is going to contain both the heading and also the value of that heading. So whenever you want to list out, or let's say filter out data, it is basically a lot more simple whenever you are working with dictionary. Let's say I'm going to create a variable. Okay, another thing you have to keep in mind is that dictionary is very important in data science because you can use dictionary in JSON files, dataset, API output, CSV, Excel, and so on. Okay, so first off, I'm going to put in pupil equal third bracket. Here, let's say I'm going to put in username and then double quotation, let's say Gary, comma, I'm going to put in, let's say, starting year. Let's say this person started on 2020. And I'm going to also put in the department this guy is in. This guy is in the AI/machine learning. Okay? So as this is the last line, I'm not going to put in any comma. Now, I want to print out, let's say, pupil. Run the program, and there we go. We have the username Gary, starting year 2020, and department is AI and machine learning. Now, only among these, tuples is the one that protects the data, which means it cannot be changed. But dictionary can be accessed or even updated. So, if you want to access any value, first off, you print out, type in the variable pupil, and then you put in the category of data that you want. Let's say I want the starting year and also pupil. Here, I also want the department. Run the program, and you will see 2020 and also AI and machine learning, which is the department. Now, the next thing that you need to know about this is you already know about accessing the values. Now, how are you going to update the dictionary? Let's say maybe I want to change the year of the starting year as this person started in 2019. So, in that case, I'm going to put in pupil, secondary brackets, let's say starting year. So this person started in 2019. Here, I want to print out pupil. Run the program, and you will see that now this person has started in 2019. Okay? So the next part of this dictionary is how you can add in new value pair. Let's say I want to add in from which region is this person from. Let's say I'm going to put in pupil, secondary brackets, let's say region, equal, the region this person joined in from was from the West. So I want to print out pupil. Run the program, and you will see region is West. Now, what if you want to loop through a dictionary? For that case, for key value. So key value in pupil dot items colon. Here I want to print them out. First off, I want the key values, comma, double quotation, colon, put in another comma, and then put in the values, which are basically these values. And these are the key pairs. So just run the program and you will see username is Gary, starting year is 2019, department is AI machine learning, and region is West. So that is going to be it, or that is it for this class, and hope you understood about everything in this class. I'm also going to give you out a mini practice for you guys to practice along with me. So the steps that you're going to follow is that you want to create a function which is going to be the square number, which returns the square of a number, and you want to create a list of 7 items. I want you to create a tuple of 7 country names. I also want you to create a dictionary about your laptop. Let's say what brand it is, what type of storage it is using, what type of processor or GPU it is using. You can create it on your own, but it should have at least 5 key pairs. So the summary of this class is you've learned about functions, which are reusable block of codes, how you can use them, and when you want to use them. You also learned about lists, which are mutable collections of data stored, which is, or let's say, can be changed anytime you want to. You also learned about tuples, which are immutable listed data, which cannot be changed or even accidentally changed. You also learned about dictionaries, which are key value pairs of data storage, and how you can use all of them in PyCharm or in Python, in whichever case it is. Okay, so thank you for watching this class up till the very end. And if you are still facing any problem, or if you have any confusion about any part, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data set. Welcome back to a new class of AI, machine learning, data science, and big data analytics. The topic of this class is going to be file handling, OOP basics, virtual environment, and package management. So what you will learn in this class is going to be how Python reads and writes files, what classes and objects are, why OOP is important in AI and machine learning, how virtual environments function and what those are, and also installing packages using pip. So before getting into our practical part of this class, we need to get an overview and idea about the topics that we are going to cover in this specific class. So first off, we're going to learn about the file handling OOP basics, virtual environment, and package management. So file handling basics. So they are the open function. There are different type of file modes, which are R, W, A, and R+, which have different functions on each and every one of those assigns. Then what it does is it reads texts and also writes, and we're also going to learn about the best practices using keywords. Now, what are file handlings in real AI and also data science works? What it does is that it examines datasets, it helps you to keep logs, prediction, export it, and also composing reports. Now, what are the OOP basics? There are mainly 4 things. First off is the class. The second is the item, which is also known as the object in most cases. Then we have the qualities, are known as attributes in programming term. Then we have is the techniques, which are known as the methods. And the last one is going to be init and also the constructor, which is going to be also part of the syntax of how these function. Okay, now let's move on to the next page. So we also have to learn about why OOP is important in machine learning. It's because models are the objects that we already talked about. There are specific pipelines for pre-processing. Now, what are you going to use these pipelines for? Only for specific objects. Then it helps you for a cleaner code, and also it is used for encapsulation, which makes the code look a bit more cleaner and also organized so that you can keep it for future purpose or reuse it. And the most important part, as Python is very versatile, most of the things are reusable, but when you are using OOP, what it does is that it creates reusable parts so that it reduces the time of effort, and also it reduces all of the work. Then, organizing the files. So, the virtual environment and also package management falls in the organization of files in Python. So, what do they do and what are those? So, if we talk about the virtual environment, well, if you've seen my classes from the beginning to the end, you already know what a virtual environment is and how does it look like. So, virtual environment is an independent remote workspace. It keeps the packages distinct from each project, and it is crucial for data science and also machine learning initiatives. Well, to keep it smaller, or even let's say to summarize it, what virtual environment does is that it gives you your own type of environment, or even let's say, for an example, let's say it creates you a space or a small server where you can run the program, you can test them, you can debug them, and also if you want to launch it, you can launch it directly from the virtual environment. Then we have to talk about the package management. Now, package management is a process. Okay, what you can do is you can install packages with the name using pip, which I'm going to show that to you later on. And also in one of my classes, I've shown you how you can install any module or any package using pip or the terminal. Then package management is also enhancing the functionality of any programming language or running the program. It also helps you to eliminate any type of data or any type of package that you do not need. And also it helps enumerating installed packages in Python or even in other programming languages if you are working along with it. So now that we have a clear idea or a small idea about the topics of this class, which we're going to cover. So first off, let's open up PyCharm on our screen and let's get started with coding and also give you a clear idea about the topics that we have given you a small idea about. So the first thing that you can see on my screen is that I just opened up PyCharm. Now the first topic that we're going to cover in this class is going to be the OOP basics. Now I'm going to tell you what OOP is, I'm going to show you the terms, and I'm also going to give you an example of how you're going to work with it. So first off, click on a new project. Here I'm going to name it, let's say, file underscore adjustment underscore environment. Now wait for a bit until the virtual environment is created on your screen. Now every time you open up PyCharm, you will see that it is going to show you a screen where it says creating virtual environment. Well, every time it opens up on my other screen, so it doesn't show up on my screen, okay? But I will show it to you later on, and I'll show you how it basically works. Now, another thing you have to keep in mind is that as we're also going to be showing you package management, make sure you have a stable internet connection throughout the whole process, okay? So just like I said, what is OOP? So OOP are also known as object-oriented programming. It is basically a structure of the code in specific objects that contain data and also function at the same time. Now, in my previous classes, I've shown you how you can work with function, how you can work with variables, and even how you can work with conditions or even loops. So if you do not, or if you still have any problem with those classes and you did not understand or let's say practice those classes yet, then I would suggest you go check out those classes again, because we're going to be using all of those in this class, and it is going to make sure and it will just give you a clearer idea about OOP. So OOP contains of a couple of things, or let's say there are a lot of things that are going to be put all together, and it is going to make up the OOP term, which is the object-oriented programming. Now, let's say, to keep it more simple, the way you are going to use Python to use its functions and data in such a way so that everything is object-oriented or also managed in a clear way to make it reusable, errorless, and also versatile is also known as OOP. Okay, so I'm going to give you out some types of, examples. First off, let's create our first Python file. Here, I'm going to put in OOP example. Okay, so there we go. Our Python file has been created. Now, just like I said, it contains objects and also contains data, and it can also add up functions. So OOP contains of class, object, attributes, method, and also the constructor, which is init. Okay, so the class is also known or can be termed as the blueprint of the program. Let's say the pipelines of the program. Now, then we are going to need the object, which is going to be the subject, or let's say the item of the class or the program. Then we're going to need the attribute, which is going to be the quality or whatever data you want to put inside of that variable. Then we're going to need methods, which is going to be following specific syntax and using specific function inside of the variable, or also known as the class. And the last one, to create the object, to create the outcome, we're going to need a constructor, which is init. So first things first, let's say, as we're going to need a class, so define in class just like this. Then we're going to need an object, or let's say a variable. Here, I'm going to put in pupil. On the next line, and on the same indentation level, I'm going to put in def, which is basically starting our function. Now, on the next part is going to be using our constructor. So it creates the object into OOP. So underscore and put in init. And you will see the first thing that opens up is going to be the self. Now, after the self, let's say I need specific attributes or specific qualities. First off, we have to create the filtered, or let's say the heading or the categorized data, such as a variable. So here, I'm also going to put in, let's say, username, comma, and I also want the department, or maybe let's say I'm just going to put in year. Okay, so I'm going to put in starting year, and now I'm going to create the attributes one by one. First off, you want to put in self. So the self is going to create the attribute. So self dot, and then put in the username, which is going to be also our attribute. Username equal to username. Okay, and here in the same way, I'm going to make sure our year is also validated. So self dot year is equal to year. In this way, our attribute is created. Now, on the next part, what I want to do is that I want to define a name, but I'm not going to put it directly, but instead, I'm going to create another function or define another function. So put in def, and here, I'm going to put in greetings to be another variable. Open up the parentheses as self, which is basically the method of making sure that our greetings is run. So on the last part, we want to put in the return value. So f double quotation here, let's say my username is. Now, as we are using f and also function, what we put here is going to be the third bracket or the curly braces. Here I'm going to put in self dot username, because first off, I want my name. after the username, put in space, and my starting year was third bracket or curly braces again, and put in self dot year. There we go. And I'm going to put in a full stop at the end. That's all that I'm going to do. Now, what we want to do at the end is going to be creating the object. Now, we have already created the object using init. So we have to make sure we create the object one by one. So let's say, as this is, let's say, a line, which I want to print. But if you want to print out more lines, you can do that. So here, I'm going to put in pupil 1 is equal to pupil, and then I'm going to put in a parentheses. Now, first off, I'm going to put in myself. So my username is going to be Gary. That's it. And also, my starting year was, let's say, 2022. Okay? Now, if I want to print all of this out by calling the method, okay, so I want to type in print student1 dot and put in greetings. Open up the parentheses just like this and run the program. You will see that it might show me off as an error. Okay, so we have student over here. Instead, I'm going to put in, let's say, pupil. Run the program, and there we go. My username is Gary, and my starting year was 2022. So what we did over here is that the class pupil, this is the blueprint, okay? Or this is the start of the program. Then we put in self, which is username or even self year. This part basically stores the object data. Then when you put in greetings, this greetings is the object action. And when you put in pupil 1, which is basically pupil and then whatever your name is, so it basically creates an object. If I put in pupil 2 equal pupil, let's say my name is Alan and my starting year was, let's say, 2023. If I print out the exact same thing, say pupil 2 and then put in dot greetings and open up the parentheses and run the program. There we go. In this way, you'll be able to run the same program and reuse it without any error. Okay? Now, you might think that why are we going to use this complex method in Python? Well, not in Python. You want to use this in machine learning and also sometimes in data science. It is because in machine learning, you are going to work with specific models, which are going to be the object. Just like you can see, the object over here, or the object data, is going to be the def init and the username or year. Okay? And this greeting is basically the action. So when you are working or when you are applying OOP in machine learning, there's going to be specific modules. And when you are working in machine learning, there is a specific module that you use, known as the random forest classifier, which basically helps you to train your specific models. Now, your models could be X, Y, A, B, C, D, whatever like variable you want to use. And just by using those models, you are going to predict specific type of data or specific type of results. So when you are using those models known as random forest or also known as random, it basically helps you to predict, fit the data, use the model, and also use specific classes. Let me just give you an example. Let's say here I have a specific model equal say random forest classifier, which is obviously not installed yet, and I don't want to go through that yet. So first off, we put in model.fit, and then you're going to train your values. Let's say a underscore train, comma, b underscore train, to train in just your data. And here you put in model.predict, and then you put in the variable or the value of your data, or let's say your objects, okay, such as a underscore train. Now, even though this is not going to work in this class, we need a different environment and a different module to run this. So one thing over here is that we have created a class. Then we have the model, which is already defined at the first, which is basically our object. Then we put in .fit. Basically, this is the method. And also, we also have .predict, which is also another method. Just like you can see, we did greetings. So if you want to fit the data, that is also, let's say a method. If you want to predict, that's also a verb, which also makes it another method. So when you use these type of syntaxes, this basically turns into pure OOP, or object-oriented programming. Okay? So now you have learned about what OOP is and how it basically works. Now, the next thing that I want to do in this class or cover is going to be the virtual environment. So you can already see we have this VENV, or the library root. This is the virtual environment, which is basically a separate Python workspace for each project. Now, if you go or close this project, it will basically just go onto the home interface. And there are going to be a lot of other projects that you have saved or you can open up at any time. So that is what a virtual environment is. What it does is that it prevents version conflicts. Let's say, as I have 3.12. Now, if I just directly change it to 3.10 and I have something which only runs on 3.12 or higher, then there's going to be a conflict. And there's going to be some errors that you have to handle or fix up. Obviously, not all the version or older versions are not the same as the newest versions. Even though a lot of them are stable, a lot of them, the programming or the syntaxes are same, but not all of the modules run on all of the versions, or let's say, Python models. So it just prevents the version conflicts and helps you to keep a stable and functional environment. So there are some things known as the TensorFlow 2.15 or TensorFlow 1.15. So if you are working with, AI projects, machine learning projects, or data science, then I would suggest you use 3.12 or higher. But if you want the most stable one, I would suggest you to go for 3.12 most of the time. Okay? Now, obviously, you know how to create a virtual environment, which I already have shown in most of my classes up till now. Now, even though if you do not know how to open up a virtual environment, what you want to do is first off, click on the terminal. Okay? Press on got it. And over here, you want to type in Python -m and put in VENV. That's all that you want to type in. And you just want to type in, hit on enter. Now, it might give you an error just like this because it already includes or has the virtual environment. But if you do not have it, and if you still want to force install it, type in VENV, then put in /, type in scripts, / again, and type in activate. There we go. In that way, the virtual environment is going to be activated and opened up on your project. Okay? So that is basically how you install, let's say, Python or the virtual environment if it is not working. But if you follow the steps that I use to create a new project, in that way, you don't have to create any virtual environment. Okay? Now, the last topic that I want to cover in this class is package management. So package management is also very important. And if you've seen my, let's say, the first class or the introduction of this course, you already know how to install packages, such as, let's say, I want to install a new module, let's say NumPy in this case. There are two methods of installing a module. First off is typing on the terminal, which I prefer most of the time because it is easy. You only type in pip install and type in the module, such as NumPy. Hit on enter and wait for a bit, but make sure you have a stable internet connection because you will see that it will download a couple of data that is not available on your device. But if it has it, then it's just going to run properly. Now, just by running it, you can see it is indexing the data because there are new type of data, new modules, which is being applied directly to your interface without even having to close the software. Okay. Now, another thing that you can see over here, it is showing me to update run python exe -m pip install _ upgrade pip. You can run the exact same thing. Copy, paste it, and you will see that it is going to install the latest pip available for your device or according to the time. Okay, it is going to uninstall the previous one and it's going to install the latest one. If you want to upgrade any specific module or package, type in pip, type in install, put in a dash, or let's say space, and put in 2 and type in upgrade, and then put in space, and let's say I want to upgrade NumPy. So it will have the latest version of NumPy available on the website. If you want to uninstall any specific package, type in pip, type in uninstall, and let's say NumPy, I don't want it anymore. Hit on enter, and it will be uninstalled in just a couple of seconds, but it is going to ask you again for confirmation. Let's say why. There we go. Successfully uninstalled NumPy. Now, if you also want to check what packages are installed on your device, type in pip and type in list. Hit on enter and wait for a bit, and you can see we only have pip available and we don't have anything else. Okay? So this is the first method, but if you want, let's say, an alternative method and you don't want to type anything, first off, just click on this over here, or right click over here, or just click on this and go down and click on interpreter settings. Click on that, and what you're going to do is you're going to see this Python interpreter. If you want to apply any new packages, just click on this plus icon, and anything or the new packages is going to appear over here. Well, if it doesn't show up, what you want to do is first off, let's say I want to select my interpreter, show all. If it doesn't show up, you can see try the redesign packaging support. Now I'm just going to press on OK. Click on this over here again. Click on new interpreter. You can add in local interpreter. You can see we have this 3.14. So let's say I'm going to change it. Let's say I'm going to apply to the existing one. If you want a new one, there we go. Inherit the global packages. And I'm just going to cut this part out. You can see it is empty, so I'm going to put in venv. Well, if it does not work, what I want you to do is, first off, let's just create or close this project first. In a couple of seconds, this is exactly how it will open up. Click on new project. Let's say I'm going to keep it 20 just like this. And I'm going to make sure to open this up on 3.14 this time. Here, I'm going to just press on create and wait for a bit until it opens up on your screen and shows the interface. Okay? So there we go. This is how it should look like. And wait for a bit just for the indexing and updating these skeletons. And after that is done, what you want to do is click on over here, interpreter settings. Here you can see we have these Python packages tool is not found. First off, install packaging tool over here. Okay, there we go. Over here, press on OK. Install packaging failed. If it shows you it has failed, then you want to run the program again, and you can add an interpreter anytime. So now what I did, I am using 3.12 again, which I told you is the most stable one. Now click on this again and click on interpreter settings and click on this plus icon. And it will take a bit of time, and you're going to need a stable internet connection. And there we go. There are a vast amount of packages or modules which basically you can install in Python. Let's say if I want pandas, I'm going to search for pandas. There we go. We have pandas. If you want to use NumPy, I'm just going to search for NumPy, and there we go. Now, whatever package you want to install and use, click on that and press on specify the version. If you want to see other options, click on that, and you can also install specific package versions too. And after you are done clicking on that, just press on install package. And in this way, you are not going to need to write anything on your terminal, and you can just install any package that you need in Python or for any work. In that way, you can see we have NumPy installed, and from here, you can also update the versions whenever you want to. Let's say, as you can see, we have pip over here, so we don't have to type in pip upgrade or anything. What we can do is we can just click on this, and you can see it will just open up again like this. We can specify the version, and the latest is 25.3. You can see it over here. Click on options and just press on install package. In that way, the pip version is also going to be updated without typing anything inside of the terminal. Okay, so obviously there are going to be different type of methods and alternate methods of how you'll be able to work. So that is going to be it for this class, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data set. Welcome back to our new class of AI, machine learning, data science, and big data analytics. The topic of this class is going to be introduction to NumPy with NumPy arrays and operation. Well, I have segmented this class in specific ways and specific parts so that it is easier for you to learn. I also have some specific objectives that I want to complete in this class so that you get a clear and vivid idea about what these are and how are you going to use them by using PyCharm or any other IDE, and how is it going to help you in AI, machine learning, data science, and even data analytics. So first off, let's open up PyCharm on our device. And if you're not using PyCharm, if you're using VS Code or any other IDE, first off, let's open it up, and we're going to learn about what is NumPy first, and then we're going to get into our practical part of this class. So as you can see, I have opened up PyCharm. Now, the first and the most important thing that we have to know is what is NumPy. Well, you can term NumPy to be a module of Python, even though it is a module of Python, but it is a very popular one. So NumPy basically means numerical Python. So the foundation of how NumPy was created is basically for data science, machine learning, deep learning, and also big data. It is basically used for mathematical operations a bit faster than the default Python. It can also handle a very vast and large amount of data sets, and also for computing scientifics or even, let's say, scientific operations. So now you might think, why NumPy? Like, there are also a lot of other modules in Python. NumPy, or why is it advantageous? It is because it is a lot faster than using default Python list. If you want to use vectorized units or vectorized measurements, it basically helps you to process data in bulks a lot faster, and also for error handling. It can also support multi-dimensional arrays, such as vertical, horizontal, depends on the user's needs. And the last and the most important thing is that it can also work with other modules such as pandas, scikit-learn, TensorFlow, PyTorch, and etc. So the first and the most important thing, what we're going to do over here is we're going to create a new project. So first off, click on New Project. There we go. We have created our project over here. Now we're going to inherit the packages from base interpreter and make available to all the projects. And also make sure you have Python installed on your device, as you already have if you have followed up my classes up till now. Okay, now what we're going to do is we're going to just press on create, and we're going to wait until the interface opens up on our screen. So right after pressing on create, you can see it is updating the skeletons. It is also going to index all the modules so that we have Python, perfectly running and functional on our interface. Okay, now we're just going to wait for a bit until this part is updated, because that is very important so that the whole IDE is functional with Python. Now, after this is done, what we have to do is we're not going to create anything like a Python file, or we're not going to start, the practical part, but instead, the most important thing is that, just like I said, NumPy is a module of Python. So we have to install that first on our IDE. Now, I've also shown you that there are different methods of installing IDE, either from the terminal or either from here. But I prefer using this, so I'm just going to open up the terminal, and here I'm going to type in pip install NumPy. Hit on enter and wait for a bit. You will see there is a syntax warning, but it is going to install and download whatever is needed to make sure that NumPy is functional on your IDE, and also it works with Python properly. Okay, so let's just wait for a bit, and also make sure you are connected to the internet most of the time, because that is very important. There we go. It has collected the package, which is NumPy, and there we go. It is done. Now you will see that it is going to index for a couple of seconds, and after that you are basically good to go. And first off, after this, you want to create your let's say, the Python file. Okay, so just like I said, that it works with large data sets. So it is kind of like a listed data. Now, obviously I've shown you how lists work in Python, but whenever you are working with big data sets, machine learning, or even data analytics, make sure to use NumPy, because that is a lot better and a lot faster. So here, let's create our Python file. Let's say I'm going to make sure to name it example1. There we go. You can see we have example1 PYI. It's totally fine, but you can also put in PY. Okay, it's basically up to you. You can see if I put in new Python package, example2. There we go. So let's just use example2, and I'm going to delete this example1 because I don't need it. Delete. There we go. So we have example2 opened up over here. Now, first thing that we need to learn about is that whenever you are using NumPy, it basically needs a specific list. Now, if you still don't know how does a list look like, we basically use the secondary bracket, or known as these, the square bracket. Let's say I'm just going to put in lists, or p_list equal secondary bracket and 1, 2, 3, 4, 5, whatever type of data it is. This is basically a list. But we don't want to work like this. Instead, we want to use it as an array of data. So whenever you are working with array, including NumPy, what we basically do is we put in, first off, import NumPy as NP. And then we put in the array. So 1. Now I'm going to put in 1. I'm going to put in example underscore array equal np.array. There we go. Whenever you define np.array, NumPy is called. So np array, open parentheses first, secondary bracket, and now we can define 1, 2, 3, 4, 5. There we go. In this way, an array has been created. You can put in D types if you want to, but I'm just going to put in the list. That's it. Okay. Now here, let's say I'm going to print it out in a form of array. So I'm going to put in example array and run the whole thing. That's basically it. When you print it out, you will see it is going to print out just like this. So that is basically a NumPy array. Okay. Now that you have seen the array, let's also put the same thing in rp lists equal 1, 2, 3, 4, or whatever it is. Let's just keep it up till 5. And I just want to print it over here. Print PR list. Let's just run this. And there we go. Now you can see both of them has been printed. The first one is a NumPy array, and the second one is basically a Python list. Now there are a couple of differences that you can already see is that in a list, the commas are visible, but in the array, the commas are not visible. Okay? So one thing over here is that there are a lot of difference. In a Python list, the speed of it to work and process is a lot slower, while the NumPy array is basically much faster than the Python list. The storage of Python list is a bit slower and a bit scattered. But the NumPy array, or whenever you are working with NumPy array, it is a continuous memory. So it doesn't give you any error, and it just keeps on printing, keeps on processing without facing any problem. In a Python list, you might see that sometimes there are some loops that are needed. You cannot work with it, you cannot print it, you cannot see it on your console. But when you are working with NumPy array, the measurements which you have are basically vectorized. So the measurements are super accurate and without any error. In that way, it doesn't give you any problems, and it can work with a large data set and give you the exact measurement. And also, when you are working with Python list, sometimes you can work with a lot of mixed type of data, such as you can use strings, you can use numerical data, float data, you can use integer, all of them. But when you are using NumPy array, it can only use these integer and float values. It cannot work with string values. If I put in, let's say, word, or double quotation, word. Let's print this out. You can see we have word over here. But when you are trying to do an operation, it is not going to work. So it's only going to validate the same type of value. This word that I have put in, even though you can see in the previous one, there was no quotation available. So if I just remove this and put in 3 again and run the program, you can see there is no quotation on any of them. Because when I put in the string value inside, all of them turned into a string value. So we cannot work with any operations then. But if we just remove the string from the float or the integer, it will only work with string, or let's say not string, but integer values. So you have to keep that thing in mind, is that NumPy array validates only one type of data inside the array. Okay? Now, let me also give you a couple of proof that why NumPy is a lot faster than Python. Okay? So let me just open up another Python file. So I'm going to put in test. First things first, I'm going to put in import NumPy as np, import time. So we can check what is the difference. First off, I'm going to have the py.li, which is the list. So I'm going to have a list and a specific range. Let's say 2_00_000. And I'm going to put in np_arr equal np.array. Open it up, and here let's say I'm going to put in the py list. So we have the exact same data. Now I'm going to put in start equal time dot time to make sure that the function works properly. I'm going to have the list that is going to be over here equal. Now we're going to put in the secondary bracket. Let's say I'm going to put in x multiplied with 2 or 3 for x in the list. On the next one, I'm going to put in print, let's say listing time. Okay, put in comma, time dot time, parentheses, put in minus, and then I'm going to make sure it starts up the function. I'm going to put in start equal, put in time dot time, open the parentheses. I'm going to put in np dot array, which is going to be just underscore array. np underscore array again, but it is going to be multiplied with 3. The same operation. And here I want to print out, let's say, numpy time, comma, say time dot time, open the parentheses, minus the start value. That's basically all that you need to do. So this is going to be our function. Now let's try running the whole thing. And you might see that there is an error over here. We're going to check which line it basically is. Line 13. We have time, comma, time. So I'm going to put in time dot time. Run this program. And there you go. We have numpy time, which took like 0.00 and then 4. But the listing time took like 0.1380. So that is a lot lesser than this one. Even though this is a very small process or a very small operation, that's why it took a lot lesser time. But if it was a very big data set, then it would have taken a lot of time and we would have seen a lot of difference. But as you can see the number, numpy time or numpy takes a lot less time than Python listing. Okay? So there we go. We have the, proof over here, which is going to help you to understand a lot better. Now, next thing is that we're going to learn about arrays. Now, what are arrays and how are you going to create the array in Python? Okay? So first of all, let's create another Python file. Let's say array 1. Okay? So first things first, what I'm going to do over here is that I'm going to import numpy as np. Now let's create a variable. X is going to be equal to np.array. Open the parentheses, secondary bracket. Let's say 1, 2, 3. And I want to print out x. If I print this out, the array is printed. Now, what if you want a multi-dimensional array? In that case, what we can do is we can open up or go onto the secondary parentheses. Now, one thing is that I'm going to make sure I put in 2 parentheses or 2 secondary brackets. And also, after this, I'm going to put in a comma. There we go. Now, over here, I'm going to make sure to put in another secondary bracket. Here, let's say 4, 5, and then 6. Now let's just close this off as we have 2 secondary brackets. There we go. Now, if I want to print out the exact same thing, I'm just going to run this, and there we go. We have 2 arrays or multi-dimensional array. Okay, and you can see there are no commas to differentiate the value. Now, we're going to also learn about how you can put in arrays with zeros. So, let's say we're going to put in zeros equal np.array parentheses, 2 parentheses basically. let's say 4 comma 5. Now we have two parentheses open. If I want to print this out, let's say zeros, run the program, you will see we have 4 and 5 at the end. Okay? So even though this is not like, a total 0, but there are no zeros over here, and also it starts from the beginning. Okay? Which makes it a lot more easier for you to understand. Now, what if you want to print it out with ones? If you want to print it out with ones, you can do that. It's basically just changing the variable. So let's say ones equal np dot array, open up the parentheses again, and here let's say I'm going to put in 2 comma 3, print ones. There we go. We have this over here. Now, what if you want to arrange it with arrange? Okay, you can arrange your value just how you want it to be. So what you can do is, let's say I'm going to put in arr equal np dot arrange, not array, but np dot arrange. Okay, another thing you can see over here is that we have array put over here. Instead, what you can do, you can change these, say zeros, and on ones, you can put in ones. And here I'm going to put in arrange, parentheses, let's say 0 comma 5 comma 3. And on the next line, so here I'm going to type in print, and I'm going to put in arr. That's it. Now run the whole thing. Now you can see sometimes that, it might show you off as an error attribute. You can see np.arrange. Okay, but here I want arrange, not arrange. So run this again, and there we go. Now you can see we have zeros, we have ones. Okay, so we have 4 zeros, 1, 2, 3, 4 lines, and there are 5 on each and every one of them. In the same way, we have 2 of these, and there are 3 of ones in each line. So this is basically how you can work with arrange. Okay, you can see we have 0, 3, and we have basically removed 5, which is not over here, which is not arranged because 5 does not belong on the index first, but 0, 3, and then 5. Okay, so that is basically how you can work with arrange. Now, the last thing that I want to show you is how you can have even spaced in between the printed one. Let's say I'm going to put in arr1 equal np dot line space. There we go. Basically, it's like linspace, but we can put it like that. And here, let's say 2 comma 5 comma 8. So we have 2, 5, and 8. If I print this out, arr1, and you want to run the program, and there we go. We have 2 over here, 2, 3, 3, 4, 4, and 5. There we go. So this is exactly how it is going to start and also how it is going to end. Now, as we're done with this, now let's get into more of the intermediate functions, which are array indexing and also slicing. I'm also going to show you a couple of operations. So let's create another Python file. There we go. Okay. So I'm going to put in array index. So we have array index, okay? First things first, let's say I'm going to put in arr equal np dot array. Open parentheses, secondary bracket should be over here. Let's say I want 10, 20, 30, 40, 50, 60, and also 70. Okay? Now, if you want to index it out, obviously in Python, you know it starts from 0. So basically, it's quite the same. So you basically just print out the ARR, secondary bracket. Let's say if I want to print out 30, so we have to count from here 0, 1, and 2. So I'm going to put in 2. Then I'm going to print out. Now, what if you want the last value of the array? First off, put in array, and then put in -1. As this is 0, so if we just rotate all the way back, then -1, -2, -3, -4, -5, -6, and -7. So if we just put it like that, it is fine. Now, what if you want to have a slice? If you want to have a slice, I'm going to put in, let's say, print ARR, secondary bracket. Let's say I'm going to slice it from 1 to 4. So 1 is 2, 4. If you just print them out, you will see that we have np.array. It is not defined, so here I'm going to put in import numpy as np. Run the program, and there we go. We have 30 and we have 70. And just like I said, we want it from 1 to 3 or 1 to 4, as 4 is exclusive. So 1, 2, 3. And 4 is basically 50, so 50 is removed. Okay? So this is how you can work with 1D array. Now, what if you want to work with two-dimensional array? If you want to work with two-dimensional, let's say I'm going to put in ARR2 equal np.array. Here, put in 2 of these secondary brackets. I'm going to start off over here. Let's say 10 again, 20, 30. There we go. I'm going to close it off over here. Move on to the next line. Secondary bracket. Let's say 40, 50, 60. That's all. Also make sure to put in a comma over here. So on the next line, I want to print out ARR2. Now, secondary bracket. Now, first off, as we're going to work with rows and columns, so starting off, if you put in any value, it is the row. And the second value is the column. So on the first row, let's say 0, put in comma. Which column of data do you want? Let's say 0, 1, 2, 0, 1, 2. So I want 20. So I'm going to put in 0, 1. Now, print ARR2, secondary bracket. Let's say I want 1 and put in comma. And let's say I want 60. So I'm going to put in 2. Now, let's say I want all rows and only column 1. So I'm going to put in ARR2, after ARR2, secondary bracket, colon, comma, and I'm just going to put in the first column. That is how it should look like. I'm going to put in print ARR2. Then I'm going to put in secondary bracket. Let's say 0 is to 2, comma. And next one is going to be, as this is a submatrix, 1 is to, let's say 2. That should work. Now, if I just print out the whole thing, this is exactly how it should print out the data. Okay? So now you know how you can work with 1D array and also 2D array. As we have learned about the indexing and slicing, let's also learn about the array operation. So, first off, let's create another Python file. Let's say OPT, that's I'm going to name it. Now, there are arithmetic operations, which are obviously vectorized, and there are array-to-array operation. So first things first, let's say I'm going to put in ARR equal, first off, let's just put in import numpy as np. ARR, and I'm going to put in np.array. Okay, parentheses, secondary bracket. Let's say I'm going to put in 2, comma 3, comma 4, comma 5. That's all that I need. Now, another thing that I'm going to do is for the next one, put in ARR2. In this, I'm going to put in np dot array. Same thing. So we have up till 5. So here, secondary bracket, I'm going to put in 6, comma, 7, comma, 8, comma, and 9. That's all that I'm going to do. Now we have both of these array. But first things first, for the arithmetic operation, I'm only going to use the first array. Let's say print out ARR plus, let's say I'm going to add it up with 6. If I print this out, there we go. It's going to add up 6 to each and every one of the numbers. In the same way, if I put in ARR multiplied with 2, it is going to multiply every number with 2. If I want to divide it, ARR divided by, let's say 2. Run the program. There we go. In the same way, you can also have a power, which is an exponent. So print out ARR, double asterisk, and 2. Run the program, and there we go. We have the exponents too. Now, what if you want to do array-to-array operation? If you want to do that, let's say I'm going to put in print, let's say ARR, and I'm going to put in space, plus ARR2. In this way, it is going to just add up each and every one of those values. And this is exactly how it will look like. If you want to multiply them, print out ARR multiplication ARR2. In this way, it is going to multiply each and every one of the values. It also works with the division. So just put in print ARR divided by ARR2, or ARR2 divided by ARR, or which is the first value. There we go. We have done arithmetic operations and also array-to-array operations too. So this is exactly how simple it is. Now, what if you want to do some functions, such as mathematical functions? If you want to do some mathematical functions with NumPy, such as, let's say I'm going to put in print, and after print, I'm going to put in np.sum, and then define our array. If I run the program, there we go, we have 14. Now let's say I'm going to put in these values to a stop for now. So we printed out this summation. If you want to do some mean value, let's say I'm just going to copy this, paste it. Now instead of sum, let's say maybe I want a mean value, so I'm going to put in mean and run the program. It will find the mean value. If I want to get, let's say, the minimum in the array, I'm going to put in minimum. This is going to find the most minimum or least value. If I want the maximum value, I put in max and run the program. And also if I want the standard value, just put in std. That's it. There we go. This is exactly how it works. If you want to reshape anything, you put in, let's say, ARR3. I'm just going to put in ARR3 equal np dot arrange. Let's say 12. And here, I'm going to put in reshaped equal ARR3 dot, I'm going to put in reshape. Okay? Let's say I'm going to reshape it with 3 and also 4. And I want to print out the value reshaped. Run the program, and you will see it is going to have every values from 0 up till 11 because 12 is exclusive. If you want to flatten any value, then type in print, and put in reshaped dot flatten. Open up the parentheses, run the program, and there we go. It will flatten it up in one dimension. So this is exactly how simple it is to work with arrays. Now let me just show you a simple project of creating a 3x3 matrix and also compute. So let's just create a Python file. Let's say I'm going to put in mini prj. First off, type in import numpy as np, put in mat equal np.array. Now I'm going to work with three-dimensional value. So I'm going to put in secondary brackets. There we go. Let's say I'm going to put in 10, 20, 30, comma, go to the next line, secondary bracket, 30, I'm going to put in 40, 50, 60, comma, I'm going to put in secondary bracket, 70, 80, and also 90. There we go. And that's the end over here. After that, what I basically want is the total sum, the also row-wise sum, and column-wise sum. Okay? So let's just print them out. Let's say total summation, comma, let's say np.sum. I'm going to put in mat, that's it. I also want to get, let's say, the summation of the row. Here I'm going to put in np.sum. Okay? Open up the parentheses. Let's say I'm going to put in mat, comma. Now, obviously you know in vectorized data there are two axes, x-axis and y-axis. So here I'm going to type in axis equal 1. That's it. In that way, the first row will be summed up. In the same way, if I want to print out the column, so I'm going to put in summation of the column, comma, np dot here, I'm going to put in sum again, parentheses, mat, comma, axis equal 0. Here, just run the program, and there we go. We have total summation, summation of rows, and also summation of the column. So this is exactly how you work with array and also NumPy. So the summary of this class is that NumPy is a foundation of AI and machine learning. It helps you to work with arrays and operations. There are specific essential functions for AI, machine learning, and big data set. And also you can see we worked with, a mini project. So hope you understood about everything in this class. And thank you for watching the video up till the end. If you have any problem or any confusion, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data set. Welcome back to another class of AI, machine learning, data science, and big data analytics. The topic of this class is Introduction to Pandas and data frames, such as loading, cleaning, and also transforming data. Now, I have made this class in separate parts so that it is easier for you to understand. Now, the most important thing that you have to keep in mind before starting the class is that you have to make sure you are connected to the internet, because we're going to be working with a lot of modules or Python libraries. So to make sure those are installed perfectly on your device, without internet, it is not going to work. Now, what you're going to do is make sure you have checked out my previous videos. Now, if you did not, it is going to be a bit tough for you to cover up every topic about this class. So I would suggest you go check out my previous videos and then continue this class. So the first thing that we want to do is open up PyCharm, or if you're not using PyCharm, open up any IDE that you prefer using. So just as you can see on my screen, I have opened up PyCharm. Now let's click on New Project. I'm going to inherit the packages and make sure you have Python, the latest version, installed and detected on your device. Now press on Create to create your environment. Just as you can see, I have created my virtual environment and my project is now on. Now, besides pandas and also the data frame, we're also going to be learning how we can load the data by creating it, how we can save it, and then using it later on. By the end of this class, we're going to learn about a lot of things, and then I'm going to give you the summary. And if you want to, I'm also going to give you an assignment which you can practice alone, or you can reuse or repeat the codes that I will give you in this class so that it will be easier for you to learn, and also it will give you an idea about how to work with it. So, just like I said, as we're going to be working with a lot of modules, make sure you are connected to the internet. So, first off, we have to know what is pandas. So pandas is also a kind of a module or a library of Python. It is basically used for data analysis, cleaning, manipulation, loading, and also saving your dataset. Basically, if you work with data science or even, let's say, machine learning, pandas is going to be very important for you, as it is known as to be the foundation of the works of data science or even machine learning. Now, you might think that if we want to work with data analysis, cleaning, and manipulation, we can do that with pandas default, or maybe even like, NumPy. But why are you going to choose pandas is because whenever you are working with pandas, it makes your data look like an Excel sheet, which basically makes it easier for you to sort, analyze, filter, process your big data workflow. And another thing, or the most important thing, is that with pandas, you can also integrate a lot more other modules, such as in my previous class, I've shown you NumPy. You can use NumPy along with it. If you want to use Matplotlib for visuals of your data, you can do that too. You can also use scikit-learn and even TensorFlow, so that any type of data that you're trying to work with, everything can be analyzed, cleaned, transformed, or even loaded. So first things first, we're going to open up the terminal. Inside the terminal, first off, I'm going to type in pip install pandas. Now, make sure you are connected to the internet, because if you are not connected to the internet, it is not going to download the necessary things that is needed for your PC or that is needed for your IDE to run these specific modules. Okay, now let's just wait for a bit until those are downloaded and installed successfully on your device. Now, as you can see, it shows us that successfully installed NumPy. After NumPy or pandas is installed, the next thing that we want to install is going to be OpenPyXL and also Workbook. So type in pip install Workbook. Hit on enter and wait for a bit. It will also show you that it is going to download the necessary things. And the last one is going to be OpenPyXL. So pip install OpenPyXL. Hit on enter and wait for a bit, and you will see in the same way it is going to install all of the packages that is needed for it to function properly. Now, we don't need to install JSON, but if you still cannot work with JSON, open up your Python interpreter, go off to interpreter settings, and check it if JSON is working. Now, even if you don't check it, or even if you don't find it over here, what you can do is first off open up another Python file. Now, as we're going to be learning how to, let's say, use those data sets or data frames, we basically need these type of modules or these libraries. Okay, so make sure to keep those things in mind. Now, as we have pandas, OpenPyXL, and also workbook, now we can start off our practical class. Now, first off, we're going to learn about the data frame basics and also the series of data. First of all, we need to know how to work with pandas. So open up a Python file. Let's say example 1. Over here, whenever you are working with pandas, just like NumPy, you want to type in import pandas as PD or whatever you prefer to trigger the word. Okay? So after the PD, you're going to type in your listed data or whatever array of data you have. So first off, I need to create a variable. Let's say no equal, I'm going to put in nos, equal pd dot series, as these are known as series of data. Let's say 20, 30, 40, and 50. So these are my series of data. Now I'm going to print out the nos, which is my variable. Run the program, and you will see we have our series of data, and also on the left side, we have our index. So why? It is because when you are working with these type of data or pandas, just like I said, it treats your data and visualizes your data just like an Excel sheet. So it is easier for you to classify, filter, sort, analyze, and even, process those data. Now, these are basically known as data frame. But whenever you are working with a better data frame, or let's say a default data frame, it is going to be a full table in a series, or let's say in a sheet, such as it will be called out with df, or just the exact keyword of data frame. Okay, so first things first, let's say here I'm going to have a data equal. Now, whenever you are creating a data frame, obviously when you are working on an Excel, you have the header, which is the category of data or filtering of the data. So third bracket, hit on enter. Now, what header or what category of data you want? Let's say I'm going to put in user. Okay, so after that colon, and then put in the exact names. Let's say, what user is this? Let's say Jim. Then I'm going to have, let's say, Ada. And also, let's say, Leroy, comma. Now, obviously, we don't need just one data or one category of data. Instead, let's say I'm going to have the code. Let's say here I'm going to have 26, 27, and also 28. That is going to be their code. Also, let's say I also want their region or server. I put in serv. So let's say this one is on the C server. Let's say the next person is going to be a Middle East. So I'm going to put in MIEA. And the last one is going to be, let's say, the US server. Okay, so that is going to be my data. And after I'm done, we don't need to put any comma on the last category of data. So after that, we're going to create df equal pd dot data frame. Open up a parentheses and type in your variable. On the last line, I'm going to print out the data frame. Now, if I just print out the whole thing, you will see this is exactly how it will look like. You can see we have the header, we have the index, And also we have the type of data. So Jim code is 26 and he is on the C server. We have Ada 27 MIEA, we have Leroy 28 US. So basically it looks like an Excel sheet. And the rows that we have are basically records, and the columns basically have our attributes. And every column that we have is obviously a series of data. Okay? So that is basically how you can create your own data frame, and that is basically the series of data frame basic. Okay? Now, on the next thing, what we're going to learn about is how you can load up data sets. Now, there are different types of, extensions of data set that you can find. Now, some people use CSV, some people use Excel file, and even some people use JSON. So how are you going to make sure to, let's say, use them? Before using them, you also have to know how you can create them. So first off, let's learn about how we can create those files. First off, I'm going to create a Python file. Let's say I'm going to type in create. Okay, so we have create.py. Import the modules first. Import pandas as PD. Import, let's say, OpenPyXL. I'm also going to import, say, workbook. And at the end, I'm going to import JSON. There we go. So basically we have all the things that is going to be important for working. Okay, so instead of import, I'm going to put in from OpenPyXL import workbook. Now let's create our sample data set. Okay, first off, we need the data. So data over here equal third bracket, let's say username. Here, the secondary bracket, let's say Alan. Then I'm going to put in, let's say, Barry. Let's say I want Charles. Then I also want, let's say, Dave. The next one is going to be, let's say, their age. Let's say their age. Alan is 25. Barry is 21. Charles is 34. Then Dave that we have is going to be 19. Now, also I'm going to put in their country, whichever country they're from. Let's say Alan is from the USA. Barry is from Scotland. Charles is from, let's say, UAE. And Dave that we have on the other hand is from Finland. Okay, so we have the data. Now on the next part, I'm going to put in df equal pd dot data frame, open parentheses, and type in data. So first off, I want to save the data as CSV. So I'm going to put in CSV underscore path equal double quotation. Now put in the exact name. Let's say sample data.csv. On the next one, df dot to CSV. In this way, your data is transformed into CSV. So I'm going to put in the CSV path, which is the variable, comma, and then put in index equals to false. So that is done. Now on the next part, I want to save the data as a JSON file. So put in JSON underscore path equal, same thing. Let's say I'm going to put in sample underscore data dot JSON. Here, what I'm going to do is make sure to put in width open up the parentheses, JSON underscore path, comma. Now, as we are creating this file, which means we are writing this file, double quotation, put in W. Here, I'm going to put in as f, okay, which is also a type of variable. Here, I want to create a dump file so that it is done or made inside my virtual environment. So here, I'm going to type in json.dump, open up the parentheses, data, comma, then put in f as the variable, comma, and I'm going to put in an indent, not an index. So here, indent is equal to, let's say, 5 or 4, whatever you prefer. Let's say I'm going to put in 5. Now, the most complicated, or the part which requires a lot of code, is only saving the data as an Excel file. First off, I'm going to put in xlsx underscore, put in path, equal, double quotation, sample underscore data dot xlsx, which is the extension. Now, in Excel or in a spreadsheet, first off, we need a workbook. So WB is equal workbook, open the parentheses. Then inside the workbook, we have specific worksheet. So we have to select the worksheet which is active. So WS is equal to WB dot active. So it selects the active worksheet. Now I want to append the data in a listed format. So WS dot append. Inside append, I want them as a list. Open the parentheses again, data dot keys. Okay, so we have these specific keys, and we also want to make sure to open the parentheses again. Now we have the data in rows and also columns. So for row in zip, inside of zip, open the parentheses, asterisk, and put in the data values, data dot values. Open the parentheses one time, and that is basically it. Okay, so make sure to put in a colon at the end, and then you want to append the data in a listed row. WS dot append, type in list, open the parentheses, and define in row. After that, we want to save the file. So go into the indentation at the beginning, WB dot save, open parentheses, and define the file name, which is xlsx. There we go. Now at the end, I'm just going to make sure to define them. So I'm going to put in CSV underscore path, comma, space, JSON path, and also xlsx. So that is basically it. Now if we run this program, you will see finished, and all of them has been created over here. Sample data CSV, sample data JSON, and sample data xlsx. In this way, all of the data has been created. Now, what we're going to do, or the last part of this class, is going to be, let's say, working with these data sets. So we're going to start off by reading these files, cleaning these files, and also we're going to remove the duplicates, and then we're going to work with data transformation. Okay, so the first thing that we're going to do is reading these files. So first off, let's create another Python file. Let's say I'm going to put in test read. Okay, first things first, let's say import pandas as pd, df equal pd dot read underscore CSV. Now, as we have the CSV, now which file do we want to work with? So let's say I want to work with the sample dataset or sample data.csv. Now we want the first 5 rows. So I'm going to print out, let's say df.head, open the parentheses, run the program, and there we go. we have all of the data. Okay? In the same way, you can see whenever we put in read, there are other formats too. Now, one thing you have to learn over here is the read CSV and also the head. What do these actually do? When you put in .read CSV, it loads the comma separated data, which is the extension of the file. And also, when you put in head, it gives you a quick preview of the file that you want to work with. Let's say if you want to read out your Excel file, instead of CSV, read underscore Excel. Okay? So instead of df, I'm going to put in df underscore Excel. So we have pd.read Excel. Then instead of CSV, we just put in XLSX. And we print out the exact same thing, but here df underscore Excel dot head, run the program, and you can see in the same way the same type of data will appear up. Okay, so it's basically the same for the JSON file too. Type in JSON, also do the same thing over here, type in JSON, do the same thing over here, just change it to JSON, and also do the same thing over here, JSON. Run the program, and there we go. We have the exact same data in the same way, reading up in the exact same manner. So this is basically how you read your data from different formats. Now, this is the most important thing, which is cleaning. Okay, so cleaning is very important because in data science, the data that you have changes rapidly like evolution. So you have to change it and you have to clean it when you don't need it anymore. First off, we put in df.info. So let's say I also want to print out, let's say df underscore JSON, then put in .info. If I run this program, you will see it will give me out the exact type of data. You can see we have integer value, we have objects, we have non-null, we have username, age, country, we have data types which are integer, which is 1, and object, which are 2, which is also the string value. Now, it also shows you in columns, rows, indexes, 0 to 3, there we go, all of them. If you have any missing values, it will also show you. If you want to check only the missing values, what you basically have to do is type in print df underscore JSON, which is it, and then type in is null. So type in is null, open up the parentheses, just like this. Okay, make sure to put it exactly the same. After that, after the parentheses, put in .sum. Also open up the parentheses and run the program. When you put the program just like this, it is going to run it just how you want it to be. Now you might see that you can see the sum takes at least one positional argument and 0 given. So we don't have anything to print out over here. Okay, you can see JSON is null sum. So instead of that, I'm just going to put in .sum. Run the program, and there we go. In all of the category of data, there is 0 null value or 0 missing value. If you find out that there are any missing row, you can do that too. What you basically do is put in df underscore cleaned. df JSON underscore cleaned equal df.drop any. Now in this manner, what you can do is you can remove the missing rows. Run the program, and there we go. You can see we have this parentheses at the beginning, which is never closed. So what you basically have to do is that we're going to check out the exact line where it is, which is on line 8. So we're going to close the program and run it back again. Now you can see we have df.drop any. Now that is not just df. What we have to do is underscore JSON. Run the program, and there we go. If there is any missing row, it is going to remove the whole row from the data, or let's say from the data set. And if you want to fill in any missing values, what you basically do is, let's say over here, I'm going to put in 0 over here and run this program again. It is going to have the exact same data, but here if I run these programs, you will see that there might be 0 once again. Okay? Because what we have created is already created. Okay? Now, one thing that I want to show you is how you can fill out the missing values. If you want to fill out the missing values, you put in df, whichever value it is or whichever variable it is. Now here, I'm going to put in underscore and type in any type of variable. Then put in df underscore JSON, not cleaned, but after that, you put in dot fill na, parentheses open, third bracket open. Now here, let's say if any age or any of the data has 0. So define 0, comma, and here, double quotation, city. If there is any value which is given here as unknown, then what I want to do is I want Python to remove all of those values. Okay? In that way, when you put in drop NA, this one, it basically deletes the row containing any null values, and when you are using fill NA, it replaces the missing value with any type of value by presuming, or even let's say just by checking the whole data, what would go better with the data. That's how it fills it up. If you find any duplicates in your data set, there are also specific function. Let's say df JSON underscore, let's say dup. I'm going to put in duplicates equal. I'm going to put in df JSON. After that, here I'm going to put in dot drop underscore duplicates. In that way, if there is any data that contains any duplicates, it is going to remove it directly. Why are you going to do it? Because sometimes when you have those duplicate data, it can cause some incorrect analysis. So what you basically have to do to train your models is clean up your data just by using these type of functions. Okay? So that is basically how you work with dataset. Now, the last thing that we're going to learn in this class is going to be data transformation. So let's create another Python file. So first off, we want to select the columns. So first things first, we have to make sure we print out the data. Here, I'm going to just make sure to use these type of data. Control C. And instead of just JSON, I'm just going to put in a df. Okay? And over here, we have the data. You can see this is the exact data that we are using. Or we can just copy this. Control C. There we go. If we run this program, you can see data frame is not defined. Here I'm going to put in print, or let's say import pandas as PD. Okay, so you can see PD is not defined, so run the program again, and there we go. We have the data. Now I don't want to print out the data, but have the data over here. Now in this data frame, I want to select columns. So print df secondary bracket double quotation. Let's say I want the usernames. So put in username, run the program. There we go. We have the username. What if you want to get the country at the same time? So after the username, put in, let's say, a comma, double quotation, let's say country. And as we have two of them, I'm going to put in two secondary brackets. There you go. We have two secondary brackets. So close it off with two secondary brackets at the same time. Run the program, and there we go. We're going to have the username and also the country at the same time. Now, what if you want to filter your rows directly by printing? Let's say I'm going to have adults equal df, secondary bracket df again, secondary bracket, now defined in the age. Let's say I only want to get people who are above, let's say 20. Okay, I'm just going to put in 20. Anybody above 20. Okay, so here I'm going to print out adults. Run the program, and there we go. Only Alan and Barry is an adult. Now I'm going to sort out the data. So I'm going to put in sorted underscore df equal df dot sort underscore values. Let's say I'm going to get the age, comma. Now, as I want to sort them out, I want them in a descending manner. So here, I'm going to put in ascending equals false. And at the end, I'm going to print out sorted data frame. Run the program, and there we go. We have it. Alan, Barry, Dave, and Charles. But you can see on the age, we have 25, 29, or 21, 19, and then 0. Okay? So this is exactly how it works. What if you want to add in a new column? If you want to add in a new column, we put in data frame, secondary bracket, let's say age, underscore, let's say 10 or 15 years later, equal df, secondary bracket, let's say age plus 15. If I run the program, you will see it is not going to show up, okay? But it is going to add it up, okay? So you have to keep that thing in mind. Now, as you can see, we have this over here, which is df age 15, like this. Now, if we print out, let's say, data, or just the data frame, run the program, and at the end, you can see we have age 15 years later, 14, 40, 36, 15, and 34. So this is exactly how it works. Now, the last thing that I want to show you is how you can group and also aggregate, which is very important for machine learning, data preparation, and even sometimes in AI. Let's say I'm going to put in country group equal df dot group by. Open up the parentheses. Now let's say I want the country first. After the country, I'm going to put in the age. Then I'm going to get the mean value. Then I'm going to print out country group. Run the program, and you will see we have the country group 19, 21, 00, and also 25. So the group data is shown in a column, and when you want to aggregate the functions, you have to basically just put in those, mean, sum, minimum, and maximum functions, which is basically just keywords. So that is basically it for this whole class. So what you have learned in this class is what is pandas, what are series and data frames, how to load in CSV, Excel, and JSON files, also how you can create them, how to clean up missing and duplicate data, and how you can sort, filter, and also transform your dataset. Now, what you can do as the project is you can load up your own file, removing the duplicates. You can fill in the missing values. you can create a new column. Let's say, as I have created the country group, what you want to do is create an age group. And also, what you should do is group the age with the country and find the average age. Okay? So that is going to be it for this class, and hope you understood about everything. If you have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data set. Welcome back to a new class of AI, machine learning, data science, and big data analytics. The topic of this class is handling missing values and data merging, grouping, and also aggregation. So I have separated this class in specific parts so that it is easy for you to understand and also to get you a clear idea about the functionalities and also what functions are you going to use to handle your data and also for, let's say, organizing or processing your values. So make sure not to skip any part and make sure you are connected to the internet so it is easier for you to progress with work and also understand and also practice along with me. So without any further ado, let's open up PyCharm, but if you're not using PyCharm, open up any of the IDE that you prefer using. So just as you can see, I have opened up PyCharm. First off, let's create a new project. Now make sure you select up Python version and then press on create. Just in a couple of seconds, you will see the virtual environment will be created, and also it is going to update these skeletons. After your skeletons have been updated completely, you'll be able to work with your interface. Okay? Now, first off, you have to know why are you going to do or why are you going to fix up missing values. So in a couple of dataset, you're going to find out missing values, and that is a very common thing. Now, let's say, as you're working or as you're preparing for machine learning, AI, dataset, and big data analytics, and to create your AI model, you need to clean your data. So, in couple of files or in multiple files, you will see there is going to be a lot of missing values. Without those missing values, or let's say while keeping the missing values, it might not give you the best or the most accurate data when you're processing it. So it is very important for you to clean up your data. Also, whenever your data sets come in multiple files, you need to merge up your data and also aggregate them. So when you're aggregating your data, cleaning your data, even merging your data, what you basically do is you use the function which is called group by and also aggregation so that you can process the data and also even summarize it. That is why missing or fixing the missing values in your data is very important. First things first, we want to create a CSV file. Let's say I'm going to put in pupil.csv. So we have our CSV over here. You can see our supported. So we want to put in, let's say, name, comma, put in age, comma, and also the points. Here, I'm going to put in the first one is going to be John, age is going to be 17, and the point he got was 87. Let's say next one is, let's say, Simon. Let's say the next one, I'm going to keep a missing value, and the grade this person got is 67. Then I'm going to put in Mike. Mike is 19 years old, but there is a missing value. Then I'm going to put in, let's say, Laura. Laura is 18 years old and she got like 98. And the last one is going to have 2 missing values and that person got 79. So that is going to be it for this person. Now, what you want to do is we want to fix up these missing values. Okay? Now, you can see plugins supporting CSV files found. We want to install the plugins. So, you're going to need an internet connection to make sure that those plugins are installed properly. Okay? So, first things first, wait for it to search for the plugins in the repository. Now, even if you don't want to do that, it's also completely fine. But sometimes it's just better to have one of them available. Press on OK. I'm going to click on accept, and you can see it has been updated and also applied. Okay. Now, what I want to do is I want to restart and activate the plugin updates. So just click on this. If you don't want to use those extensions, it is also totally fine. Now, I'm going to create a Python file. Let's say I'm going to name it test. Here, what I'm going to do is first off, I'm going to import pandas. If it is not available, open up terminal and type in pip install pandas. Hit on enter and wait for a bit until everything is installed and it is installed successfully. You will see on the last line, it is going to show you successfully installed NumPy pandas. If that appears up, that means pandas has been installed perfectly. But if it does not show you that, that means there are a couple of things that are not able to download and install perfectly on your device. So make sure you have a stable internet connection. Wait for a bit until it shows up, and you can see successfully installed NumPy pandas. Now pandas as PD. I'm going to load the dataset. df equal pd.read_CSV. Open up double quotation. Here, I'm going to put in pupil.csv. Now, I want to print out, let's say, the original dataset. And also, I'm going to put in printout df. Run the program, and you will see we're going to get the whole dataset, something like a spreadsheet or like a table. And you can see the CSV is working. Now you can see in a couple of them there are NaN value. That means there are no values in those specific places. Now, how are you going to find out those missing values? To find out those missing values, first off, I'm going to put in function to find missing values. What you want to do is type in print df.isNull. Open parentheses. Now, basically what this shows you is it gives you a true and false for each missing value. Wherever there is an NaN error or NaN value, it is going to show us as false. There we go. We have false, false, false. So it is the opposite. You can see it is true, which is over here. Simon is true. There we go. We have last true, true, which means there are true missing values. Now, what you can also do is you can also get the sum of the missing values. Let's create another section. Function to sum missing values. So I'm going to type in print df.isNull. Open the parentheses, and after that put in dot sum. Open the parentheses again. It counts missing per column. So run the program, and you will see name is 1, age 2 missing, and points is 1 missing. So when you put in isNull, it basically is the function to check each cell. And when you put in sum, it basically counts the missing values per the column. So it also helps you to understand and detect up how bad missing values are available on your dataset. Now, as we know how to find out these missing values, how to sum up these missing values, what if you want to remove the missing values? So let's say I'm going to create another, let's say, variable. Let's say here, function to remove NaN values. Let's create a variable. Let's say clean data frame equal df dot drop na. Well, if you've checked out my previous class, you already know about it. So here, print clean df. Run the program, and you will see it is basically going to clean out all the cells or all the rows which contains those missing values. Okay? Now, what if you want to remove rows only if all values are missing? So, we're going to put a condition. Let's say function to remove NaN values if row contains all NaN values. So I'm going to put in clean underscore df1 equal df dot drop na. Here, how is going to be the condition? Single quotation and all. Run the program, and you will see that any row which contains all values which are missing is basically going to be dropped. But except for that, it is not going to work. So, when are you going to use this? As you can see, nothing has been printed. It is because none of these rows contain all missing values. Some of them has all the values are one or two of the values, not all. If I remove all of this like this and keep the program running and run the program again, you will see nothing has been printed over here. There we go. We have NaN on all of them. Okay? So I'm just going to make sure to put in any specific number and then run the program. There we go. Nothing has been printed. So when are you going to use this? You are going to use these functions when incomplete rows are useless for analysis. But you have to keep in mind that dropping a lot of rows can destroy the data and give you, let's say, an unexpected result. So you have to make sure you are aware of your data too. Even though you are going to be using these functions to make sure that you have or you put in less time and effort, but I would still suggest you go check out your data set sometimes, because it is obviously good to be aware and be a bit careful. Now, the next thing that we're going to learn is about filling the missing values, which is also known as imputation. So let's say I'm going to create a section, function for imputation. Okay, what you want to do is put in, let's say, df fill. This is going to be my variable, df dot fill na. Now, what do you want to fill it with? Let's say I want to fill the all NaN values with 1. Run the program, and any of the data which is containing, the printed one, or let's say I'm going to print out clean df1, also print out, I'm just going to put in something like this. Run the program, and there we go. We have NaN. If we just remove this over here and run the program, you will see the last row will be missing. If we put in the value 56 again and then run the program, it is going to come back. Now, in the same way, we want to print in df dot fill. Run the program, and you will see any data which has NaN will be replaced with 1. Okay, so that is basically how it is going to work. Now, so basically this function is basically useful for numeric columns when, any value. Most of the time we basically use just a 0, which is basically used to like give it more sense. And Python and even pandas can give it a more, let's say, better operation or process it better when there is a numerical value instead of the NaN. Okay? Now, the next thing that we're going to learn about this class is going to be filling any value with mean, median, and also mode. So first things first, let's say here, say mean, mode, median. Let's say data frame. Now, which section or which category of data do you want to apply to? So basically, I want to apply to my age. So let's say age equal df age dot fill NA. Let's say df secondary bracket age, and then put in dot mean open parentheses. That's all. This is basically how you put in the mean value. In the same way, let's say instead of age, I want to put it inside my point. So I'm going to type in point. Over here, do the same thing. Type in point, fill NA, also df, point, and this is basically where you just change all the things. So here I'm going to put in median. Now, if I want to change the values of the names which are missing, and I want to print out unknown instead of NaN or 0 or 1, what I can do, df name equal df name dot fill NA df name. Okay, this is how you basically put it. But instead, what I want you to do is cut all of this fill NA with, let's say, no name. Run the program, and you can see this is how it shows up. Okay, you can see we have 0 like this. But if you print out data frame again, run the program, and you will see no name. And also in age we have a mean, so there is basically no 0 value or NaN. Even in the point there is no 0 value but NaN. Okay, but you can see we have filled it out with a median value. So this is basically how you fill up your NaN or missing values with mean, mode, or even median. Okay, in the same way you can type in mode. There we go. So it is basically now mode. So this is basically how you work with mean, mode, and median. Now, what if you want to work with backward and forward fill? So create a section. Let's say I'm going to put in forward / backward fill. Okay. Let's say I'm going to put in df dot, and then you put in fill. This basically shows, or this basically represents forward fill. df dot put in fillna. I'm going to put in method equal ffill. In the same way, underscore bfill equal df dot fill NA, method equal here bfill. If you want to run the program, print data frame. Run the program, and you will see, there we go, we have this error. Future warning, data frame fill NA with method is deprecated and will raise in a future version. So use object.ffill. Okay, so instead I can put in obj. Let's use obj, run the program, and you can see there we go, we have this error again because object has no attribute as object. Okay, so we're going to basically just change this format. If it keeps showing you this exact same error, what we can do is we can basically just remove this. Okay, so we have ffill, and instead of fill and a, I'm going to just put in ffill. Cut this off. Run the program and check if it shows you an error. There we go. Then we have printed the forward fill and also the backward fill. So this is basically how it works when you want to work with forward fill and also backward fill at the same time. So what forward fill does is that it copies the previous row values. As you can see, as it is copying, we're going to check out Simon. Okay, so it is going to basically just copy the previous one, but it's just going to add it up with 1. So it turned out to be 18. Okay, and also we're going to check out Mike 67. You can see this is 77, incremented by 10. In the same way, if I check out Laura, which is 18, and it basically just copied up 18. Now there are backward fill and forward fill on all of them, so it could basically just choose up any of the values that it is finding up as, let's say, none. Okay, so this is basically how you're going to work with filling out those missing values. Okay, now after this, hope you learned about everything up till this part. Now we're going to go to the next part of this class where we're going to learn about data merging, grouping, and also aggregation. So let's create a file. First off, I'm going to name it student.csv. So here I'm going to put in ID, let's say user, and also the age. ID1, let's say Jacob, and the age is going to be 17. Now for the next one, say 2, let's say Sarah, and this person is 16. 3, comma, let's say Mela, and this person is 18. And also 4, which is the ID, I'm going to put in Leroy. This person is also 19. So that is going to be our student.csv. Let's create another CSV file. Let's say grade.csv. Here I'm going to put in, let's say, number. Then I'm going to put in, let's say, English, and also literature. Okay, so number is 1. So 1 is basically John. He got 86. In literature, he got 98. For 2, he got 90 and also 87. For 3, he got 84. I'm going to put in 99. Number 4, I'm going to put in 92 and also 79. That is basically it. Now, what we're going to do is we're going to merge both of these data. So first off, let's create a Python file, as that already is available. Test 1. First things first, import pandas as pd, and then I'm going to put in students equal pd.read underscore CSV. First off, for students, I want to find out student.csv, and let's say for the scores, or let's say for the grade, equal pd.read CSV. Here, I'm going to find out grade CSV. I'm going to put in merged equal pd. Now this is where the functions are applied. If you want to merge up any data, just type in merge. Then I'm going to type in the variables, which is students, comma, and then the grade. Here, I'm going to put in on equal. I'm going to put in ID. Now, one thing that should be like the same on both of them, let's say instead of number, put in ID. So I'm going to put in ID over here. Okay? After that, I'm going to print out merged. Run the program. And there we go. We have ID, Jacob user, age, and we also have the English and also literature number. Okay? So this is basically how it works when you are merging up your data. So whenever you are using merge, it basically joins using common column. So one thing needs to be the same. Instead of ID, if I put in number, also here, put in number. If I run the program, it might show you off as an error. So here, we have to put the common one and run the program. And there we go. This is how it will appear up. Now, let's say I'm going to create a section. Let's say I'm going to find different variables. So I'm going to put in different types of data. Let's say pd.merge. Here I'm going to put in students, comma, grade. Let's say on, single quotation, number, comma. Here I'm going to put in how. First off, I'm going to put in this inner, which is basically the only matching row. Okay? So anything that is basically the matching one will be printed. So print it out, and there we go. The next thing that I want to do is keeping all the students. So PD. Now first things first, I'm going to print out the data. Run the program, and this is how it will appear. You can also change it whenever you want to, but I'm just going to keep it just like this. I'm going to copy this. I'm going to paste it. Now, on how, what I want to do is I want to keep all the ones on the left. So it basically keeps all the students. If I want to keep all the scores, I'm going to type in right. And if I want to keep all the rows, I'm going to put in outer. Run the program. You will see everything will be basically the same, but instead of merged, what you can do is you can turn it into a data frame, which we didn't do basically. But we can make sure that everything is turned into a data frame. But we don't want to do it right now, because that is going to make it a lot more complex. Now, the next thing that we're going to learn is grouping up the data. So I'm going to create a section with grouping. First off, create a variable grouped. Put in merged, which is the variable, and then type in group by, which is also the function which basically groups up your data. Now, what I want to do is I want to group the data with the age. So I'm going to put in age. and then I want to print out grouped dot mean value of the data. Run the program, and you can see it might show you off as an error. So I'm going to find it out group by. Then we have the age. You can see we have the age over here. And also you can see we have how mean dtype object. So first off, let's check out the exact line. Grouped mean. Okay? So if it doesn't show you off with the mean value, we can cut it off. So instead of mean, we can just first off print out how it basically looks. There we go. We have panda score, all of them, and also everything is basically grouped. Okay? But if you want to find out the mean value or the mode or the median, you can find it out however you prefer. Okay? Now, what it basically does is that it groups rows based on column values and also allows calculations per the group. Okay? You can see object at this specific value. Now, let's try running the program again. And this is exactly how it shows up. Okay? Now, you also have to understand why this type of error appears up. You can see mean dtype is an object, which means there is a string value. Now, if there is a string value, what you can do inside this parentheses is type in numeric only equal true. Run the program, and there we go. We have the mean value. So this is basically how it is going to work when you try to group data. Okay? And it also works based on column values and also allows your calculation process. Now, the one thing or the next thing that we're going to learn about in this class is the aggregation function. So I'm going to put in aggregation. Here, let's say I'm going to put in merged dot group by. Now, I'm going to open up the parentheses. First off, I want to group by with age dot aggregation. Parentheses, third bracket, and first off, I want English and literature. So, I'm going to put in English, colon, I'm going to put in mean, comma, and also for literature, here, what I want is, let's say, the median. That is basically it. If you run the program, you might see another error. But if it doesn't show up, then you will exactly find out how it basically looks like. If you want to print it out, you can also print it out exactly how you want it to be. Okay? You can also term it as a variable, and you can use like summation, maximum, minimum, count, and even standard. Now, the last thing that you want to learn in this class is going to be multiple grouping of columns. So, I'm going to put in multiple grouping columns. First off, I'm going to put in merged dot group by. Parentheses, secondary bracket. First off, let's say I want the age, and also I want the name. Now, I'm going to find the mean value. If you run the program, it might show you off as an error. Then, in the same way, what you can do is put the exact same thing, numeric only equals true. That is it. Run the program, and it might show you off working better. But if it still does not work, then there are specific things that you have to follow through. Now, this might show you off as an error over and over again, but here, after this, you want to type in print, put in merged, and type in columns. Run the program, and there we go. We have number, user, age, English, and also literature, which are all object. And what I did was put in name. But in our students, we have user, not name. So make sure to put in the exact keyword. And in this way, you will see how you can group up data, how you can aggregate, how you can also use group by. So that is it for this class, and hope you understood about everything in this class. So the summary of this class is how you can create clean data for accurate machine learning and also for preparing AI models. I've also shown you how you can merge multiple sources of data and also how you can group and aggregate to analyze the trends of the data. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If there is any problem, if you're facing anything, or if you're having any issues, or if you have any question, feel free to ask me anytime, as I'm always there to help you out. So, without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analytics. Welcome back to another class of AI, machine learning, data science, and big data analytics. The topic of this class is going to be exploratory data analysis, which is also known as EDA. We're also going to cover things about data visualization with Matplotlib. Matplotlib is also another module or library by Python, which basically helps you to give you out a visual result. Let's say it could be like a chart, it could be like a coordination, it could also be like hot springs. Okay, so make sure not to skip any part of this class because I kept it super beginner friendly. I'm also going to give you out code examples. I'm also going to help you out with the explanations about the codes and also what is going to help you and how you're going to make sure to use the codes to make sure to get the full functionality of EDA, Python, and also Matplotlib. So without any further ado, let's open up PyCharm, and if you're not using PyCharm, open up any of the IDE that you are using. So, just as you can see, I have opened up PyCharm. Let's create a new project, and that is basically it, and press on create. So, just for waiting a couple of seconds, you will see that the virtual environment will be created. The first thing that we need to do in this class too is installing the modules. Now there are going to be two types of modules that we're going to need in this class. The first off is to validate the dataset or the data frame and also to visualize our data. So here I'm going to type in pip install pandas. Let's wait for a bit until pandas is successfully installed on our device. The next thing is to visualize our data, which is Matplotlib. So we're also going to make sure to install Matplotlib on our device. But make sure you are connected to the internet and also you have a stable internet connection. So let's wait for a bit until this is done, and then we're also going to install Matplotlib. As you can see, pandas has been installed. I'm going to type in pip install matplotlib. Hit on enter and wait for a bit until it downloads all the necessary files, just like you can see right now. This is the exact reason why you need an internet connection, because sometimes there is a lot of data that is not given default by Python or the Python package. So just stay connected to the internet. And you can see everything is being downloaded. It is just going to take a couple of seconds. It is also going to install whatever is needed to make sure that Python and also to visualize your data, it is functioning properly. Wait for a bit, and you will see it will also be successfully installed on your device. Now, another thing you have to keep in mind is to run and also test and also debug your program, which basically gives you out a test result. After this is done, the virtual environment is going to index again one more time, and it is going to update these skeletons so that whatever module or package you are using is functioning properly. Okay? As we can see, that is completely done. Now, let's create our CSV file first. So, I'm going to name it student.csv. Okay? Ignore the extensions as we're going to be creating them right now. Let's say user, age, mark, or we can put in points, and also the sex. First off, Alan, age 18.88, and sex is male. Okay? Then I'm going to put in, let's say, Ron. Age is 17, point is 89, and also male. The next one is going to be, let's say, Nelly. Let's say 19, point is 86. This person is a female. Then I'm going to put in, let's say, Henry. Let's say 19, 79. This person is a male. And then I'm going to put in Tara. So this person is 20. Let's say the point Tara got was 87. And obviously she's a male. So we have created our CSV file. Now, as we have our CSV file, we're going to take a bit of time to give you the introduction to EDA, which is Exploratory Data Analysis. Now you might think, what is it basically used for? So, EDA is basically used for understanding your data frame and your data set. Whenever you want to visualize your data or even create your module, you have to find out specific patterns of your data, how it is progressing, how it increases, or how it even decreases. And in your data set, obviously there could be a lot of missing values. Now those missing values are also known as outliers, and detecting them is the process of outliers. Whenever you are detecting the missing values and you are fixing them out or filling out with, let's say, replacing the data, so what you're doing through the process is preparing the data for machine learning or even for AI models. So to do all of those processes, the tools or the modules that we used are basically pandas and also matplotlib. Pandas basically validate your data, and matplotlib basically helps you and serves the purpose of visualizing your data. So both of them, like together, gives you out basically the best type of outcome of getting your visualization of data. Now, let's create a Python file. Test. Here, I'm going to import pandas as pd. On the next one, I'm going to put in import matplotlib.pyplot as plt. Now we want to load our data set, which is CSV. df is equal pd.read_CSV. Open up the parentheses. Now I'm going to put in student.csv. Now I want to print out our data frame, but we want the first rows. Run the program, and it might appear up just like this. Okay? So, if you've checked out my previous classes, you already know what pd.read_CSV does, which basically loads up your CSV file, and df.head basically shows you the first 5 or 6 rows in your dataset. So This is basically the basic steps of EDA, which is looking through or going through your data. Now, what we're going to go through is going to be going through basic EDA, which is also known as dataset overview. So, over here, let's type in print. Let's say I want to get the shape of the dataset. To get the shape of the dataset, we put in df dot shape. So, run the program, and there we go. We have 5 columns, 5 rows, and 4 columns. If you want to get out the exact column, what we basically do is type in print and then type in df dot columns. Run the program, and it will only show you how the columns are shown. Okay, you can see syntax warning, return is finally a block. You can see this is how it works, and there we go. We have the columns. Now, what if you want to get out the info of the data? To get that, we type in print, and then we put in df dot info. Run the program. In this way, you get the information or the whole information about your dataset. Now you can also put in extra lines if you want to, but I just prefer typing it out just like this. If you want to get a whole summary of the statistics of your dataset, we put in print df, and then we put in describe. Run the program. In this way, you get the whole summary, including the count, mean, standard, minimum 25, 50%, 75%, and also the maximum, which is 100%. So when you put in shape, it basically prints out the rows and columns, how many you have. When you try to get the info, it basically gives you out the data types, including the missing values info. And when you put in describe, it finds out the mean, mode, median, minimum, standard, and also percentiles. So this is basically the foundation of understanding your dataset. Now, what if you want to handle your missing values? In my previous classes, I've already shown you how to, go through the process of handling the missing values. What you basically do is type in print, then put in df dot is null. That's it. Open up the parentheses. That's all you basically do. But if you want to sum it up, put in dot sum and open up the parentheses. In this way, it handles the missing values and also gives you a summation of how many missing values there is in the columns. So when you put in the function just like this, it basically does is that counts the missing values, and if the missing values exists, it basically shows it to you. What if you want to drop the missing values? We put in df drop na. So df equal df dot drop na. That's all. It removes the missing values. But what it does is removes the whole row. If you want to replace it with mean values, we put in df equal df dot fill na, open parentheses, df dot mean, and open parentheses. Run the program. In this way, it might show you off just like this, but here, what you can do is you can put in numeric only equal true. Run the program, and then it will work. If it shows you off an error over and over again, instead of fill na the whole thing, we put in fill na dot mean. There we go. In this way, this is how it is validated. So the drop na, what it does is removes the missing rows, but it can lose data. And if you put in fill na, it keeps the data and also gives you out in zeros, or even NaN. Now what we can do is we can also cut this part out. It will still fill in the missing values. Now, what if you want to find some simple EDA analysis? Let's say I want to get the sex distribution. So I'm going to type in print df, and then here put in sex. After that, put in dot value. As you can see, we have a comma. I'm going to put in dot value, and then I'm going to put in counts and open the parentheses. Run the program, and you will see we have sex over here. I'm going to go over there, and we have this over here. So basically the value is the same, okay? Even though it is showing you that it is not working properly, and the method object is not subscriptable. So there is a specific value that is wrong within this, okay? So after this, what I'm going to do is that we basically close this off. We have value dot underscore counts. Okay, we have opened up the parentheses, and this is how it might show up as an error. But this basically works on the newest version of Python. So for the older syntax, there is a different method. First off, what I want to do is I want to print out the column to check if there is a column based on that. So here, print, here, df dot columns. Run the program, and first off, it will run the program. If nothing shows up like this, run it again, and you can see we have dot columns. So I'm going to check out if anything is working or not. If it ain't, then that means that we cannot find the exact column based on it. So let's check it out again, and you can see it is over here. User, age, points, and sex. So there is no null value on any of them. Okay? Now, another thing what we can do is we have this drop an A and fill an A. So we're going to cut out this part and run the program. If it shows you that it is now showing up on your screen, that it means that when you're putting drop an A and fill an A, it becomes a bit case sensitive, and also it drops the values. After this is done, you want to run the exact same code again, which is print df sex. After that, put in dot values or value underscore counts. Now you want to run the program one more time. There we go. We have 3 male and 2 female. What if we want to, let's say, get the average mark by, or let's say average points by the sex? So here I'm going to print out df dot group by. After that, let's say sex, and then we want to put in points. There we go. After points, I'm going to put in the dot mean value and run the program one more time. And there we go. For female, the average result is 86.5, and the average result for male is 85.3. So when you put in value underscore counts, it basically helps to understand the distribution. And when you put in group by, it finds the relationship between the columns and what you are trying to find. So we are basically done with EDA analysis. So now let's move into introduction to matplotlib. So here I'm going to create a section, matplotlib. So we're going to start off by visualizing your data. So just like I said, the main purpose of Matplotlib is to visualize your data. And there is a basic flow of Matplotlib, which are data preparation, plotting your data, giving labels to your data, and also representing it. So let's start off with it. Let's say I'm going to visualize the points of the students based on their names. Let's say I'm going to put in PLT dot, let's say, figure. Now open up the parentheses. Let's say fig size. The size is going to be 6 by 4. Run the program, and you can see it is not working yet, because one thing over here is that whenever you are defining it, you have to make sure to put in a parentheses and also close it off. Run the program, and you will see that it might not show up just like this, but we have the name, the points, and the data types. Then here, close it off, and I'm going to put in PLT dot plot. Here, first off, define the data frame. Now, first off, I'm going to put in the user or the name of the students. So I'm going to put in user. After that, put in comma, data frame, and then I'm going to find out the points. On the next line, I want to get the points of the user. So PLT dot title, let's say points of the users. Now, in, let's say, a visualization chart, there's an x-axis and a y-axis. So PLT dot x label. Let's say on the x label, I'm going to put in users. And on the y label, I'm going to find out the points. Now, I want to put in the x ticks. So PLT dot x ticks rotation here equal, let's say, 46. And also, I'm going to put in PLT dot show, which basically works like print. Run the program, and you will see something like this will appear up on your screen. We have Alan, we have Ron, we have Nelly. Let's also open that up. There we go. We have 88, and also Ron to be the highest score, which is 89. And this is basically how it works. Henry is somewhere like 79, which is like the lowest. And also, we have this Tara, which is close to 87. So, this is basically how it works. And when you put in PLT, okay? So, basically this PLT.show is for the line graph. And always, it shows the labels on the axis that you have put. On the x-axis, as you can see, we have the users. On the y-axis, we have the points. Okay? And also the rotation of the x labels, to make it readable, we put in 46. If you put in something like 50, that also works. Let's say I want to put in 50. Run the program or rerun it. And basically this is how it will look up. Okay? And you can also reduce it however you prefer. Let's say maybe I want 30. Run the program. And this is exactly how it will look like. Okay? If you reduce it less, let's say 20. Run the program. And that is exactly how it will work. There we go. So you can basically just customize it however you prefer. Now, even though this is the line chart, what if you want to get, let's say, a bar chart If you want to get a bar chart, what you basically do, let's say, first off, I want to get the average points. Equal df dot group by. Open up the parentheses. First off, I want the sex based on the gender, which is over here. And then I'm going to put in the mean value. I'm going to put in plt dot bar, let's say average point, as you can see, and I'm going to start off with indexing. Now, after that, I'm going to find out the average points, but I'm going to put in average point again and put in dot values. After that, I'm going to put in plt dot title. The title is going to be average points by sex. Here, plt dot xlabel. First off, I'm going to put in the sex, plt dot ylabel, and then I want the points. So obviously we put in plt.show at the end, and we run the program. You might see this is how it will look up, but what we want to do is we want to put in 3 of those. There we go. And then we can run the program. When we can run the program, we can cut this part out. We can put it over here too. Rerun it. And you might see this is how it might appear up, as there is an array problem. So we have both of them as sex over here. So here, I'm going to put in points. Run the program again and check it out. This is how it will look like. So basically, bar chart is very good for comparison. As you can see, just a bit, which was like 85 and also 80, or let's say 86 and 85. So it doesn't make any of that difference. Let's say points of run is going to be 65. Now if we rerun the whole thing, it will be a bit different. There we go. This is how it will look up. Okay? Now, even though we have this, let's say the next thing that we want to show is going to be the histogram. So if we put in plt.histogram, let's say df, and then I'm going to put in, let's say, points. Here I'm going to put in bins equal 5. I'm going to put in plt.title, double quotation, let's say distribution of points. I'm going to put in plt.xlabel and ylabel, the same thing. We have 6, and also on the ylabel, instead of points, let's say I'm going to put in frequency. And the last thing is obviously plt.show. Run the program, and it will just appear up in just a couple of seconds. There we go. We have frequency, and we also have the sex. So this is basically the best if you want to detect outliers and also for skews. Let's also cut this part out. Control X, Control V, and the last thing that I want to show you is going to be the scatter plot. So plt dot scatter. Let's say df. First off, we want the age, comma, df. I also want the points. There we go. on the next line, I'm just going to basically copy these. There we go. Here, I'm going to put in age with points. Instead of that, I'm going to put in age and also points. PLT show, that's it. Run the program. And this is how it will look like. And this is called scatter plot, which is basically the best for correlation. Okay? So that is going to be it for this class, and hope you understood about everything in this class. So the final summary is you have learned about what is EDA, why is it important, how you can load up and inspect your data set and your data frame, how you can get the shape of the data set, get the information, the description, detection, handling the missing values, grouping and summarizing the data, and also visualizing your data using Matplotlib in different type of formats such as bar chart, line plot, histogram, and even scatter plot. Okay? So thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analytics. Welcome back to a new class of AI, data science, machine learning, and big data analytics. The topic of this class is going to be advanced visualization with Seaborn and also feature engineering and also pre-processing. I have separated and divided this class into a couple of sections, so it is going to be easier for you to understand about the topic. Well, in my previous class, I've also shown you how you can work with datasets and data frame and how you can visualize them using Matplotlib. So if you want to get into more of the intermediate section or the intermediate part of visualizing your data, you have to understand about Seaborn. So make sure not to skip any part, as it is going to be very important for you. And also the most important thing is that if you didn't understand my previous classes, including EDA and also Matplotlib, then it will be a bit hard for you to understand this class. So I would suggest you, if you still don't have any idea about it, go check out my previous classes and then come back to this class and follow through. So let's open up IDE, or which is PyCharm, which I prefer using, but if you prefer using any other IDE, then you can open them up. Just as you can see, I have opened up PyCharm. Let's create a new project. As we have the project, inherit the packages, make sure to select the version of Python whichever you prefer and press on create. In just a couple of seconds, you will see the virtual environment will be created. Now, before getting into our hands-on experience of this class or the practical part about this class, we have to understand what is advanced visualization with Seaborn. So first off, what is Seaborn? Well, if I get to the summary, Seaborn is also a type of module or a package of Python, which basically helps you to visualize your data. So if you have any statistical data set or a data frame and you want to visualize it using a library with which, let's say, you can also intertwine it or connect it with Matplotlib and also get the intermediate version of visualizations, then Seaborn is the exact tool for you. It offers you beautiful, easy, information-rich charts and also different methods, also different types of charts, just like you can see or just like you have seen in Matplotlib. We've shown you 4 types of charts in Matplotlib. But when you're using Seaborn, also on the side by Matplotlib, it makes your, let's say, chart a bit more understandable, and also it includes a lot of information. Now, it is basically very useful and serves the purpose of using EDA, such as exploratory data analysis. So the more data and the more information your chart holds, the visualization is a lot better. First things first that we need to do is we want to install the necessary modules. So open up your terminal, and here I'm going to type in pip install pandas for validating our dataset. Let's wait for a bit until everything has been installed properly. After that, we also want to install matplotlib so that we can visualize our data, but on the basic side. You can see this is done. So I'm going to install matplotlib. Hit on enter and also wait for a couple of seconds, and you will see the necessary modules will be installed and downloaded on your device. Now, one thing is, you can see, or you have seen in my previous class, I also installed matplotlib, but why is it not working? It is not working because every time you open up your virtual environment, everything resets. So you have a clean slate, and also you can start up exactly wherever you want to start up from. And also, to be most clear, you can start off from ground zero every time you open up a new environment, or let's say a new project. So whenever you create a new project, just make sure to install the necessary modules that you require for each and every class. Now, why is this done in all of the projects? It is because sometimes there are a lot of modules that you are not going to need in all classes. So that is why it is the best if you are starting from the start, or let's say from ground zero. So let's wait for a bit until this one is also installed and successfully downloaded. And then we're going to install the last module, which is Seaborn. Now, after this is done, let's also put the same thing, pip install Seaborn. Okay, and it will also install and update your module. So I'm going to type in pip install Seaborn. Hit on enter and wait for a bit until this one is also downloaded and also installed successfully on your device. You will see in just a couple of seconds it will be installed. Now, another thing is that with couple of modules or packages or libraries, there are also a lot of, let's say, default files. Okay, a couple of data sets which you can use anytime you want. So first things first, we want to create a Python file. Let's say I'm going to put in test. Okay, here I'm going to type in import Seaborn as SNS, import matplotlib dot pyplot as PLT. Now we're going to load up the dataset. Now there is a built-in dataset which we are going to use. So data frame equal SNS dot load dataset. Here I'm going to put in tips, which is a built-in dataset. So here I'm going to print that out, df dot head. Now if you want to run the program, you will see that a couple of data might be appearing up because we are using the default or built-in dataset, which is basically given with Seaborn. So it is also downloaded and you can work along with it. So the first things first, we have to get into the explanation, which is SNS load dataset, which basically loads in a ready-made dataset, which is given default by Seaborn or whenever you install it on your device. And then we have this tips over here, which contains a lot of bill information inside of that built-in dataset, such as it contains total bills, there's tips, there's gender, there's, let's say, smoker, we have day, time, size, and everything. So you can basically get out or give whatever you exactly want. Okay, now let's get into the secondary part of this class, which is the advanced plots. Now, what is the advanced plots? Whenever you are combining histogram plus the KDE, which is also known as the distribution plot of any dataset, we turn that, or we put it to the term of advanced plots. You can also apply in box plots if you prefer, and you can also use like violin plots, you can use in scatter plots, regression line, you can use pair plots, you can even use heat maps. So I'm going to be showing you everything that you basically need. Okay, so starting off, I want to show you the histogram, including the distribution plot. So I'm going to create a couple of sections over here. I'm going to type in sns.histplot, okay? Histplot. I'm going to put in data equal data frame, comma. Now, just like I have shown you in my previous classes, in a couple of these charts, there are x-axis and y-axis. So x is going to be equal to, let's say, total bill that we want to find out. After the total bill, put in a comma. And here, this is where you put in your distribution plot. So type in KDE equal true. Okay? Now for the next one, I'm going to put in PLT dot title, open up the parentheses, and here I'm going to put in distribution of the total bills in the dataset. Okay, now here I'm going to put in PLT dot show. Now run the program, and you will see that it is going to basically give you out a chart like this. Now, one thing you can see over here is that it includes, bar and also, the histogram at the same time. But in Matplotlib, only one can be shown. So you can see why the Seaborn is known as an advanced plot, or it is basically known as advancedly showing up or visualizing your data, because it contains a lot of data. Even though we did not put on the X label or Y label, we didn't even put in X. We put in the title, but we did not put in where we want it to be. So it basically, let's say, there are a couple of things when you are visualizing data using Seaborn, such as we are using histogram. So in histogram, what happens is that it counts up the specific values of your data set or your data frame, whichever one you are working with. Then we have the KDE, which basically gives you out a smooth curve showing probability and the distribution of your data. So basically, whenever you are showing the smooth curve showing the probability of data and also the distribution, what it does is that gives you out in charts and also in regression lines, which makes it easier for whoever it is, or let's say the audience, to understand it better, which is basically like a lot richer than Matplotlib. And basically this is used for understanding the data shape. You can see this is how it goes up and then comes down again. But even though you can see, the bar chart basically gives you out more information. Okay, so this is basically how you use histogram and also KDE at the same time. I'm going to put in 3 dots so I can show you the rest of the things. Okay, now on the next one, what I want to show you is going to be the outlier detection. Now the outlier detection basically shows you the median, the highlights, and also it detects up the unusual data points. So this is also known as, let's say, the box plot. So first things first, we want to put in SNS, type in box plot, just like this. But I'm going to put in a dot, which makes it a lot more easier for Python to understand. And here the same thing, data frame, comma, x equal, single quotation, let's say I'm going to find in the day. Let's say on the y-axis, I want to find in the total bill. There we go. Now after that, I'm going to put in the title, PLT title. Now open up the parentheses. Let's say I'm going to put in total bill individual day. And here I'm going to put in PLT dot show. Run the program, the same data will appear up, but now you can see we have the box plots. You can see we have the circles over here, we have this box plot over here, which basically gives you out a probability of how much your data is there. So this is basically how you visualize your data just by using box plots. So in the same way, let's just postpone the action over here. Now let's move on to our next plot. In the next plot, what I want to show you is going to be known as the violin plot. Now, this is a bit more advanced, and if you don't know the previous methods, then it is going to be a bit hard for you to understand the whole thing. Now, violin plots are also known as the advanced version of box plots because it contains a lot more data. And in the same way, it is also going to work with your x-axis and also include your y-axis at the same time. So what I want to do is get the exact same thing, but in a visual violin plot. Okay, so I want to find out the total bill of the individual day. Okay, so first things first, I'm going to put in SNS dot violin plot. Now here, define your data frame at the same time. Now I'm going to work with the x-axis first. Let's say first off, I want to work with the day on the x-axis, and on the y-axis, what I want to do is I want to find out the total bill. So there we go. We have visualized, or we have given out our data. Now I'm going to put in the title. So the title of this is going to be the violin plot. Violin plot. And in the same way, let's say total bill individual day. So after the end, what I want to do over here, I'm going to put in plt dot show. Okay? So I'm just going to run out the program and check if it visualizes your data. And you will see at the same time that it will be printed out just like this. Now, what it basically does is also it gives you out a distribution of the probability. Now, what it does is that it combines the box plot and also includes your KDE at the same time. So it includes box plot and also distribution plot at the same time. Okay? So what it basically does is that it shows data distribution a bit more clearly than the previous ones. Okay? Which makes it a lot more advanced and a lot more complex than using the previous ones. So as we're done with the violin plot, we want to show you the next three more, okay? So after this, I want to move into, let's say, the scatter plot. But I've shown you the scatter plot in my previous class of Matplotlib, and those are very basic. But here, I'm going to add in regression line at the same time. So here I'm going to put in SNS dot lm and then put in plot, lm plot, okay? Data should be equal to the data frame. Now on the x-axis, I'm going to find out the total bill. And there we go. Now on the y-axis, we're going to be working with the tips. Now after that, I'm going to put in plt dot title. After the title, let's say I'm going to put in the keyword relation between total bill and tips per day. At the end, I'm going to put in plt.show, run the program, and you will see everything will run exactly the same. You can cut this part off if you prefer. You can run the program, and you will see everything will show you off as an error. Now, you might think like, why is it not printing out my value? Because it is totally fine, because you're going to need a pair plot, which is also known as a multivariate relationship. So here, you want to type in SNS dot pair plot and put in your data frame, and then you're going to type in plt dot show. Now you can run out the program. It might show you off as an error at the beginning, but I can show you like how you want to make this work. If it gives you up like a couple of errors over and over again, just type in tip over here. Let's just cut out this part, run the program, and you will see that this will appear up on your screen. Okay, so now you can see we have the LMP plot, or also known as the scatter plot, including the regression line. Okay, so this basically shows you the correlation and also adds regression line automatically to visualize your data a bit more better. If you want to use the pair plot, just like I said, just type in the exact same thing. Here, type in SNS dot pair plot. There we go, and define in your data frame. Run the program, and you will see basically the first thing will appear up on your screen is this one. And this is also on the side. I can just remove it, but you can see we have every type of data and every type of method of visualizing our own data. Okay, so this is basically how simple it is. So this visualizes the relationship between all the numeric values, and also this is known as the fast EDA tool. Okay, so let's also put this on a pause. Now the last thing that I want to do is show you the heat map, or also known as the correlation matrix. So first off, I'm going to import up pandas. And here I'm going to put in correlation. CORR equal df dot correlation. Here I'm going to put in numeric only, so I only work with the numeric values. I'm going to put in SNS dot heat map. After the heat map, I'm going to put in correlation. Here I'm also going to put in an anot. So the anot is going to be equal to the value of true. And also, as we're using like CMap, so type in CMap just like this. And here, let's say I want a cool warm CMap. You can also use warm if you want to, but I just prefer using cool warm. And here, I'm going to put in plt.title. Here, I'm going to put in correlation matrix. Okay? So here, as we have the correlation matrix, now I'm going to show out my visualization. So put in .show. That's it. Now you can run the program and just wait for a bit and you will see the correlation matrix on the side. Okay? So this is basically, when you have variables which are related and you have like strong positive and negative correlation. And this is basically used for future selection of your data, which one you want to work with and which one you don't want to work with. Okay? So there are lots of data. You can see on the most predictable ones are in red. Then we have, a lower red, and we have bluish, we have sky blue. You can see we have tips over here. The lowest terms are 0.49, and we have 1, which is the highest amount of tip. Okay? So that is basically how it is going to work when you have relation of your data set. Okay? So now you have learned everything about CMap, or let's say Seaborn, and also how you can visualize your data better. Okay? So now let's move on to the next part of our class, which is feature engineering and pre-processing. So first off, you have to understand about what is feature engineering. So feature engineering means transforming your raw data into meaningful input, such as featuring with machine learning and also applying it for AI models. So there are specific steps which you have to follow up, such as handling your missing values, encoding the data, scaling numerical data, featuring your selected data, and also feature the creation of your model. Okay, so first off, let's create a Python file. Put in test1. Okay, so first thing, I want to load up my data. So I'm going to type in import pandas as pd. Now I'm going to create our df pd.read_csv. Now, one thing that I want to use over here is going to be also a built-in dataset, which is iris.csv. Now, this should come as a default and built-in, but if it is not working, I'm going to show you where you can find it. So first off, I'm going to print out the data, df.head, and open up the parentheses. Now, if you run the program, either it is going to show you this error. You can see no such file in directory iris.csv. If you cannot find it, it is completely fine. First off, what you basically have to do is open up a browser. So whenever you open up your browser, you can just search for iris.csv file, and you can just go off to GitHub gist. Now click on download zip. It will start downloading the zip file on your PC, and then you can just open it up and drop it in your directory file. Okay? So there we go. We have the iris file, and this is the virtual environment. So I'm just going to drag it inside of this file, so it is now inside. Okay? So I'm just going to cut this off, and there we go. Now we want to rerun the program again. You can see we have the iris CSV. Now run the program, and there we go. We have the CSV file, and we are basically reading it. Okay? Now, if it doesn't find out the iris file, there are a couple of codes which you can run, but you can use Seaborn for that. Now, if you don't want to file out, or let's say find out the CSV file, let's say run_CSV_iris. Now, even if your Python or pandas does not have the iris, you can use Seaborn. Okay? So here, type in from sklearn. Datasets import load underscore iris. Okay, here you can type in import pandas as pd. Iris is going to be equal to load iris. Open up the parentheses, keep it empty. Data frame equal pd dot data frame. Open it up, iris dot data. Now after iris dot data, put in comma. Columns is going to be equal to iris dot feature, and after feature you put in the exact names that you want to use. Now after that, you just basically put in data frame and define in the target value, which is target, and put in equal to iris dot target. That's basically it. Now you want to run the program, and you can see it cannot still find the iris dataset. If this appears up, let's just go off the terminal, type in pip install sklearn. That's it. Now just wait for a bit, and sklearn will start downloading all the dependencies. Just make sure you are connected to the internet and you have a stable internet connection. That's all. Now you want to run the program again, and you might see that it is going to basically show you up the error over and over again. You also want to install another module. Let's open up the terminal and type in pip install scikit-learn. Now run the program, or let's just go off the terminal, hit on enter, and wait for a bit. If it shows you that scikit-learn has been installed successfully, or scikit-learn 1, or whatever version it is, then just wait for a bit. Okay? So it is going to download all the necessary data that it needs to run successfully and to be functional. There we go. Now this is done. Now let's rerun the file. You can see it is indexing, so it's going to take just a bit of time. Let's wait up for a bit. So I'm going to click on show all, and there we go. If it shows you that process finished with exit code 0, then it means that it has run perfectly, and it also has found the iris file. Okay, so now that we have our iris file, now we're going to work with handling the missing values. Let's go to test 1. Here, I'm going to put in print, and after print, you put in df dot is null. Okay, open it up, put in dot sum, and open up the parentheses one more time. Now we're going to wait until the Python interpreter is basically done, but you can rerun the program. Whenever you rerun the program, you can see there is 0 missing values. Now, if you want to file or fill out any missing numerical values, then what you basically do is you type in df, open up the secondary bracket, let's say sepalent. Here, all of them are in centimeters, so I'm going to put in centimeter after the secondary brackets, put in fill NA, put in data frame, secondary bracket. Here, I'm going to put in double quotation, first of all, secondary bracket. Here, sepalent, and open it up with centimeter. Now, after the secondary bracket, you want to put it with the mean value. So you have, let's say, the average value of everything. Now here, I'm going to put in place equal true. That's basically all that you need to do. Well, this is basically going to fill out your numerical value. Now you can run the program, and it might show you off as an error, sepalent, meter, and all of those. But what basically happens is that there is no missing values, just like you can see, 0. So it is not going to work. But you can also put in sepal.length, and you can cut off the centimeter. You can rerun the program, and this is basically how it is going to work, because this basically does not work if it does not have any missing values. If you want to fill out the categorical values, you put in df let's say double quotation, I want to put in species. After that, I want to make sure that it is equal, secondary bracket, species. After that, dot fill NA, open it up, data frame. Now, as I want to fill up species, I'm going to put in secondary brackets. And after the species, I'm going to put in dot mode. Okay, open up the parentheses. Now, what do you want to fill it with? I want to fill it with the numerical 0. That's basically all that you need to do. And you can run the program and the category will change. Okay, but as we don't have any missing values, it is basically not going to work. Now, let's move on to the next part of this class, which is going to be encoding your categorical variables or your data. So you want to type in from sklearn. Okay, now after sklearn, we're going to pre-process our data. So put in dot pre-processing. After that, I'm going to put in import label, and I'm going to put in encoder. Now LE is going to stand for label encoder. So I'm going to put in label encoder, open up the parentheses, data frame, secondary bracket. Now I'm going to start off with the species one more time. It's going to be equal to LE dot fit underscore transform. Now inside that df, I'm going to put in species one more time. Now one thing that I want to do over here is I'm going to put in the 3 of these parentheses, so I just postpone these actions. And there we go. Now you want to run the program one more time, and there we go. It might show you off as an error again, because there is nothing as species. Okay, we have variety, which you can work with. You can see over here, as we have variety, so I can put in variety. Run the program, and there we go. We have the type and also the process finished with exit code 0. In the same way, if you want to work with one hot encoding, so put in df pd, then put in .get, and you can get dummies. This is basically used for machine learning models. So here, data frame, comma, columns, equal, here, I'm going to put in variety. Variety. Now I want to print out my data. df.head. Now you can run the program, and you will see that everything that we need is going to be printed out just like this. Okay, so that is how simple it is. Now you can also feature your scaling in a standard way and also in a minimum maximum way. If you want to do that, first off, let's also postpone these actions. So first things first, I'm going to put in from sklearn. Then I'm going to put in dot pre-processing. First off, as I want a standard scalar, so I'm going to put in standard scalar. After that, I'm going to create a variable. Let's say I'm going to put in scalar. I'm going to put in standard scalar, open up the parentheses. And here I'm going to put in the scaled value, scalar dot fit. After that, underscore transform. I'm going to transform with the drop, df dot drop. Open up the parentheses. Let's say I'm going to put in the target. After the target, I want axis equal 1. Now you can run the program. You might see it might show you off as an error, okay, because there is no target found. So instead of the target, what I can do over here is, let's say I want also the variety or maybe the petal width. So I can copy this and paste it over here and run the program. You might see that the D type is going to be, a float value. So what I want to do is, let's say I want a variety. Let's cut this part out, run the program. And if it shows you an error again, then it means that it does not have the D type, which we basically want. But it is a standard meaning, okay? If you want to work with minimum maximum scaling, which is 0 to 1, you start off with from sklearn dot preprocessing. I'm going to put in import minimum and maximum scalar. Scalar is going to be equal to minimum maximum scalar again. And here, I'm going to put in the scaled value. Scaled equals scalar dot fit underscore transform df dot drop. Here, let's say I'm going to put in variety again. After variety, you can say I'm going to put in comma, and then I'm going to put in the axis equal 1. Okay, now in the same way, I'm going to postpone these actions and run the program. And in this way, it will basically give you a minimum and maximum scalar from 0 to 1. If it does not have any data which matches up with the data that you want to work with, it is not going to print out anything. Now, the last thing that I want to show you in this class is going to be the feature selection. If you want to have the feature selection, let's say start off with from sklearn and put in, let's say, feature either extraction, or you can put in selection. Now I'm going to import select. Here, I'm going to put in k best. After that, put in comma, and here I'm going to put in the f class if. After that, I'm going to work with my x-axis, df dot drop. Open it up. Let's say I'm going to work with variety again. And after the variety, I'm going to define my axis. Let's say axis equal 1. Now on the y-axis, equal df, and open up the secondary brackets. I'm going to put in variety over here again. Now I'm going to put in my selector. Equal, I'm going to put in select k best. Now I'm going to put in score value, score underscore the function. Here I'm going to put in f class if. Now as I'm working with KDE, I'm going to put in k equal 2 in this case. Now I'm going to put in x underscore new as the variable. And here I'm going to put in selector dot fit. And also I'm going to transform my value into my x and y axis. So x, comma, y. Now I'm going to print out my variable with x new as my variable. And also I want it to be sliced a bit. So let's say 5 as the value. If you run the program just like this, you will basically see, you can see we have the x is not defined. So if it is not defined properly, I'm going to make sure I put in the x over here, and then I rerun the program. If I rerun the program like this, now you can see we have a sliced up data, and it is kind of looking like a bit of the pandas list. Okay, so that is going to be it for this class. Now let's get into the summary. Is that Seaborn basically helps you to visualize your distributions and your probability. It detects your outliers or your advanced plots. It can also find out relationship between multiple variables at the same time. It can work both with EDA and also pair plots, and also helps you with heat maps. Not just heat maps, it also gives you out of like a variety of correlation. And when are you going to use your feature engineering? It is basically used to clean out and transform your data, encoding your categorical data, scale your features, selecting important feature, and also creating new feature however you prefer. So, hope you understood about everything in this class, and if you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analytics. Welcome back to our class of AI, machine learning, data science, and big data analysis. The topic of this class is going to be descriptive statistics and probability basics. So we have changed another module of our course, which is statistics and mathematics for AI. So in this part or in this module, the classes are going to have a lot of complex codes which you'll be able to use to make sure to prepare your AI and also machine learning models. Okay, so to summarize the data using descriptive statistics and understand uncertainty using probability basics. So both of these things or both of these topics are also known to be the foundation in AI, machine learning, and also data science. What descriptive stats help you, or what is the purpose, is that it helps you to understand your data, or let's say your variables or your data set, before building your machine learning models. And the probability basics that we're going to learn is basically going to help you to predict the outcomes. So make sure not to skip any part, as it is going to be a very important class, as we're going to go through the foundation and the basics of everything you need to start with statistics and the mathematics for making your AI and machine learning model. So let's open up PyCharm, or if you want to use any other IDE, you are welcome. Just as you can see, we have opened up PyCharm, and let's create a new project. I'm going to make sure to detect them, and I'm going to use 3.12 as this is the most stable version of Python. So let's just press on create. As you can see, I have opened up PyCharm. Now, there are a couple of things you have to keep in mind. Well, if you didn't check out my previous classes, it is going to be hard for you to understand everything, because I'm going to be using the basics of my previous classes, and I'm going to be using the models that I have already shown you. Not models, but the modules, the libraries, and how you can use those basic functions. So I'm going to go through and I'm going to be using pandas, matplotlib, and also seaborn in this class. I'm also going to be showing you a couple of things which will help you in the process. First things first, let's open up the terminal. Here I'm going to type in pip install pandas matplotlib, comma, and seaborn at the same time. Well, if not all of them are installed like directly, then I would suggest you install them individually. But if you want to save a bit more time, everything you can just put it up like this, and everything will be installed in one go. Okay? It will give you out the last line that successfully installed these packages. Well, if you see it, then you will know that everything has been installed successfully and you are basically good to go, as everything will be working functionally. Okay? So let's wait for a bit until this is done. Just make sure you are connected to the internet. In a couple of seconds, you will see it will show successfully installed, requirements satisfied, and all of those. So this is how it will look like. Now we're going to wait until the indexing has been done. But at the same time, let's create our CSV file. So I'm going to create my CSV file over here. Let's say here I'm going to put in student points.csv. There we go. Going to ignore the plugins, or I can just ignore extensions. So I'm going to put in name. Let's say I'm going to put in physics, comma, and I'm going to put in chemistry. So that is going to be the marks that I'm going to make a correlation out of, and you will know how everything will come up together. Let's say Alan, he scored 87, and on chemistry he got 94. After that, I'm going to put in, let's say Rig. He scored, let's say 79, and on chemistry he got a 77. Let's say we have Johnny. So Johnny got, let's say 94, and on chemistry he got an 80. Let's say just 80. After that, I'm going to put in, let's say, Sarah. Sarah got, let's say, 69 on physics, and on chemistry, she got around like 77. Now let's move on to the next one. Let's say Kelly. So Kelly got 82 on physics, and on chemistry, she got a 99. So this is going to be my CSV file. Okay. Now, before getting into more of our practical part of the class, we have to know a bit more about the descriptive statistics. Okay. So first off, you have to know about what descriptive statistic is. Okay. So basically, if I keep it simple, what it does is that it summarizes and describes your data in a very rich format. Just like I said about Seaborn. You can visualize it and you can also print it out in a data format. But most of the time, what it does as you're working for your machine learning model or your AI model, what it does, it creates a visual representation of your data, but it summarizes and describes it a lot more better. Now, there are two types of descriptive statistics. One is called the central tendency, and the second one is called the dispersion. Well, in central tendency, what it works with is three modes or three types of operation, which are the mean, mode, and the median. And the second type of descriptive statistics, what it works with is the range, the variance, and also the standard deviation of your data. Let's say you have the CSV file where I am basically counting or putting up my student points or how much marks they got or how much points they got. So what it does is that my students in physics, okay, what or how much data or how much points did they get? So what descriptive statistics is going to do is that it is going to work and process with the average performance of specific subjects such as physics. It is also going to give you out a spread data, and also it is going to find out the variations between what type of data or what category of data you are trying to search for. Okay, so I'm going to go through them step by step. Okay, so first off, you always have to work with the central tendency when you are working with descriptive, okay, or known as descriptive statistics. I'm going to make sure that everything lines up together, but you have to keep in mind that there are two types, and these two types are basically connected together so that it turns out to be one program and you can run everything functionally. Okay, it might be a bit complex for you to understand, but I'm going to create sections so that it is easier for you to understand. Okay, so let's create our Python file. Let's say I'm going to put in the test. Now, first off, we want to calculate the mean, mode, and median. So I'm going to create a section where I'm going to put in mean, mode, median. First step of, let's say I'm going to put in descriptive statistics, and it is known as the central tendency. This is basically where everything starts. So I'm just going to copy this. Okay, so first off, you have to import the modules. So I'm going to start off by importing pandas as PD. Now we're going to create our data frame. So df equal pd dot read underscore CSV. Now I'm going to put in my CSV file, which is student points dot CSV. Now, as we want to find out our physics marks, okay? So here I'm going to put in physics. Let's say physics points. Physics points is going to be equal df, and now I'm going to define the category physics. Now, one thing you have to make sure is the case is basically the same. Okay? Now, I'm going to start printing out my values with my specific, let's say, operations. Starting off, I want the mean value. After the mean value, let's say I'm going to put in physics points dot mean. That is all that you need to type in. Print, let's say, mode, comma, physics points dot mode. Now, what mode do you want? You also have to specify it. Let's say I'm just going to start with the index 0. Now, the last one is the median. physics points dot median. That's it. Open it up. Now you can just run the program. If you run the program, you will get the mean, mode, and the median. And how it works is that when you are using mean, it is going to find you out and operate the average score from that specific list of data. When you're putting in mode, what it does is it uses the most common score, which is 69 in this case. And then we have the median, which is also known as the medium, or let's say the middle value of your range of data. So what you can see is the printed data of those basic operation or the central tendency. You can also print out a sorted list of the points that I have on my list. You can highlight the median in the list, you can highlight the mode and repeat the values if they exist. And also you can make sure to make interactive visuals in the code. So if you want to do that, first off, you have to make sure to import matplotlib. Matplotlib.pyplot as plt. Now, after this is where I'm going to visualize my data. So I want a histogram. So plt, obviously you know, HIST, that's all you need to put. Now I'm going to put in my physics points. There we go. Physics points, comma. I'm going to put in the bins. Bins should be equal to 5, as I have 5 values. Now I'm going to represent my color. Let's say I'm going to define my color equal. Then I'm going to, let's say, use blue in this case. After blue, I'm also going to put in an edge color. So edge color that we want to use is going to be simple as black. So it basically looks like a border. And I don't prefer using anything else because sometimes the color does not look good and neither can it represent better. Now, as we have the hist plot created, now as we have basically the histogram, I also want the title. So plt.title. Let's say the name of this title is going to be the score of the physics, or let's say distribution of the scores points gained by students. There we go. That's it. So I'm going to put in a colon. Then I'm going to work with the X label and also the Y label. So plt dot X label. X label, open up the parentheses. Here, let's say I want points attained. And also plt dot Y label, I want, let's say, the frequency of data. That's it. Here, I want to print it out, so plt dot show. So on the x-axis, it's going to have the scores or the points, and on the y label, it is going to have the frequency of the data. So run the program, and you will see this is exactly how it will look like. Now I can change the color if I prefer. Let's say maybe I want a teal color. So if I run the program, you will basically see this is how it will look like. You can change the color however you want to. Now, let's move on to the next section of this code, where basically I'm going to show you dispersion, which is the second type of descriptive statistics, where I'm going to be working with the range, variance, standard, and also the standard deviation. So let's create another section. Here I'm going to put in range, variance, and also standard deviation. Here, that was the first step. I'm going to work with the second step of descriptive statistics. Now, this part is known as the slide concept. So, there we go. Or also, you can put in dispersion. Okay? So the central tendency, or the first thing, you have to work or process your data in such a way you get the average, middle, and also the common value. After you get those values, from there, you can work with more probabilities. Okay? So this is where we basically start. We have to find the minimum value, the maximum value, and then we're going to find out the variance and also the standard deviation. So starting off, I want to print out a couple of things, such as, let's say, minimum data. Okay, so after that, put in a comma. Let's say physics points. After physics points, I'm going to put in dot minimum. Okay, open up the parentheses and keep it empty. Now I'm going to print out the next one. Let's say maximum data, comma, let's say physics points dot max. Now the next thing that I want to do is I want to find out the range of the data. Let's say the difference of the data. Whenever you say range, we basically need to find out what is the range or how many spaces it is taking. Okay, so the most easiest method of finding a range is basically just deducting the lowest value from the maximum value, or a subtraction. That's it. Okay, so here I'm going to put in range of data, comma. Here I'm going to put in the physics points, then put in dot max. Here put in space minus, again, physics points dot minimum. Okay, that's basically all that you need to put. Now I want to print out also the variance of the data. If you want to find out the variance, there is a specific function in Python just known as .var. So here, put in double quotation, variance. There we go. Variance in data. Then you put in the physics points or whatever variable you are working with and put in .var. That's it. Now, on the last one, we want the standard deviation. So print it out in the same way. Put in, let's say, standard deviation in data, comma. I'm going to put in physics points and then put in .std. That's all. Open up the parentheses and run the program. In this way, it will find you out all of the data. If I close this one, it will print out another thing right over here. There we go. Everything has been printed on my console. So what it works with is that the range, which is the difference between the highest and the lowest. The variance is basically the spread of values from the mean value, or let's say the average value. And then we have the standard deviation, which is the variance in the original unit. Okay? So if you want to visualize this data, let's say put in space. Let's say I'm going to create a section. Let's visualize it. Here, I'm going to work with box plots. plt dot box plots. Open up the parentheses. Let's say I'm going to put in the physics points. plt dot title. Open it up. Let's say box plots. Box plot visualization of physics points. There we go. After that, plt.show. So if I run the program, both of them will be printed. There we go. We have one. If I cut this off, another one will open up just like this. Okay? So that is going to be, or that is going to show you how the median, quartiles, minimum, and maximum are visible in the box plot. Okay? So that is basically done on our second part, or the second type of descriptive statistics. Now, we're going to learn about the probability basics. Now, after this, everything that I'm going to show you is going to be the probability basics. Okay? So I'm going to create a section. I'm going to type in probability Okay, so in probability basics, you have to first off understand what it is. So probability is basically prediction, but it is like getting data from the events and also from the data. So we already have the data of the students and how much they have scored. They have 87, 79, 94, 69, 82, and so on. But we're working with physics. So 87, 79, 94, 69, and 82. So how is it going to find out and predict up the next values or the probability? Let's say you have checked up or you have seen in a couple of sports that there are probability chances of some team or one of the team winning. And there is a rate based on that. And that basically shows up on the chemistry, or not chemistry, but the history and the data of specific teams. And that's how the probability chances or the rates show up. So this probability basic is also going to be the same way. Okay, so let me just show you a specific formula. So I basically opened up a chart like this. Let's say I'm going to create something. Just going to make sure that I have a big weight. Okay, so first things first, there is a formula of probability basic. Now probability basic is basically determined with PE. So we have a P, and then in the parentheses, so I'm just going to reduce the size a bit more. Let's say P. We have P over here, okay? And then we have basically in the parentheses E. This basically, or this thing, or this unit is known as the probability. And how does probability show up? So it is basically equal to favorable outcomes. Okay, I'm just going to type it over here. There we go. Okay. One is favorable outcome, and it is divided by the total outcome. Okay, so this is exactly how the formula is. Okay, so PE basically stands for probability, and the formula of PE is favorable outcome divided by the total outcome. So in this class, we're going to be showing you by simulating a rolling dice, and at the same time, I'm going to be creating another thing called the flipping coin, which is basically going to predict our data based on the data that we already have. Okay, so let's open up the pie chart again. So first things first that we need, or that we're going to do, is going to be simulating our rolling dice. So I'm going to create another section. Let's say simulation of rolling dice. Okay, now the first thing that I want to import is going to be our module. Now in a dice, there are 6 of them, okay? And I don't want the dice to print out the exact same number over and over again. In that case, we're going to import random. Type in import random. And you don't need to install it because it comes default or built in with Python. So I'm going to put in roles equal secondary brackets, and I want an integer value. So random dot rand integer, and I want the values from 1 to 6. Now here 6 is not going to be an exclusive value because we want the integer number, okay? From point A to point B, okay? So for then underscore in range, okay? In the range 1000. So from this range, this is how it is going to work. Now I'm going to put in probability 1 is going to be equal to, let's say, roles. Now I'm going to count up the value. Count, and there are 6 values. So every time it is going to be different. So I'm going to divide it with the length of the rolls. After this, I'm going to print out the probability. So let's say probability of the rolling dice. Okay, 6. Here, I'm going to make sure to apply the probability 1 so that any of the 6 opens up or shows up, but they're going to be random every time. So based on this data, I'm going to print out, or I'm going to create a histogram. plt.hist, open parentheses, and I'm going to make sure to put in rolls, comma, and as there are 6 numbers, and I want 6 of them to be printed, but randomly, so I'm going to make sure to put in bins and 6. Now I'm going to print out the color. The color that I want to use is going to be red. Now after that, I'm going to have an edge color. Edge color is going to be equal to, let's say, obviously black all the time. After that, I'm going to have the title, plt.title. Here, I'm going to put in, let's say, distribution of the random rolling dice. Okay? After that, I'm going to work with the X and Y label, plt X label. Let's say, here I'm going to put in dice digit, and plt.y label is basically going to have the frequency. Okay? And then I'm going to put in plt.show. And that is it. If you run the program, what it basically is going to show you, not this one either, but there we go. So this is the probability. In 1,000 rolls of your dice, there's going to be 1 150 time. You will get 2 close to 175 time. 3 is going to appear up almost 150 time. 4 is going to appear up almost 175 time. 5 is going to appear up somewhere in between 165 times or 170 times. And 6 will appear up almost close to 170 times. Okay? So this histogram approximately shows you the uniform distribution of how many times these digits will appear up when you are rolling a random dice by using Python program. And that is going to be the estimated frequency. It is not going to be like totally accurate, but it will give you the approx values. Okay? Now, in the same way, if you want to work with, or if you want to see in 1,000 times, how many times will heads show up or tails show up in your coin flip? Okay? So, let's say here I'm going to put in the same thing. Let's say flip or flips. Flips equal secondary brackets. Going to put in random dot choice. Now, open up the parentheses, secondary brackets, and now I'm going to define my choice. So the first choice that I'm going to put in is going to be heads, comma, double quotation, and the B unit is going to be tails. So this is going to be my sequence. Okay? So after the parentheses, 4 underscore in range. Now open up the parentheses and let's say I want 1,000 tries. So I'm going to put in prob underscore, let's say, flip. Okay? So prob underscore flip is going to be, let's say, flips dot count. There we go. So I want to first off count up my heads. Now, this heads is going to be divided by len, and then I'm going to put in flips. So there we go, we have a random number. Now I want to print out my probability. So I'm going to put in probability of the flipping coin on, let's say, different sides. Okay? So after that, we also want to put in comma, and then I'm going to put in prob flip. Okay? So after this, I'm going to create the histogram. So plt dot histogram, open up secondary bracket 1, if let's say f is double equal to double quotation heads. We want to make sure everything is case sensitive, else 0 for f in flips. Okay, now you want to close off the secondary bracket. Now there are two probability, either the heads or the tails. So the bins that we want to use is going to be 2. Okay, now I'm going to have a specific color. So the color is going to be equal to, let's say, green in this case. Then we also want to put in our edge color. So after that, put in comma. Edge color is going to be obviously black, just like I say. Okay? After that, we want to work with the title. So plt, then put in dot title. Here, I'm going to put in distribution of the results of the coin flip. That's it. Now we're going to define the x ticks because this is 2 of them. So plt dot x ticks, and then open up the parentheses, secondary bracket 0 comma, and then put in 1 because we only have 2 of these values, comma, secondary bracket again. Now we're going to work with the label. 0 is going to be, let's say, tails, and the 1 which we are using is going to be, let's say, heads. That's all. After that, just put in plt dot show. Run the program. Everything will appear up. Let's just cut them off. And there we go. So basically, heads will appear up 500 times and tails will appear up almost close to 480 times. So this is how independent events and outcomes are randomized and shows you the outcome. Okay? So that is basically how simple it is. Now let's move on to the next part, where you're going to be combining statistics or descriptive statistics and also probability in your data science. So first things first, you have to know when you are working with standard deviation. What it does is that it scales up the features of the data which you are going to be using or preparing for machine learning. And when you are working with probability simulations, just like this, what it basically does is that it gives you regression of your logics and also naive Bayes. Now, you might not know, or you might think what it exactly is. So to keep it more simple and to summarize it, what it does when you're combining them together is that it gives you out a description of your statistic of your dataset, and also at the same time, it summarizes the data and prepares your dataset in such a way so that you can prepare your machine learning and also AI model. So what you can do to describe your function is the most simple one. Just type in print, then put in df.describe, and then open up the parentheses. Run the program, and everything will be printed and also done at the same time. There we go. It has shown up. It has also shown up. Cut this off. This will also show up. And there we go. We have the description of our data and also the probabilities of how many times everything will appear up. Okay? So that is going to be the description. You will have 25, 50, 75, and also 100%. So the summary of this class, I'm just going to go through everything that we have learned, is that we learned how descriptive statistics work by summarizing your data. When you're using probability, it makes predictions and probability, but it makes it in such a way that you can create a model with uncertainty but approx results. So in Python, when you are combining matplotlib and Seaborn, you can make these concepts more interactive and more visual. If you want to work with a large dataset, make sure to always use pandas before working or, let's say, importing matplotlib and seaborn. So in this class, I've also shown you how you can use histogram, box plots, printed list, and also pandas so that you can visualize the frequency, the points, the outcomes, showing the spread, using median, quartile, showing sample, the space, and also for sorting values, and at the end, also creating a summary table for your data frame. Okay? So thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analytics. Welcome back to our new class of AI, machine learning, data science, and big data analysis. The topic of this class is going to be distributions, which are normal, Gaussians, and also binomial. And also, I'm going to cover everything that you need to know about hypothesis testing. So I have separated and prepared this class in a couple of sections so that it is easier for you to understand, and I'm going to give you out codes and also explanation so you can practice along with me and also understand the whole class. So make sure not to skip any part. Make sure you are connected to the internet and you have a stable internet connection. And without any further ado, let's open up PyCharm on our device. And if you're not using PyCharm, open up any of the IDE that you prefer using. So, as you can see on my screen, I have opened up PyCharm. So let's create a new project. There we go. Going to make sure to inherit the packages and also make available to all the projects. And over here, as we are working with the custom environment, it is going to start off from the basic, or let's say from ground zero. So let's press on create and wait for our virtual environment to create the interface in front of us. So just as you can see on my screen, I have opened up PyCharm, and also my project has been created. Now, first off, we're going to go through what is distributions. So when you are working with your data set and also you are preparing for machine learning or even AI or even data science, you have to understand distribution because this is also one of the foundation. Okay? So whenever you are going through the process of distribution, it is basically going to tell you how your data is going to spread and how it is going to behave based on the probability, based on the processing that you are doing, and also how you are preparing your data set to create your model. Now, you might think like, why is it going to be important and why is it the foundation of machine learning or even AI? So whenever you are distributing your data to find out how much it is spreading and how it is behaving, it basically helps you or the user to understand the probability and give you out the approximate value or the outcome. Now, in many algorithms such as machine learning or even in AI, what it basically does is that it assumes the data or it assumes the probability based on the history or whatever data it has already. So what it basically does is that it gives you out or assumes a probability of distribution, or let's say prediction of normal distribution. Okay? Now, the last thing that we need to know about this is going to be the Poisson and the binomial appearance. So what it basically does is that it takes up specific variables and also specific data set from your data. And then what it does is that it classifies your data in such a way so that it helps Python to, let's say, predict and also presume your data. Okay? Now, as we already learned about what is distribution and why is it important, you also have to understand about what is normal distribution, because there are two types. Now, when are you going to use the normal distribution? Whenever you are working with dataset, there are going to be different types of data. Okay? And let's say when you have specific heights, weights, coordination, test score, then there is noise in the model. Then you also are working with feature scaling assumption and predicting those values. You are going to work with normal distribution, okay? Because that is going to give you out an approximate value. Now we're going to go through everything step by step, but first off, what I'm going to do is I'm going to create my CSV, okay? So first off, let's create our CSV file. Here I'm going to put in example underscore data.csv. Okay, let's ignore the extension. There we go. Now the first things first, I'm going to work with my ID. Now here, I'm going to put in, let's say, 18 to 20 values, which is basically going to make it a lot more easier. So ID, I'm going to put in value, and also, let's say, department. First off, 1, let's say it is going to be 40 over here, and the group is going to be A. 2 is going to be somewhere around 51, and also, over here, it is going to be A. For 3, I'm going to put in, let's say, 48. It is also going to be the A group. Then I'm going to put in 4, let's say 59, group is A. 5, in the same way, we're just going to continue until I meet like my exact outcome or how much I exactly want. So here I'm going to put in A. For 6, I'm going to put in 71, A group. 7, I'm going to put in, let's say, 53, A group. 8 over here, I'm going to put in 55, and I'm going to put in A group. 9, I'm going to put in 91, also A group. Now after this, I'm going to work with my double digit, and I'm going to make sure to put everything in the B group. So let's say 57, B group. 11 is going to be 43, B group. 12, I'm going to put in 69, B group. 13 is going to be 70, also B group. 14, I'm going to put in 25, B group. 15 is going to be 91, B group. And I'm going to put in, let's say, 16 to be 81, B group. And 17, 65, B group. Okay, so there we go. We have 16 or 17 IDs. Now this is what we're going to use as the data. Now this data set is going to contain all of the columns, which are ID row number. Then we have value, which is the value or the attribute of the value. And then we have the department, or let's say the section, which is A or B. So whenever we want to, let's say, group wise or want to, let's say, sample the data, there are two types. So A sample and B sample, which basically makes it two sample data set. Let's say here I'm also going to make sure to put in B. Okay. Now, as we have our data set, now the next thing that I want to do is I want to load and check if the CSV is working or not. So first things first, let's put in a Python file. Let's say test data_CSV. Here, the first thing we want to do is we want to open up our terminal. Now, I'm going to make sure to install all the necessary modules and packages or libraries that I'm going to need in this class. So I'm going to type in pip install pandas matplotlib seaborn, I'm also going to need a couple of modules. Let's say I'm going to put in scipy. Then I'm going to also import in, let's say, scikit-learn. Also, sklearn. Now let's install all of these modules first and wait for a bit until everything has been installed properly. You can see ignore the following version that requires a different Python version. It requires Python 3.12. Okay, there we go. We have all of these over here. Now we're going to check whichever one is working. So over here, I'm going to make sure to copy this. If it doesn't show up, so we're going to wait for a bit until the pip version has been updated. There we go, successfully uninstalled pip, the previous one, and it's going to install the latest one. So here I'm going to type in pip install matplotlib. Now let's wait for a bit until this one is also done. And I'm also going to install scipy, which is going to be very important in this class. But make sure you are connected to the internet because it is going to require a couple of data that is going to be downloaded from the web. Okay, so just make sure you have a stable internet connection throughout the whole process. Now, after this is done, now we're going to type in pip install, and we're going to also install numpy. We're going to wait for a bit until this is done. So it is already there. Put in pip install scipy. Wait for a bit until this one is also installed, and you can see that it is going to download the necessary data. Now, the last thing that I want to install on my PC or inside this project is going to be stats model, because we are basically preparing our data and creating distribution so that we can create our machine learning model. Okay, so let's wait for a bit until this is done, and then we're going to install our last module or our Python library. Okay, there we go, installing collected packages scipy. Okay, so there we go, this one is also done. Scipy is installed. Let's type in pip install stats models. Okay, this is exactly how you want to type in. Hit on enter. Now wait for a bit until this one is also downloaded on your device. Now a couple of things are going to be required or already installed, because obviously it is going to work with other type of modules or other libraries at the same time. Okay, so you have to keep that thing in mind, that we're going to be connecting all of those modules at the same time. And the last thing I want to check is that if pandas has been successfully installed. Even though you can see we have pandas over here, but I'm just going to run it one more time to get, let's say, another check if it is going to work or not. So just type in pip install pandas. If it shows your requirement already satisfied, then you are basically good to go. Okay, so first things first, let's type in over here. Let's say import pandas as PD. Now data frame equal pd dot read underscore CSV. Now here I'm going to put in the example data CSV, and I'm going to print out the data. Let's say df dot head, open up the parentheses, and here I'm going to make sure to get the basic statistics. So I'm going to type in print data frame. Let's say I want to get the value. So double quotation or single quotation, put in the exact keyword, value, and also I'm going to put in describe. In this way, it will give us the basic statistics. Run the program, and if it shows you off like this, then it means it is working properly. Okay, So as this is working properly, now we want to get into our basic, or let's say our normal distribution. So in our venv, I'm going to create another Python file. And I'm going to name it just test. And I'm going to close this off, but we're going to need it later on. Okay? So just like I said, when you are working through the process of normal distribution, it works with specific or accurate data, such as heights, weights, coordinates, test score, noise, and even assumptions of scaling features. So first things first, you want to import numpy as np. Then I'm going to also import another module, import matplotlib.pyplot as plt. Now here, I'm going to work with scipy.stats. I'm going to import norm. Okay? Now in this way, we will be able to work with normal distribution, and also we can work with deviations. Okay? So first off, I want to generate my data, but I'm going to be using them as a variable. Let's say mu. Now mu, this is what I mean over here, is a mean value. You can also put in me. Me equal, let's say 51. Then I'm going to put in the sigma value. Now you might be able to work with this over here, but I don't want any specific variables. Let's say sigma 1. Sigma 1 is going to be having a standard deviation. Let's say in this case 11. And here I'm going to put in 55 in this case. Okay? Now, the next thing that I want to do is work with the axis. So x is going to be equal np, which is, as you can see over here, which is going to work with numpy. Now I'm going to put in the linspace. So me is going to be minus, so let's say 4 into sigma 1, and then comma, and then I'm going to put in me plus, I'm going to put in 4 into, let's say, sigma 1, and after that put in the number of tries it is going to do. So most of the time there are 1000 times I try to create my model, so I'm going to make sure to run them 1000 times again. Now the next thing that I want to do is I'm going to work with the normal PDF. Okay, so the normal PDF is going to be on the y-axis. So y is going to be equal to norm.pdf. As you can see, open up the parentheses. First off, I'm going to put in the x value, comma, the me value, and also the sigma value. Okay, so this is basically going to make your function a bit more dense on the probability. Now, as I want to visualize the data, let's say I'm just going to make sure to use plot. So plt.plot, x-axis and also the y-axis. plt.title. Let's say here I'm going to put in normal distribution of the me and sigma 1 value. Okay, so we have these values over here. Now another thing that I can do is that mean value is going to be equal to 55, comma, and also the standard std-dev standard deviation is going to be, let's say, 11 in this case. I can also put in std just in this case. In this case, it will work too. After this, I'm going to work with the labels. So plt.xlabel is going to have, let's say, the value of the data or the value of the ID. plt.ylabel is basically going to have the distribution. So density of the probability. There we go. Now after that, I'm going to make sure everything is on the grid. So plt.grid And here, I'm going to make sure to put in the Boolean value true. And as I want to visualize it, I'm going to put in show, and that's it. So when you basically put in the norm.pdf, what it does is that it gives you the curve of the normal distribution. So when I run the program, this is going to how it might show up. There we go. So we have the normal distribution of ME and sigma value, mean 55, and standard deviation is 11. There we go. This is how it works. Okay? So the data lies mostly within, let's say, 68% over here, or maybe somewhere around like 55, or let's say, yeah, something around like 45 to, up to 70 or 65%. Okay? So this is basically how you work with normal distribution. Now, let's move into the binomial distribution. So in binomial distribution, what you basically work with is the binary outcomes. Okay? And you also have to keep in mind that there is a specific format to work with binomial distribution. Okay? So the most important thing is that you have specific variables, and that is a specific value. One is going to work with the number of trials or how many times you want to run or test. And also, you're going to have another value, which is basically going to determine the success of your probability. So, how are you going to work with it? Okay, so first things first, what I'm going to do is I'm going to create another Python file. Let's say test1. Okay, so here I'm going to put in from scipy.stats. I'm going to import binomial. I'm going to import numpy as np. I'm going to import matplotlib.pyplot as plt. So just like I said, you're going to have specific variables. So another thing you have to understand is where are you going to work with the binomial distribution. You're only going to use binomial distribution when you have to predict, let's say, win or lose, pass or fail, 1 or 0. So you have seen this in my previous class that I've told you in couple of sports, what it does is that it gives you out a stat of the winning rate or the losing rate of specific team. So this is exactly where it can be used, okay? But it is going to use the data set and the history of that specific team, and then it is going to predict out the data. Okay, so first things first, over here, I'm going to work with n. So n is going to basically, represent the number of trials. Let's say I want 11 trials. And also, we have p. So p is the success of the probability, or the rate of the success of probability. Let's say the rate of the success of probability is 0.4. Now I'm going to work with my axis. X is going to be np dot arrange. So first off, 0, also n plus 1. So it increments 1 by 1. Y equal, I'm going to put in binomial dot pmf. And then you're going to work with x, comma, n, comma, and p. Now here, as we want binary output, so we're going to work with bar chart. So plt dot bar x, comma, y. So both of them are validated. Now plt dot title. Here, I'm going to put in binomial distribution of, let's say, n and p. I'm just going to make sure to put it like this. Now, after this, I'm going to put in the labels. PLT_X label, parentheses, let's say on the X label, success rate, and also PLT.Y label is going to have the rate of, let's say, probability. After this, I'm going to put in PLT.show, and that's it. Run the program, and you will see this is exactly how it will show up. So, as you can see, based on the data, when the number gets to 4 and in between 5, that is the amount, or that is the success rate to be the highest. When it is 10 and when it is close to 0, that is when the success rate is the lowest. So as it goes to the middle of the data, that is where there is the density of probability and the success is the highest. Okay, so that is basically how you can work with binomial distribution. Now, let's get into the Poisson distribution. So when we want to work with Poisson distribution, when you have specific events and it is going to happen at a fixed time, such as you want to send in messages, emails, or even notification on specific time, such as, let's say, customer support, when they're going to get the calls, when they're going to get the emails, when a person is going to arrive at any specific, let's say, reservation, maybe even at a hospital. So everything that is derived and given at any specific time, let's say something like when the clock hits 12 o'clock on December 31st, it gives you out a notification on every phone, Happy New Year. So that is exactly the type of thing when you want to use the Poisson distribution. Now, there are specific parameters of using Poisson distribution. When you are working with Poisson distribution, it basically works with the lambda. So a lambda is going to arrange the events per the interval based on the clock. Okay, so it already has the knowledge and program of its own and has its own memory. So how you want to work with it, I'm going to show it to you. First off, let's open up another Python file. Let's say test2. Here, I'm going to put in from scipy.stats. I'm going to import, I'm going to type in Poisson. Now, as the parameter is a lambda, so you cannot use any specific variables. You have to put in lambda, just like this. Just type in lam. Here, I'm going to make sure to work with, let's say, 5 intervals. Now, I'm going to put in the axis, let's say np.arrange. Here, I'm going to work with 0, and the exclusive number is going to be 16. Then I'm going to put in y-axis, let's say Poisson.pmf. I'm going to put in x, comma, and lambda, which is basically the variable. Okay, now plt.bar x, comma, y. plt.title, let's say this is going to be distribution of Poisson. Then I'm going to work with the labels, plt.x label, x label. Let's say here, I'm going to put in events per, let's say, interval, and also plt.y label. Here, I'm going to put in, let's say, density of probability. So I'm going to put in plt.show. That's all. And now you want to run the program. Whenever you run the program, it might show you off as an error. If it shows you off as an error, it is completely fine. You can see we have NP. So here we also want to put in import numpy as NP. Okay, now run the program again and check if it is working or not. If there is PLT, here I'm going to put in import matplotlib dot pyplot as PLT. Now run the program again. If it shows you up this type of data, then you can see it is working. And that is the distribution of poison. So that is the exact amount of time, or at the exact time when the notification, the message, or the email is going to be sent. Okay? And that is exactly when or on which time it will be sent and how much or how many people it is going to reach. Okay? So that is going to be it. Now, the last thing that we are going to learn about in this class is going to be the hypothesis testing. Now, there are going to be two types of testing. One is going to be one sample, and the second one is going to be two sample. Now, I'm going to make sure to keep it very simple. First off, we have to understand what is hypothesis testing. So, hypothesis testing is basically done when you basically want to, let's say, claim that any data is statistically true, but it goes through decisions and also conditions. So there are specific steps of hypothesis testing, such as null hypothesis, then there is alternative hypothesis, then there is significance level, the running the test, which is getting the p-value, and also you have to reject HO, which is p lesser than alpha. Now p basically is going to give you out the test result, okay, which is basically the probability. So I'm going to create more Python file over here. Let's say I'm going to put in, let's say, one sample. Okay, so over here, as we want to work with one sample, so there's going to be specific data and there's going to be specific values. I'm going to create the data over here, but you can work with it later on. Okay, so first off, I'm going to put in from scipy.stats. I'm going to import the test, let's say one sample. Now you might think, why is it not appearing up? It will not, don't worry. I'm going to put in sample equal. Now this is exactly where you want to put in your data. 38, 41, 53, or 54. Going to put in, let's say, 50. Then I'm going to put in 61. Then I'm going to put in, let's say, 49 at the end. Now, the next thing that I want to do is I want to get the average value. So here I'm going to put in p mean. So p mean is going to be closer to 50. So here I'm going to put in t stat underscore, and also I'm going to put in p underscore value. Okay, it's going to be equal to, let's say, t test 1 or test 1, just like this. You can also put in t test like this. T test 1 sample, and I can also put the exact same thing. So we have this over here. Instead of that, let's say t test sample 1. I'm going to put in the exact sample that we are working with, and also I'm going to put in the p mean value. Now after that, we want to print out specific statistics. So let's say double quotation, let's say t stats, comma, I'm going to put in t stat over here. Also at the same time, I'm going to make sure to put in a colon so it just distributes better. Going to put in print, let's say over here, probability dot value, comma. Here I'm going to put in p underscore value. After that, I'm going to put in if p value or p mean, whichever data you are working with. So we have p mean, and we have this p value over here, which is basically placed over here. So p mean is going to be lesser than a specific float value, such as, let's say, 0.06. So if this value is lesser than 0.06, I want to print out, let's say, reject H0. Now you might think, what is H0? So H0 is the null hypothesis. So basically means that I want to reject the no difference value. Reject H0, colon over here. And after this, I'm going to cut this off. I'm going to put in there is a significant difference in your dataset. And if it doesn't meet up the criteria, else I want to print out, let's say, failed to reject H0. That's it. Okay, so I'm going to run the program. It might show you off as an error, but if it doesn't show you up as an error, it will give you out the t statistics and also the probability value. And it can say, or it is saying, failed to reject H0. Now, why is it showing you it is failing to reject H0? Is that the p-value or the p-mean value is a bit higher. Okay, now let's say I can work with 5. If I run the program again and check this, fail to reject H0, because this is basically not the mean value. The mean is going to be lesser than, let's say, close to 40 or 45. Okay, so if your p-value is lesser than 0.05, then the results are statistically significant. But if it is not, the results are not significant. Okay, let's say if I put in 45 and if I run the program, you can see fail to reject H0. Okay, so that means your data is not significant. And obviously this is a random data. So obviously when you are creating or preparing for your machine model or machine learning model, obviously you're going to be working with data which is going to make sense and is going to be significant. Now, as we're done with the first one, let's show you the last thing in this class, which is going to be 2 sample t-set. So how are you going to work with it? Let's create the last Python file that I'm going to show in this class. Let's say 2 sample. Okay, so here I'm going to put in from scipy dot stats. I'm going to import t-test. Let's say here I'm going to put in int. Okay, so let's say x is going to be equal, let's say 56, 61. Here I'm going to put in 59. I'm going to put in 63, and I'm going to put in 58. That's done. On the y-axis, I'm going to put in, let's say, 51. I'm going to put in 53. I'm going to put in, let's say, 50 over here. I'm going to put in 54. I'm going to put in, let's say, 52. So we have all of the data. So as we are working with 2 values, there's going to be t-stat. There we go. t underscore stat, and then I'm going to put in p underscore value. There we go. So it is going to be equal to t-test int. Now, as there are individual ones, one is going to be x, and the next value is going to be y. So I'm going to print out each and every one of them. So the first one is going to have the t statistics, comma. I'm going to put in the t-test or t-stat, and also for the p-value or the probability density, I'm going to put in probability value. Here, I'm going to put in p value just like this. You can cut this part out if you want to, but you can run the program just like this. And you will see we have the t statistics and also the probability value. Okay? So that is all for this class, and hope you understood about everything. If you are still facing any problem, or if there's any question, feel free to ask me anytime. I'm always there to help you out. Now, let's get to the summary. So what we have learned in this class is about normal, Poisson, and also binomial distribution. When are you going to use them in machine learning? How you can plot them and distribute them in Python. And also, we have learned about one sampling, two sampling, and also hypothesis testing by decision rule using the p-value and also t-stat. Okay? So without any further ado, let's move on to our next class of AI, machine learning, data science, and big data analysis. Welcome back to our new class of AI, machine learning, data science, and big data analysis. The topic of this class is going to be correlation and covariance and linear algebra for machine learning. Now, you might think, why are we going to need correlation, covariance, and also linear algebra for machine learning? So, to make it clear, or to just give you the short, let's say, term about why is it important, is because when you want to find out the relationship between variables, let's say your data, you have to use correlation and also covariance. Another thing is that whatever data you're going to get as the outcome, that is also known as a vectorized data, because that is super accurate. So, to do those mathematical operations with your data, also finding out the relationship of your data, you have to use vectors, matrices, and also dot products. Well, in my previous classes, I've shown you everything that you need to know about Seaborn, Matplotlib, and also a lot of other modules to visualize your data. So, there is a specific algorithm in Python and also for machine learning is that you need to use linear regression, also PCA, neural networks, to make sure to create your machine learning model. So, that is exactly why this class is going to be very important for you if you want to advance more in these cases. So, without any further ado, I'm going to show you a couple of concepts, and I'm going to explain a lot of explanation and information about this class before we get into our practical part of this class. So, make sure not to skip any part, as it is going to be very important for you in the long run. So without any further ado, first off, I'm just going to open up a canvas so I can show you the formulas that is going to clear out your concept. So first things first. Just like I said, this class is going to be very important. Now, if you have no prior experience with these type of things, or let's say these type of processes, it is completely fine, because I'm going to explain everything and I'm going to summarize it so you can get a better understanding about how you can process your data. So first of all, I'm going to cover up covariance. Now, covariance is basically a process how you're going to operate and measure two variables with the change together. Now, let's say I have a data. Now, another thing that I'm going to do is I'm just going to show it to you over here. So first off, we're going to need a text box, and I'm going to paste it right over here. So this is the formula of covariance. Now, what we basically do over here is that we find out, like, this is going to be on the top. Okay, so there we go. This is on the top, and this thing should be on the bottom. Now, one thing over here that I'm going to do is I'm going to create a line. There we go. So this line that we have over here is going to be the division. Okay, let's say I'm going to reduce the stroke a bit more so it is easier for you to see. So we have covariance. And also, just like I said, you have to find out the relationship between two data or two variables. Now, two of those variables are going to have either different values or sometimes even the similar value. Now, one thing you can see over here, we have x and y. So x and y is basically the covariance or the variable. So one thing you can see over here is we have this x minus x, and then we have the exponent or whatever there is, and then we have y minus that value. So the top thing or the top part that you can see, x minus x and y minus y, that is going to be your positive covariance, because this thing is going to multiply to the top part and also the bottom part. So there's going to be a bit of mathematics over here. Okay, so when this variable x and y is multiplied with the top value, that is known as the positive covariance. Okay, and when this x and y variable is multiplied with the bottom part, which is n minus 1, that is known as the negative covariance. Okay, so one thing, or the last thing you have to keep in mind, is that whatever the value is, but if you get the total answer, or let's say the outcome, to be 0, which is 0 covariance, then you will basically have no pattern and no visualization of data. So you basically have to go through these formulas first to check if there is any relationship. If there is not, then you won't get any data visualization. Okay, and that is basically covariance. Now, the next thing that we're going to learn or understand is going to be correlation. Now, what is correlation? When you basically standardize this formula or this process, or if I just keep it simple, if you standardize this concept, that is known as correlation. But one thing in correlation is that there's going to be only specific 3 types of data, not variables like this. So the only 3 data that you're going to work with in correlation is going to be -1, 0, and +1. So just like I said, if the answer is 0, there's going to be no pattern or no data to be visualized. But if you get a minus value and a plus value as the outcome, the +1 basically indicates a perfect positive. So that means your data is going to, let's say, work with each other perfectly. But if you get a minus outcome or a minus value after this formula, it is basically known, or the -1 indicates a perfect negative. So both of those data will basically have relation, but it is not going to work together in the best way. Okay, so if I basically just come to conclusion and tell you what is the difference between correlation and covariance, is that when you are working with covariance, it basically depends on this x and y variable. But when you are working with correlation, there is a specific data, -1, +1, and 0. Okay? And also, one thing is that in covariance, this interpretation of your data is kind of really hard, because this is mainly used in scientific data. Okay? And when you want to work with correlation, as the data is simple, only 3 values, it is basically very simple. Okay? And when are you going to use both of these? Well, when you are working with PCA, feature variance, let's say in conclusion, scientific data, you are only going to work with covariance. But if you see that there is only one thing that you have to specify or work with, which is featuring the relationship, or let's say the variance of your data, or let's say finding if it is positive, negative, or if there's no data at all, then you're going to use correlation. Now, it might be a bit complex for you to understand right now, but I'm going to go through them step by step. Okay? So, first things first, let's finish up our first thing, or the first part of our class, which is correlation and covariance. So first off, let's open up PyCharm. Now I'm going to create a new project that is going to be exactly the same name. Make sure you are working with 3.12 Python or above. Make sure not to use anything below 3.12. Okay? So just like you can see, I have opened up PyCharm. And you can see my environment has been totally functional. Now, the first thing that we want to do is we want a data set. So first things first, let's create let's say a CSV file. Let's say I'm going to put in example.csv. So in this example.csv, let's say I'm going to put in height, height. Then I'm going to put in, let's say, width. And also I'm going to work with age. So the height is going to be, let's say in centimeters, 160. Let's say the weight or the width of this person is going to be 56. And also the age of this person is going to be 22. Then I'm going to put in, let's say 167. This is going to be 59. And the age is going to be 21. Here, I'm going to just keep incrementing the data or the value. So the width of this person is going to be, let's say, 60. And this person is going to be 24. Then I'm going to put in like 2 more data. Let's say 175. This person is going to be, let's say, 66 in width. And the age of this person is going to be, let's say, somewhere around 28. 179, and let's say I'm going to put in 81, or let's say 71, and also for this person, this age is going to be 31. There we go. So we have our CSV data. Now, let's create a Python file. Let's say corr, that's it. So we can work with correlation and covariance. Now, to complete this class or to make sure that everything is functional, we're going to need a couple of the modules. First things first, pip install pandas to work with our data. And also I'm going to put in numpy at the same time. So both of these are going to be installed perfectly on your device. There we go. This is how it's going to show up. Now, after that, I'm also going to include, or I'm also going to put in Seaborn and also Matplotlib, because those things or those modules or libraries are basically going to help us to visualize the data and to find out our correlation and also the covariance. You will see in just a couple of seconds and how you will be able to find the relationship between those data. Okay, let's wait for a bit. Just make sure you are connected to the internet. There we go. We have NumPy and we also have pandas. To give it another check, I'm just going to go off to interpreter settings. And as this opens up, we have pip over here. And first things first, I'm going to type in import, let's say pandas as PD. I'm going to import NumPy as NP. There we go. So we have both of these. I'm going to make sure to also run this exact same code over here to just update our pip version. Okay. Now, as we have pandas and NumPy, we're just going to wait for a bit, and then I'm going to type in pip install Seaborn. So we are going to use Seaborn and also matplotlib at the same time. There you go. You can see it is going to install a couple of packages, which are basically the font tools. So just wait for a bit until it shows up, and then we're going to also install matplotlib on our device. There we go. It has been installed. I'm going to type in pip install matplotlib. There we go. So we also have matplotlib installed on our project. So as this is done, I'm also going to import Seaborn as SNS. I'm going to import matplotlib.pyplot as plt. Now, the first thing that you want to do is you want to load up the data. So data frame equal, then put in pd.readcsv, open up the parentheses. Let's say I'm going to put in example.csv. Now I want to print out my dataset. Dataset info. Also, I'm going to print out the data frame. Now, first off, let's run the program. That's what you should obviously do all of the time to check if your data is printed or not. If your data does not print over here, then it means that it cannot find the dataset and it cannot be processed. Now, after this one, or after this step, this is exactly where I'm going to show you both of the matrix, which is covariance and also correlation. So first things first, I'm going to show you covariance. Just like I said, it is going to depend on the variables. Now, one thing inside this data set is that there are a couple of variables. Even though this is one data set, there we have height as a category, width as a category, and also age as a category. So I'm going to put in covariance matrix. It's going to be equal to df dot, just put in COV. Whenever you want to find out the covariance, just type in .cov. Now, I want to print it out, double quotation slash n covariance data matrix. So we have this covariance data matrix, and then I'm going to print out cov matrix. If I run the program, you will see something will be printed over here. And you can see everything has been given in such a way it looks like almost a spreadsheet, or let's say a table. We have height, width, age over here. We also have height, width, and weight, age over here. So that is going to be our relation of our data. Now, even though we have specific data applied, nothing is going to show up yet. Because if you want to work with it, you basically have to visualize it using Seaborn and also matplotlib. So we're going to go through that later. Now, the next thing that I'm going to show you is going to be the correlation matrix. So I'm going to put in correlation matrix is going to be equal data frame dot and put in CORR. So CORR for correlation and COV for covariance. First off, I'm going to print it out, backslash, double quotation, backslash, n. Here I'm going to put in correlation data matrix. Here, I'm going to print out the correlation matrix. If we run the program in the same way, you will see this is exactly how it will print it out. Even though you can see over here, we have a lot of different type of data, such as we have 1, we have 0, we have 0 over here, 0, 1 again, 0, 0, 0, and 1. So 3 of the data is going to be perfect positive, and most of them are negative values. Now, perfect negative is this one, which is on the first index. Or let's say not this one, but the other ones are on 0, but not perfect. Okay? Now, to find out the relationship between both of these data and to work to process our data, we have to use, let's say, plots. So I want to use Seaborn to make sure to visualize the data. So plt.figure. Now the figure, I have to define the size of the figure. For that, I'm going to type in fixed size. And the first thing that I want to put in over here, parentheses, let's say 6, comma 4. Now, even though if you want it to be bigger or smaller, it's basically up to you, but I'm just going to use this data. Now, this is where we put in our seaborn. So sns.heatmap. First off, the first data that I want to use is going to be the correlation matrix. So correlation matrix, comma, and then you're going to type in anot equal true. After this, I'm going to make sure to put in a title. So in the title, I'm going to put in, let's say, correlation matrix relationship visualization. There we go. So we have the visualization of this data. Now, the next thing that I want to do is I want to save the figure as, let's say, an image format. So I'm going to type in plt.savefigure, open up the parentheses, double quotation. Here, let's say, I'm going to put in correlation dot, let's say I'm going to put in PNG. Now after that, first off, I want to show the data too. So put in show. So after this, you just want to run the whole program. Now, if it shows you off as an error, then it means it is not working. But if it shows you out something like this, there we go. So the correlation matrix relationship visualization is over here, such as we have 1, 1, and 1. So all three of these are basically the perfect positive value. And the other ones are all of them negative value. Now, if you also want to work with, let's say, covariance, you can also work with it. So instead of correlation, you just type in covariance. And let's say I'm going to put in covariance in the same thing, covariance. Now you can run the program just like this, and you will see we're going to have data like this. Now, one thing that I have explained to you at the beginning is that covariance does not work with only 3 values. It is basically infinite. It could be minus infinite, it could be positive or plus infinite at the same time. And there is just 0 at the middle. So this is exactly how you can find the data or find the relationship of your data, which is going to be completely positive or negative. That is going to depend on the data set that you have. Now, one thing you can see over here, there is 42 2 times. That means there is going to be a good relation between these two data when these are combined together. And that is basically how Python and these libraries are going to find out the relationship between your data. There we go. We have 24, 24, 27, 27. There's no 54 over here, but we have 36. We have 18, which are basically only singular values. So this is exactly how you can work with correlation and also covariance. Okay, so hope you understood about covariance and also correlation. Now, let's move into the next part of this class, which is going to be linear algebra using NumPy. So NumPy is basically going to have a very important, let's say, influence in this part of the class. Okay, so just like, correlation and covariance, there are also some, formulas that you have to understand. Now, in the same way, you might think, why is it important in, machine learning? So in machine learning, there is going to be a couple of operation. Now, if you've seen my classes up till the very beginning, up till now, you know that in Python, there are different types of operation. There is arithmetic operation, there is comparison operation, there's Boolean operation, and so on. So in machine learning, there are also a couple of operations. And those are, let's say, vectors, matrices, matrix multiplication, dot product, transpose, identity matrix, and also linear transformation, which comes from linear regression. Okay, so how these operations help is basically using neural network, which basically multiplies your matrix and your data, just like we've seen on the figure. It basically multiplies the data and predicts and finds out more possibility of matching up more, giving you out more positive or negative value, or giving you out something, let's say, with no pattern, something like that. Okay. Then if you want to find out, let's say, a normal equation, such as, let's say you want to find out positive values, that is exactly where linear regression comes to help. It basically gives you out a couple of data in such a way where all of them are going to be, or most of them are going to be connected, and give you out an equation. Then you can work with engine values and also engine vectors, which is basically used in PCA. Well, you don't need to go into all of these complex concepts, but you can obviously understand and know more about it. Then there is also another operation which is known to give more space to your vectors. Now you can see, or you will see sometimes, that there are going to be a couple of data with, let's say, 0 and a lot of decimals or a lot of decimal values, which can be almost quite similar or identical, but at some point there is one different value. So if you want to give out more space to your data to find out more differences and to find out the, let's say, intervals between them, you basically use SVM, which is also done by using linear algebra. Then if you want to, let's say, find out pixel matrices, what you basically do is use a process called computer vision. So all of these things basically help you to create your machine learning model to predict more and find out more data and multiply them. So the most important thing that we're going to learn in this class is going to be the vector and the matrix. So vector can also be termed as a list of data, and matrix is basically known as, let's say, double-sided or 2D list of data. Okay, so basically how it looks like is, let's say I'm going to create a text box. Well, so I'm just going to draw it over here. Okay, I'm going to reduce the weight a bit. Let's say I have a variable. Now in vector, it is basically used by something like this. V, our vector, is going to be equal to the secondary bracket, and then you can put in your data, 1, 2, 3. So this is basically your vector data, but this is going to be immutable. So these data cannot change, you cannot replace it, neither you can modify it. Then we have the matrix. Matrix is kind of like, let's say, a range of data, but it is basically defined by A. So A is going to be equal to secondary brackets, and let's say 1, 2, 3, and also 4. So that is exactly how you define your matrix. And the next thing, which is, let's say, optional, but you can learn this too. Now, even though when you follow these formulas or these type of syntaxes, basically what it combines up together is, let's say, a dot product. So how is a dot product used and where is it used? So the dot product is basically also a type of visualization of your data. Okay, I'm going to put it right over here so it is just easier for you to see. I'm going to just reduce the size just like this. There we go. Okay, so the dot product is the visualization of data, but it is basically used in neural network to multiply your matrix, cosine similarity, which is also, let's say, to give more space to your vectors, and also gradient calculation. Okay, and this is basically defined by using A, which is your matrix, and then we have B, which is your secondary variable. Now this is basically equal to, let's say, I'm just going to make sure to, undo this, lambda, and then A, then we have the constant value, B, and then we also have the constant value. Okay, so this is basically how you go through the process of multiplying your matrix. but this is just the base part to find out the variable and the result, which you can use to actually multiply your data. I'm going to group it together. I'm going to keep it right over here. Okay, so here I'm just going to also group it together. I'm going to group this together too. Okay, now the last process to actually multiply your matrix, which is the range of data, which is basically done through prediction or the information that is going to get through the data set. So basically, there is a specific rule of multiplying your matrix, which is inner dimensions need to match. Okay? Now, what is inner dimension? Now, obviously, when you worked with data or even mathematics, let's say in parentheses, let's say I have two parentheses. Now, both of them are multiplication. 2, let's say, into 1, and 3 into 3. Now, which one do you think is the inner dimension? The inner dimension is basically the 1 and this 3, because this is more in the middle. Okay? And another thing is that when you are working with matrix, there cannot be a vast amount of data. Basically, you're working with two data or two variables, and then you're finding out the relationship. Okay? So there's not going to be a lot of data when you work with, machine learning model and also multiplying your matrix. Okay? So these two, 1 and this 3, this one is basically the inner dimension, and both of these need to match. Just like you can see, the first one we have is 1, and on the next parentheses, it's starting with 3. So it will not work. Okay? So this is basically defined by C, which is the, let's say the multiplication of matrix, equal to a variable, which is vector, and multiplied with B. So this is the exact formula of matrix multiplication. I'm also going to keep them grouped up. I'm just going to keep it right beside this. Okay? Now, what are we basically going to do using all of these things? So, in this class, I'm going to compute the covariance. I'm going to find out the correlation. I'm going to visualize both of these data, correlation and covariance. And the next thing, or the most important thing, is that I'm going to show you by working with vector, matrix, dot product, and also multiplication. So let's open up PyCharm and let's get started with this part of this class of, let's say, linear algebra. Okay? Now, another thing is that, just like I said, there's going to be only two types of data. So first off, let's create a Python file. So I'm going to put in COVV. Okay? So both of these files are a bit different. So first off, I'm going to import numpy as np. Now I'm going to create the vector. So vector a, va, is going to be equal to np dot array. Open up the parentheses, secondary bracket. Let's say I'm going to start off with the most basic one, 1, 2, 3. Then I'm going to put in VB. Is going to be equal np dot array. Open up the parentheses, secondary bracket. Here, as we have 3, I'm just going to put in 4, 5, 6. Now you can put in any random number. That's basically up to you. Now let's print out these variables. Let's say vector 1. Here, I'm just going to print them out, VA. And in the same way, I'm going to type in vector 2, colon, is going to be VB. So we have both of these data, so let's just print them out first. So we have those data. Now, we're going to work with dot product. So to find out the dot product, we need a variable. So dot, just type in dot, equal np dot, that's it. Now, va, comma, vb. Now let's print it out. Let's say dot product of our variable 1 and 2. Here, just type in comma and type in the variable dot. So run the program, and there we go. We have the dot product, which is 32. So we have another variable that we basically need. Now, let's create our matrix. Not the matrix, but the matrix. Okay? So, the matrix is going to have A and B. So A is basically going to be equal to np dot array. So open up the parentheses just once and put in 2 secondary brackets. First off, I'm going to put in 1, comma 2. On the next line, do the same thing, secondary bracket, 3, comma 4. There we go. So we have our first array of data. In the same way, let's say first off, put in the parentheses. Here, B is going to be equal to np dot array of data. Open up the parentheses, secondary bracket 2 times. Here I'm going to put in 5, comma 6, secondary bracket 7, comma 8. So this is going to be my matrix. Okay, so now let's print out the matrices. Print out, let's say double quotation, matrix of A. Here just type in A. And I'm going to print out, let's say, matrix of B. Type in B. Now, as we have found out our matrix and also our vector at the same time, you can see we have 1, comma 2. This last indices might be integer or slices. Okay, so what we're going to do, we're going to check out line number 12. So here I'm going to put in comma over here, just like this. Now we can run the program again, and there we go. We have matrix of the data, and we also have our dot product of our vector. Now, as we have these data to be found out or done, this is exactly where we're going to multiply our matrix data. So, just like in the formula, which is C equal to A into B. So type in C equal np dot, type in mat mul. Okay, so matrix multiplication. So first is A, comma, and the second is B. So if I want to print it out, let's say I'm going to put in multiplication of matrix value, or I'm going to put in outcome. That's it. So put in comma and define in C. Run the program, and there we go. We have the multiplication of matrix, which is 19 and 22, and we have 43, 50. That is the value of C. So our matrix has been basically multiplicated. Okay, now you can also transpose the data, which is basically done by A underscore T equal A, and then put in dot, just like this, and put in T. So this basically transposes your data. So if I want to print it out, we basically put in, let's say, transposed data of A, comma, A underscore T. And also, as we have transposed the data, the last thing that you have to basically do is also identify it. So I is going to be equal np dot I. Okay, so it is basically going to identify it. So there are 3 data. So I'm going to put in 3, and then you basically type in print and identifying matrix of the data and multiplied variable. Okay, or you can put in multiplied matrix, comma, and here I'm going to type in I, which is the variable. If you run the program, you will see it has identified it. So basically we have 0, 1, 2, 3, 4. So we have 4 non-visualized data, and 2 of them we have positive data. We have transposed data, which is 1, 3, 2, 4. We have multiplied matrix, and all of them are basically just like this. Okay? So the summary of this class is that you have learned how to run linear regression and basically the actual foundation of, let's say, preparing your machine learning model. And these data that we have, just like you can see, we have transposed, we have multiplied matrix, is basically the data that you need to prepare your model. And these are the data that is basically predicted and possibilities of the data or the variable or the vector. Okay, so basically in the summary is that you basically have created an array of data that has been, let's say, pre-processed by Python and also the libraries to create this variable into your learning model. Okay, so thank you for watching this class up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our class projects of this course. Welcome to class project 1. The name of the class project is Optimize a Simple Function Using Gradient Descent in Python. Now, with this class project, I have attached in what tools you're going to require to complete it and get a functional outcome. And also, I have created this class or this class project in such a way so you can follow up 5 simple steps, and also you will know by the end of this class what you're going to learn. So first off, let's get into what tools we're going to need in this class. The first thing that you're going to need is an IDE. Now I have put in, or I'm going to work with PyCharm because that is integrated for Python. But if you want to use VS Code or any other IDE that you're comfortable with and which supports Python, I would suggest you can use it. The next thing that you're going to need is Python 3. Now I'm also going to specify a version which is Python 3.12. Now anything before that version is going to be okay too. But before that version, what happens is that it cannot support the newer infrastructures of the code. Now, even if you have Python 3 or 3.12 and anything above like 3.13 or maybe 3.14, that is completely fine. Now, the libraries or the module that you need to use in this class project is going to be NumPy to handle your data. Then we're going to use matplotlib, which is basically going to help you to visualize your data. And the third optional library that you can use to derivate your verification and your data, or let's say your variable, you can use SymPy. So let's get into these steps. The first step that you need to do is create the project and the file. In step 2, you're going to define the function with the derivative. In step 3, you're going to implement the gradient descent. In step 4, you're going to visualize the optimization movement and you're going to save up the file. Step 5 is completely optional. You can write a short summary file if you want to, but if you don't want to, it's also completely fine. The last thing that you want to do, or that I would suggest you to do, is take a screenshot of your code snippet and also take a screenshot of your, let's say, the image that you're going to create or represent visually by using matplotlib. The outcome of this class project is that you will know how to create a functional gradient descent Python program. You will know how to illustrate the optimal path. You will also get the knowledge of derivatives and also gradients, and you will know how to use a function's value which is decreased by gradient descent, and also a tidy project folder with well-organized files. So, first off, let's open up PyCharm and let's create our project. So, as we have opened up PyCharm, create a new project. Let's say the name is going to be class project 1. Inherit the package, make available to all project, create a custom environment, and press on create. In just a couple of seconds, you will see the project will be created. Now, as we have the project, we're not going to need any, let's say, out data, or let's say anything to download, because you are going to define the function, the derivatives, you're going to visualize the data, everything starting from the code snippet. So let's create a Python file. Let's say the data that I'm going to use, or the Python file, I'm going to name it test, okay? So, as you're not going to be needing any type of data, such as CSV or Excel, or even JSON, so you're going to start off directly from ground zero. Now, open up the terminal, and let's first off import the modules. Type in pip install and type in first off numpy. Hit on enter, and now wait for a bit until numpy has been correctly installed on your device. Now, up till now, I have been installing numpy on almost all of my projects, so it is not going to need any internet connection, because everything that needs to make numpy function properly, every data is already available on my device. Now, let's also install matplotlib. Hit on enter and wait for a bit until everything has been installed. And in a couple of seconds, you will see everything will be installed, like just in a couple of seconds. After that will be done, first off, let's import our first module, which is going to be, let's say, import numpy as np. Then I'm going to import matplotlib.pyplot as plt. Now, just like our second step, we're going to define the function, including the derivatives. So, the function, you have to define it with def. Now, as I want a function, now I'm going to apply the derivatives, which is x to be the variable. Now, here, I'm going to return it with the exponent of that value. So return it x double asterisk, let's say 2. I'm just going to keep it very simple. That is the function. If you want to apply the derivative, type in def, then put in df as the data frame, define the variable, and also in the same way, just get the derivative, which is return and 2 asterisk x. So that is going to be our function and also our derivative. Okay, now let's move on to the next step, which is the third step, which is implementing the gradient descent. Now, implementing gradient descent requires hyperparameters, such as your starting lead or the starting data. Then you're going to learn about, how fast your learning model can cope up with the data, or how fast it can learn. And then you're also going to mention how many times you want it to iterate. Okay? So let's say it's kind of like how many times do you want the program to run. So first thing is my x. X is going to be equal, let's say 4.0. That is going to be my starting lead, or let's say my starting point. Now I'm going to define how fast, or in how many steps my machine learning model can take the data. Let's say learning rate is going to be equal, let's say 0.2. So in every 0.2, or let's say this is the amount of data it can take. Now I'm going to define how many times do I want it to iterate. So I'm going to put in ITR. That's it. ITR is going to be equal to, let's say, 21. So I want it to work for 21 times. Now I'm going to define, let's say, the history of the data. So I'm going to put in history. It's going to be equal. Now, as we don't have any specific type of data, so I'm going to use the variable as x. Now, we're going to put in the loop because we want the program to run 21 times. So for I in range. Now define how many times. So here I'm going to define ITR. Okay, so iterated amount of, let's say, approach. First thing, as you want a gradient, so I'm going to put in grad. It's going to be equal to df. Now the variable is x. X is going to be equal to x minus, I'm going to put in the learning rate, and now I want to multiply it with the gradient. After that, you also want to append the history of the data. So I'm going to put in history dot append. Now the variable is x, so put in x. Now I want to print out the data. Let's say now I want to get the amount of iterated data. So f, let's say I'm going to put in iterated. So open up the third bracket just one time and put in I plus, now how many times you want to iterate, or how do you want it to iterate, is only one per approach. After that, put in a colon. X is going to be equal, third bracket, here x colon, and now I'm going to, let's say, put in 0.5. There we go, f, which is the function, comma. Now f is going to be opened up in the parentheses with the variable, and it is going to be equal to third bracket. Now put in f, open parentheses, as x, after the x, colon, comma, or let's say 0.5f. There we go. That is all that you need to put over here. So this is basically going to show you how close your variable is going to be closer to the minimum of data. If you run the program, this is exactly how it will look like. Okay, but you won't understand anything because it is basically just iterating over and over again. But it is based on the data and the history that you have put in. Now, the last and the most important step of this class project is visualizing your data and visualizing every data that we have over here, and also to check how the relationship between the data is. So, first off, we want to define the data with variables. First off, if you've seen my last class of this course, you know that for preparing the data model or the machine learning model, you need two variables. So in that case, x1, you can put in xs if you want to, but I'm going to put in x1 is going to be equal np dot linspace. There we go. So I'm going to start off with minus 5 value. Then I'm going to put in 5 value. And also, what I want to do is I want to show them how many times do I want this program to run. So I want it to run 500 times. Now, I'm going to put in y1 is going to be equal to the function, and the variable is still x1. Okay, now we're going to define everything with the plot. plt dot plot. Now open it up with x1 as the first or the starting point. Then I'm going to put in y1 as the argument, and also we want a specific label. So the label that we're going to use over here, first off, put in equal. Now after equal, what you want to do is, even though we have the parentheses, single quotation, after that put in f, open parentheses, and then put in equal x, now to the power of, let's say we have exponent 2, so I'm going to put in 2 over here. Okay, now the next thing that I'm going to do is I'm going to put in plt dot scatter plot. Okay, so you can just put in just scatter if you want to. Now we want to validate the history. So type in history of the data, secondary bracket, F open parentheses as H for H in history. Okay, now put in comma, and I put in the marker equal as O. Now after O, I'm going to put in a label equal, single quotation again. Let's say this is where we want to define where or which path is it going to take. So I'm going to put in gradient path. That's it. Okay. After this, what I'm going to do is I'm going to put in plt dot title. Now another thing that you can do over here is you can define the descent path, which can make it look a bit more better. But even though this is just a label, so I'm just going to put in descent path. Okay, this is exactly how it is going to look like. Now I'm going to put in the title. Let's say class project 1 gradient descent. That is exactly going to be the title. Now let's put in the X label and Y label. plt dot X label. Let's say on the X label we want the variable which is X, and plt dot Y label, open up the parentheses, double quotation F, open parentheses, inside put in X, which is the variable. Okay, now plt, now one thing different that I want over here is I want legends. So plt dot legend, open parentheses, plt dot grid. Now open the parentheses and type in crew. And I'm going to save up the file plt dot save figure. Now you're going to put in a name. Let's say I'm going to put in, let's say, gradient dot png in this case. Now I'm just going to put in plt dot show. That's going to be it for this class project. Now you can run the program. When you run the program, this is exactly how it is going to look like. There we go. We have the data like this, but it is the opposite. You can create your, figure however you want to. That's basically up to you. Now the dot trial that you can see is basically indicating your optimization and your intuition. Okay? So this is exactly how your outcome is going to look like. And now you know how to create or how you can work with gradient descent on your project, or let's say even on your work. So thank you for watching this class project up to the very end. And the last thing that you want to do is take a screenshot of this alongside your code snippet and upload it onto our project panel so that we can check however you are progressing with work. So let's move on to class project 2. Class project 2. The name of this class project is building your first machine learning model. So I have attached in what tools you're going to require in this class. I have also attached in the steps that you need to follow, and I made it to be very simple and beginner friendly. And also, I have also given you the outcome of this class project. So, what tools are you going to need in this class? First off, you're going to need Python version 3.12 or like version Python 3.14. I'm not going to suggest you anything below 1.2 because those are kind of outdated, and also it does not support the newer versions of code snippets. Then you're going to require an IDE. You can use VS Code if you want to, and use any other IDE which has Python integrated or supports Python. But I'm going to use PyCharm because this is basically made and built for Python. The libraries that you're going to require in this class is going to be pandas for handling your data. You're going to need scikit-learn for your machine learning model, and also matplotlib to visualize your data. The steps that you're going to follow is going to be importing the libraries and loading up your data. In step 2, you're going to prepare the feature and the label, which is basically the variables x and y. In step 3, you're going to train the model using machine learning. In step 4, you're going to test the model and show the accuracy of your model. And in step 5, you're going to predict for a new person. The outcome of this class project is that you will understand how the machine learning core workflow works. You will know how to split data, train and predict the models, assessing accuracy, and also you will learn how to make actual predictions using machine learning. Additionally, you will also have a machine learning project, which is going to be fully functional and operational at the same time. So let's open up PyCharm and also create our project file. Just as you can see, I have opened up PyCharm. I'm going to name it class project 2. That's it. Inherit the packages and press on create. So just like you can see, I have opened up PyCharm and I've also created a project file. Now, first off, open up the terminal and install the necessary libraries. I'm going to type in pip install, let's say, pandas, scikit-learn. You're going to type in scikit dash and then put in learn. I'm going to type in matplotlib and also numpy. You can hit on enter. If it shows you off an error, then put in a comma. But if it does not show you something like this, then you're going to install them individually. So pip install pandas. Now wait for a bit until everything has been installed. Then I'm going to move on to the next installation. Let's also install numpy. Pip install. Let's first off install scikit-learn. Wait for a bit until this one is also installed on your device. It's not going to take a lot of time. Let's also install matplotlib. Let's wait for a bit until this is done. There you go. You can see it has started installing it. And the last one, type in pip install numpy. Hit on enter. There we go. So we have all the necessary libraries that we're going to need in this class. So first off, let's create, or I'm just going to put in a CSV file. Let's say here, I'm going to create, let's say, user.csv. Okay. Now, I'm just going to paste in a couple of data that I already have. You can use this. I'm just going to give it in my resource file. You can use it whenever you want to. Now, let's create our Python file. I'm going to name it test. Okay. So we have the CSV and also we have our test file. So let's start off by importing the libraries and the data. So first off, import pandas as PD, import sklearn dot model. You can put in selection if you want to, because we want to test our data. And I'm going to put in import train test. And I'm going to make sure to put in split. So instead of import, I'm going to put in from sklearn train test split. Now here I'm going to put in from sklearn. Now I want a linear model. So there we go. We have a linear model. I'm going to import logistic regression. And from sklearn again, I'm going to get metrics. And I'm going to import the accuracy score. And the last thing to visualize our data, let's use matplotlib. .pyplot as plt. Here I'm going to put in df.pd.read CSV, double quotation. Now I'm going to use user CSV and we want to print it out. Print df.head. Okay, run the program and check if it is working or not. If it is working, that means you're good to go. Now, in my last class of this course, you've known in machine learning, you're going to need two variables to find out the relation and also to find out how you can make them work properly, either positive, negative, or no data. So x is going to be equal df, secondary bracket 2 time. First off, I'm going to put in age, and after age, put in comma. Then I'm going to need an income source. After that, let's put in y, df, secondary brackets. Here, I'm going to check out the third, which is by. Okay, so here I'm going to put in by. Now I'm going to train my data. So x underscore train. Okay, comma, x underscore test, comma, y underscore, let's say first off I'm going to train the data, and y underscore test is going to be equal the train test split. Open the parentheses, x is the first variable, y is the second variable. Now you want the size of the text. Okay, so first off I'm going to put in test size, let's say 0.3. And I want a random number because I have to predict the value. So I'm going to put in a random state, which is going to be 40. Okay, so after that, we are done with our second step of preparing our feature. The third step of this class project is going to be training the machine learning model. So here I'm going to put in model equal. The model that we're going to use is logistic regression. Logistic regression. And I'm going to put in model dot fit, open up the parentheses, x underscore train. First off, train your data. In the same way, I'm going to make sure that y value is also trained. Now I'm going to test the model and check the accuracy. So I'm going to put in prediction is going to be equal to model dot predict. Okay, so the first model we want to predict is going to be the x value. So x dot r underscore test. Here, I'm going to check the accuracy. So I'm going to put in ACC is going to be equal accuracy score. Now, as this is for y, put in y underscore test. And also, we want the prediction of the x test. So I'm going to put in prediction. Now, let's print them out. Print out, let's say, prediction of our data frame, comma. Now I'm going to put in prediction, going to print out, double quotation, let's say the actual base value, comma. Now here, I'm going to visualize them in a listed format. So I'm going to put in list, then I want the y test. And the last thing that I want to print out is going to be the accuracy of the model. So I'm going to put in print, let's say, accuracy of the predicted model, comma. I'm going to type in ACC. So basically we're done almost. Okay, so if I print this out, this is exactly how it will show up. But we want to visualize it and predict for a newer person. So let's say NW underscore data equal, let's say I'm going to have, let's say a different type of data. Let's say 45, and also the next value or the next variable is going to be, let's say somewhere around 50,000. Okay, so this is going to be, let's say, the age of this person is going to be 45, and the income of this person is going to be 50,000. So how much is this person going to buy? So based on the data, and now as we have our history, I want the result. Result is going to be equal model dot predict. Now I'm going to put in NW data. Now if this person, or based on this data, is this person going to buy or is this person not going to buy? So I'm going to put in print. I'm going to put in, let's say, a condition. Is this person going to buy? Question right over here. Okay, so after this, I want two answers in a Boolean value. You can see we have 0 and 1. So 1 means that person has bought it, but 0 means that person did not. Okay, or it could be the opposite. If it is 0, it could be yes. It could be 1 if it is a no. Okay, so let's say I'm going to type in yes. I'm going to type in just yes if result is, let's say, 0 and completely equal to 1. Else, it is going to say no. So we basically have this run the program, and you will see in just a couple of seconds, you can see there's going to be a warning because X does not valid feature names. Okay, so it does not feature any name. Okay, but we want to visualize the data in, let's say, a visual format. So I'm going to put in plt dot scatter. Here, open up the parentheses, data frame, starting off with the age, comma, data frame, let's say the income of this person, and also now as I want the whole data and the relationship between age and income, so for C is going to be for matrix multiplication, I'm going to put in df, secondary bracket, and I'm going to put in, let's say, buy, if this person bought or not. So plt dot x label, it is going to indicate the age of the person. Plt dot y label, it is going to indicate the income of the person. And plt dot title, it is basically going to show you the decision of buying based on the person's data. Okay, now I'm going to put in plt dot show. That's all that you need to do. You can run the program, but sometimes it might give you off as an error. Just run the program first. If it gives you out a data just like this, then it is showing that it is working properly. Now, even though you got the warning because there is no name, but this is showing that the person did buy the data and the accuracy is completely 1, which means that it is completely positive data. Okay, so this is exactly how it is going to work. Now, the last thing that you want to do is take a screenshot of the snippet, just like this. Keep your, regression line at the side and upload it onto our project panel. So hope you understood about everything in this course and also this class project. If you still have any confusion or any question about any part of this class, feel free to ask me anytime. I'm always there to help you out. So hope to see you guys in my next course.